Hi, welcome to Mastering DevOps, the video course by Pack Publishing. My name's Dave Mango, and I'll be your coach throughout the course. Together, you and I are going to explore DevOps. We're going to talk about what it is, and we're going to find out what it means to and for its practitioners. Before we really get started, a little bit about me. I have more than 20 years of systems engineering experience, and I've done it at companies both large and small. Before I was a systems administrator, I was a developer. So I actually have a background in both disciplines, and that's helped me a lot over the course of my career. I've led multiple transformations to operational maturity or with DevOps maturity at different companies. So small companies like Terracotta, or large companies like Cable and Wireless and Salesforce, where I architected monitoring, configuration management, DNS systems, things like that. I love metrics, monitoring, and scalability. Those are my three favorite topics in computer science and my three favorite topics at my job. So I'm lucky because I'm privileged enough to work in all three at my current job as Director of Operations for Librado and Papertrail, which are metrics and monitoring companies. And lastly, sometimes I blog about technical topics or DevOps at tech.mango.com, or feel free to reach out and give me feedback or ask questions about the course or about DevOps in general at Dave Mango on Twitter. And I try to follow that as closely as I can. So this is video 1.1, the course overview. In this course, we're going to take a look at what is DevOps? Why do I even care? What's so important about it? We're going to look at the CAMS model, a way of looking at DevOps and all the different components that make up DevOps thinking. We're going to talk about establishing a DevOps culture, things that you can bring to your organization to change to adopt a more DevOps culture. We're going to talk about configuration management and automation. And those sections will have lots of code examples. We'll be firing up instances in the Google Cloud or in the Amazon Cloud. We'll be trying out different things to see what we can learn. Then we'll talk about measurement. Again, we'll have lots of examples. We'll set up systems that allow us to take in metrics and things like that. And then lastly, we're going to talk about sharing as a part of the DevOps model. And we'll talk about why sharing is such a crucial part of what we're trying to accomplish in DevOps. And the last part of the course, we'll have some next steps where we talk about more advanced topics in DevOps and places that you can find resources if you want to explore different areas of DevOps. So why is this all so important? Well, Gene Kim and others do a survey every year. And in the 2015 DevOps survey, they discovered that, quote, for the nearly 800 organizations that provided a stock ticker symbol, we found that the high performers had nearly 50% higher market capitalization growth over 3 years, indicating that DevOps is great for IT performance as well as organizational performance. So that's our goal here. Our goal is to create high-performing organizations. And we know that through DevOps, we can actually create these high-performing organizations without burning our people out. By taking care of the people that work for us, by taking care of the people that work with us, by being mindful of other parts of the organization, we can actually create high-performing teams, departments, organizations. Probably the best example of this was in 2009 at the O'Reilly Velocity Conference. And for some, this was the birth of the DevOps movement. Paul Hammond and John Allspaw gave a talk called 10 plus deploys per day, Dev and Ops Cooperation at Flickr, where they talked about how they did deploys at Flickr. This was 2009. Doing 10 or more deploys a day was complete and utter insanity. Nobody had ever talked about doing something like this. Organizations at that time were happy if they were doing deploys quarterly, or maybe if you were really, really amazing, you were doing it monthly. Weekly was just almost unheard of, and doing multiple deploys a day, Who could do such a thing? This talk was truly earth-shattering, and it gave birth through circumstances that involved other people like Andrew Schaefer and Patrick Dubois, who's known as the godfather of DevOps, gave the birth to a worldwide movement of people who are practicing the kinds of techniques that were necessary in order to do 10 or more deploys a day. Dev and Ops, maybe DevOps, cooperation at Flickr. And you can see the URL for this talk on the bottom of the slide. So, in this course, it'd be helpful but not required to have a programming background because, like we said, in the automation sections and things like that, you're going to have to be able to write a little bit of code at least to be able to try some of the examples and to modify them for your own purposes. So you might want to brush up through some pack publishing books or video courses, etc. It'd be great to have some relevant work experience on an IT team because we're going to be talking about real world problems that people bump into every day on IT teams. And so some familiarity would be helpful. And lastly, it's important to bring a systems thinking approach, to be able to look at an entire system as a whole instead of just the things that are right in front of us. And we're going to talk a lot more about systems thinking and why that's important for DevOps. So, by the end of the course, you should have a deep understanding of DevOps. You should also have an understanding of how to bring to your job, your team, your organization, the things that you've learned in order to create a high-performing one. I'm really looking forward to going on this journey with you, and together, you and I are going to learn all kinds of great things about how to create a high-performing organization. See you there. Hi, welcome to Section 1. What is DevOps? In this section, we're going to talk about what DevOps is. We're going to talk about how to think about it, and throughout the course, we're going to continually be referring back to this section as it sets the foundation for how we even think about DevOps. We're going to take a look at, is DevOps for me? We're going to talk about Gene Kim's 3 ways. The first way, systems thinking, looking at the system as a whole. The second way, feedback loops, where we take feedback from our system and put it back into the system to get better. We're going to talk about the third way, the culture of experimentation, what some of the highest performing organizations out there do as part of their normal culture. And then we'll talk about the principle of Kaizen, the principle of self-improvement. This video is DevOps for me? Hopefully by the end of the video, you'll decide that the answer is yes. In this video, we're going to take a look at DevOps, the buzzword. It's everywhere. We'll talk about why should I care? Like, what is the point of actually implementing DevOps? And finally, we'll close with the software development factory, a way of thinking about the way that we do our work, a way that we think about how we develop software that will enable us to actually implement all these different kinds of DevOps practices we'll be discussing. One can scarcely open up a tech publication without seeing DevOps written somewhere. There's DevOps champions, there's DevOps culture, there's all kinds of articles about that. Not only can you read about it, but there's conferences you can go to. There's the DevOps Enterprise Summit, there's DevOps Days, there's Velocity, and there's even books about it. There's the Phoenix Project, there's Beyond Blame. There's all kinds of different resources out there that'll enable us to learn about DevOps. But why? Why is there so much press about it? Why does everybody care? Well, if we refer back to the DevOps survey that we talked about earlier, the one that's run by Puppet Labs, there have been a number of different results that have come out of the DevOps surveys over the years. One thing that they've observed about people who practice DevOps is that they can deploy their software 30 times more frequently. And when they do, they can do it 200 times faster. Remember we talked about Paul Hammond and John Allspaw speaking at Velocity about 10 or more deploys a day at Flickr? This is it. This is being able to deploy more frequently and faster. Not only that, when they do these deployments, they have 60% fewer service disruptions, fewer failures when they're doing deployments. And if they do have a failure, they can recover 168 times faster. So think about that. Organizations that practice DevOps deploy more frequently, they deploy faster, and they have less problems when they do. And if they have problems, they can even fix them faster. That's pretty great. That is something that I would want for my organization. And having that capability has real benefits for our business. Companies with high-performing IT departments are twice as likely to significantly exceed their targets for productivity, market share, and profitability. More profitable companies from practicing DevOps. And job satisfaction is the #1 predictor for high organizational performance. So if you practice DevOps, you are going to have high job satisfaction because that's correlated with high organizational performance, and you're going to be more profitable, which will probably enable more job satisfaction, which will enable more profitability, which will enable more job satisfaction. It's a virtuous cycle. That's what we're talking about. So that sounds great. I want to do this. I want DevOps. But what is DevOps? Well, I say that DevOps is a collaboration between development, operations, and other teams in the organization with a recognition that we're tasked with achieving common business goals. The point of our business is the same, no matter what part of the business that we're in. We're all trying to achieve common business goals. So we need to work together to achieve those goals. One way of thinking about it is a factory, right? A factory, in this case, a cheese factory, their job is to make cheese. So how does that happen? Well, they have a process, and it's very easy to see on a factory floor what the process is, right? We have the milk that's coming in, we have all kinds of flavoring or whatever, we have to make the cheese, it has to go through this assembly line after the cheese is made, it has to be packaged, it has to be sent out the door, because ultimately, what's the goal of the cheese factory? It's to get the cheese into the hands of our customers. That's what they want. That if we don't sell the cheese to our customers and they don't buy it, then we don't make any money. So what's the point of actually having the factory? And anything that gets in the way of actually delivering that cheese to the customer, whether it's through the actual delivery with the trucks, or if it's the supply of the milk, or if it's a breakdown on the assembly line, those are all things that get in the way of the goal of the factory, which is to get the cheese into the hands of our customers. And it's the same thing when we work in IT. Another way of thinking about this, right, is maybe that's development on the left and operations in the middle and production on the right. And what do we have to do? We have to get our software out the door and into the hands of our customers. If I'm running software as a service, I need to be able to go as quickly as possible from a feature that I've decided that my customers need until that feature gets into the hands of our customer. That distance, that amount of time has to be as short as possible. If there's bottlenecks in the system, that causes problems. That causes us problems with getting the software into our hands of our customers. That causes problems with getting the cheese out the door. If development is having trouble with their virtual machines, or operations is having performance problems, or the software keeps crashing, or any of those things happen, they're going to impede the flow of the software from the beginning of the system to the end of the system. And that's a problem. And thinking about our jobs in the context of a factory, thinking about the context of moving the software from the beginning of the system to the end of the system as quickly as possible, this fundamental change, that's the key to enabling a high-performance organization. A high-performance organization looks at this problem and figures out how do we do this as quickly and as safely as possible. So the way to actually examine this formally will be to talk about the 3 ways. And in the next video, we're going to talk about the first way, systems thinking, one of the most important concepts in DevOps. Hi, welcome back. In this video, we're going to take a look at the first way, systems thinking. This is the theory behind our idea of optimizing flow through the factory. In this video, we're going to take a look at the first way. What is it? What do we mean when we say the first way? We're going to look at examples of the first way, and then we're going to talk about some barriers to success with the first way and how you can combat those. The idea of the 3 ways comes from a blog post by Gene Kim called The 3 Ways, The Principles Underpinning DevOps. Gene Kim was the CTO of Tripwire, and now he studies high-performance organizations. He defines the first way as this: systems thinking, trying to move product through the system as quickly as possible, from the left to the right. Faster is better, just like in the factory. The important thing to think about with systems thinking is we're thinking about the system as a whole, globally. We always want to do global optimization of the system. The problem with doing local optimizations without thinking about it globally is if I make my work center go faster, but downstream work centers can't handle it, if development can ship bits faster, but operations can't get those bits into production, then I actually haven't made the system faster as a whole. And that's what I'm trying to do. I'm trying to make the system faster as a whole. Local optimizations without looking at global flow is a problem. So the outcome of the first way of trying to always make the entire system go faster are 3. The first outcome: never passing a known defect to downstream work centers. If I pass a defect to a downstream work center, how is that optimizing global flow? It just means I'm passing the problem to somebody else, and they're going to have to deal with it. And that's not a goal of the first way. The first way, we want to optimize globally. Another outcome is never allowing a local optimization to create a global degradation. Just like we talked about with development and operations. We don't want to be able to go faster producing cheese, but not be able to package it. We don't want to be able to go faster developing software, but not actually be able to release it. Those things don't help with the global optimization of flow through the system. What we're always trying to do is increase flow. That's our goal. One of the best examples of being able to increase flow is continuous delivery, right? Continuous delivery, which we'll talk about much more in depth later on in the course, every piece of software that's checked in is automatically tested. It's automatically put through a pipeline of testing. No humans have to get involved. No one has to press a button. It's simply the act of checking code into the repository. And then, once that code is checked in, we can have a series of tests that run on it. And the faster we can get that software from beginning to end is the first way, right? That is optimizing the flow from beginning to end. And if we take continuous delivery one step further to continuous deployment, meaning at the end of the continuous delivery pipeline, if the software is blessed for production, it's passed all of our tests, it's met the acceptable level of quality, in continuous deployment, we're actually going to deploy that software to production automatically. If we're just doing continuous delivery, that doesn't happen. That actual continuous deployment is even more of moving our software from beginning to the end as quickly as possible, because the work doesn't stop. It actually goes all the way into the hands of our customers. And there can be all kinds of things that happen inside of our continuous delivery pipeline. Lots of different kinds of testing, quality testing, security testing, all kinds of things can be done in there. But no matter how much testing we're doing, we're always going to try to look to do that as quickly and as safely as possible, right? High quality. We don't want to pass known defects to downstream work centers. Passing a bug out into production that we know about that we're going to have to go back and fix is not optimizing our global delivery. So this idea of balancing speed with quality is high performance, right? If you can deliver high quality at high speed, then you're a high performing organization. This is what DevOps is all about. And it has to be sustainable as well. Burning our people out, making it so that they aren't performing at their highest level because we're overworking them, that's not going to be a high performing organization, right? That's going to be an organization that is up and then it's down and then it's up and then it's down, depending on at what stage in the cycle of burnout their people are. And we all know that people who are burned out always work much less productively than people who are actually excited and rested and ready to do their jobs. So this idea of taking care of people is even fundamental to the idea of DevOps. So what are some barriers to the idea of the first way? Well, the biggest barrier that I've seen are handoffs. Handoffs are killer to flow. Handoffs between functional areas or groups are the places you most likely see this. And in the old way, when we used to do waterfall, it was really easy to see these things in the Gantt charts, right? You would see network engineering hand something off to systems engineering, and people have to wait for that to happen. The handoffs are where the work stops. And this is why cross-functional teams are actually so much better, because they have all the tools that they need to be able to deliver the software from the left to the right, from development all the way into production, because they have those members on those teams. They never have to wait for another functional area. They never have to worry about handoffs. So if I do have this idea of handoffs and I want to figure out how to go faster, how can I do that? Well, one technique is called value stream mapping. And in value stream mapping, we look at the flow of work through the system. We look at where the time is spent, where we're creating value, and we're wary of local optimizations. We need to do bottleneck analysis in there. We want to see where the work is being backed up. And if we look at this entire system and we map it out, then we can go and maximize throughput. We can apply resources to the areas that need to go faster in order to maximize global optimization of flow through the system, because speed is important. Speed is the new currency of business. Speed is more important than other things like cutting costs because it costs less to go fast. If I can go fast, that makes me better able to compete with my competitors. We call it lead time. Lead time is this idea of going from idea to production. We want to get the cheese or the materials all the way to product as quickly as possible. In software, we want to go from the idea of what we think that the customer needs into our customer's hands. And if your lead time is faster than your competitors' lead times, then you can always outpace your competitors. You can always outpace your competition, and that's going to make you more successful. That's going to allow you to capture more market share. That's going to make you more profitable. So speed, the goal of the first way of DevOps, is super important. As an example of this, Courtney Kistler, who's the VP of e-commerce and store technologies at Nordstrom, was speaking at the DevOps Enterprise Summit. And what she said was, our DevOps journey started when we stopped optimizing technology for cost and instead started optimizing for speed. At Nordstrom, they were implementing the first way of DevOps. That's why they started with the first way. It's right at the beginning. And that's where you and I are right now in our discussion of DevOps and in our journey. We're at the first way, maximizing throughput through the system. In the next video, we're going to talk about the second way of DevOps, about feedback loops, and how that allows us to push even further on our DevOps journey. Hi, welcome back. In this video, we're going to look at the second way of DevOps, feedback loops, which is our follow-on to the first way of DevOps, optimizing flow through the system. Just like in the first video of the three ways, we're going to look at the second way. What is it? We're going to look at examples of the second way, and then we're looking at barriers to the second way and what we can do about that. Feedback is critical. Nobody is perfect. Nobody will ever be perfect. Feedback is how we get better. The goal of the second way is to shorten and amplify feedback loops. We want to take signal that we get from our system and feed it back into the beginning of our system, or wherever we need to feed it back into our system in order to allow us to get better. Because we're always trying to get better as an organization, or as a business, or as a department, or any kinds of component of our business. And feedback is how we actually do that. It's the signal that tells us how to get better. Some examples of feedback would be measuring throughput of work through the system. If we measure that and we can take that feedback from that measurement and feed it back into our system, then we can do optimizations like we're talking about in the first way, optimizing the flow of software through the system. If we know how long our cycle times are or our lead times are, then we can try and shorten those using feedback. We can look at page load times. There have been numerous studies that have shown that faster page load times makes happier customers, more engaged customers, and gets people more sales of their product online because customers don't have to wait. We can take the feedback of that signal and make it so that our page load times are faster, and then we can have happier customers. We can look at, am I even building the right thing, right? If we don't build the right thing for our customers, we're not going to have customers for very long. If you've ever read The Lean Startup by Eric Ries, you know that Eric advocates continually running a series of A/B tests, a series of tests that give either choice A to the customer or choice B to the customer, and we see which choice, A or B, makes the customer respond in the way that we actually are looking for the customer to respond. We're going to take feedback from our tests and use that to determine whether we're going to deploy A or deploy B. Is the button going to be red or is the button going to be green? Feedback drives our business plan, and therefore it drives our success. We can look at metrics. We can look at metrics on systems or on servers or on network or on storage. We can look at metrics about how well our unit tests are passing or failing, how well our integration tests are passing or failing. And we can take that information that we get from those things and feed that back into the optimization of our system, right? If we have lots and lots of failures on our unit tests, maybe we're not doing something correct in development, and that's why we're having so many failures. Not only can we look at systems kinds of things like that, like CPU and network, but we can also look at our key performance indicators, our KPIs. We can look at things like revenue. We can look at gross profit margin, things like that. Those are also things that are super important. More profit, better business. So let's measure those kinds of things and do whatever we can with that number to be able to raise our gross profit margin. This all ties very well into the first way with key performance indicators, thinking about things from a system perspective, thinking about the system as a whole. We can get feedback from postmortems or learning reviews. If we have an outage or we have something that went really well, we can look at it and say, what went right? What went wrong? We can actually take that information that we collect during those learning reviews and feed that back into the system. That will allow us to do all kinds of things like shorten our mean time to recovery, our MTTR. If it took somebody a really long time to be able to build a replacement system when something failed, then we have to figure out ways to be able to make that system building even faster. We're going to look at that part of the system. We're going to look at the amount of time it took to build that server and figure out ways to do that faster, whether it's cycle times, lead times, mean time to recovery. Those kinds of things are easy to fix when we spend time looking at it in a learning review or what some people would call a postmortem. But what if we don't see improvements? What if I'm measuring all kinds of things, but I don't see my lead times getting faster, or I don't see my mean time to recover getting faster? Well, maybe we're measuring the wrong things, right? Maybe CPU is not the right thing to measure. Maybe KPIs are the things that are more important to measure. If I deploy something out to my website and my customers are calling in like crazy to my customer support line, it doesn't matter if I'm like, hey, look, my CPU utilization is really low on these servers, so therefore everything must be fine. No, everything's not fine. Our customers are calling in to customer support saying they can't use the website. There's a problem with the website. So it's really important that we measure the right things. Do you remember the Twitter fail whale? That was because Twitter was having problems. I worked somewhere, not Twitter, where they only measured page load times. They never looked at downtime like Twitter had with their fail whale. Downtime wasn't important to them. Well, if the site is often down, it doesn't matter what your page load time is when the site is up, because your customers aren't going to be able to use your website during those times that they're down. You can't throw that data out and ignore the fact that the site was down. You have to include that in your measurement. So in their case, they eventually came around to this idea that strictly measuring page load time when the site was up was not enough. But that's an example of needing to measure the right things. If our customers aren't happy, it doesn't matter if we can point to some metric and say, hey, this thing is great, because we're not going to have customers for very long. So the outcomes of the second way are 3, just like with the first way. The first outcome is understanding and responding to all customers, internal and external. Having that feedback enables us to understand and respond to our customers because we know that there's something happening that we need to respond to. Another outcome is shortening and amplifying all feedback loops, making sure that things are as quick as possible, shortening, and as visible as possible, amplifying. And last is embedding knowledge where we need it. We need to make sure that the people who are operating the site or developing the site or involved in any kinds of things that we're going to do in our software development have the knowledge that they need available to them, because what's the point of getting feedback if you don't know what to do with it? So we need to embed knowledge of what to do with this feedback where we need it. If you're really interested in some of this, I recommend you check out The Lean Startup by Eric Ries, where he talks a lot about continually taking feedback from our customers and using that to drive your business. In this video, we looked at the second way, shortening and amplifying feedback loops. In the next video, we're going to look at the third and final way of DevOps, where we take the benefits of our system optimization, we take the benefits of our measurement and our feedback, and we're going to put them all together into what I think is the most fun part of the 3 ways. And the third way of DevOps, the culture of experimentation, is the culture that the most revered tech companies in the world thrive on. See you there. Hi, welcome back. This video is about the third way, the culture of experimentation. In this video, we're going to take a look at the third way. What is a culture of experimentation? And just like with the first and second way, we're going to look at examples, and then we're going to look at some barriers to success. So the third way. The third way is a culture of continual experimentation and learning. The third way fosters continual experimentation and learning from failure, and understanding that repetition is the prerequisite to mastery. This is where everything comes together from the first and the second way. Continual experimentation, we're going to constantly run experiments on our software, on our infrastructure, whether it's part of a continuous delivery pipeline or something else, because we want to continually run experiments so that we can get better. We want to learn. And we're going to introduce failures. We understand that repetition is the prerequisite to mastery. Just like the old expression, practice makes perfect, if we introduce failures into our system and we practice fixing those failures, then we're going to get better. We're going to lower our MTTR, our mean time to recover. So remember we said in one of the very first videos that they can recover more quickly from failures? It's because they practice. They practice having these failures so they can recover more quickly. So the outcomes of the third way include allocating time for the improvement of daily work. If we want our system to go faster, we need to allocate time for that to happen. We need to be able to make sure that we actually are improving all the time. Creating rituals that reward the team for taking risks. If we want to stay ahead of our competition, we're going to need to make sure that we're always taking risks, that we're always pushing the bleeding edge of whatever we're doing so we can stay ahead of anybody else that we're competing with. And last, introducing faults into the system to increase resilience, lowering the MTTR. We have to do that by understanding that repetition is the prerequisite to mastery. So let's look at this. Let's look at some examples of these outcomes. So allocating time for the improvement of daily work. Google's famous for having 20% time. Salesforce had something called PT on, or paid time on. And the purposes of these programs is to allow their employees to experiment, to try new things, to figure out a way to go faster, to figure out some technology they've never done before. Anything that they can experiment with that will allow them to improve is something that they're actually really interested in. This is this culture of experimentation. Other ways that you can do this is having things like hack days, or maybe you're on a scrum team and you say, in this sprint, we're going to allocate 10 points of time for improvement of daily work. But these are important parts of the culture that help us get better. Creating rituals that reward the team for taking risks is the second outcome. And Google, this is their site reliability engineering logo, is famous for having something called downtime credits. And the downtime credits say that your service can have downtime, and you can use these credits as a way of sort of spending that downtime. For somebody who works in operations, that sounds crazy. What do you mean? Like, I want to have as many nines as possible, right? 5 nines, 6 nines, whatever. I have credits now that I can spend on having downtime. Why would that be? It's because Google has a culture of experimentation. They want their teams to try new things all the time. They want them to take risks. If a team has too high an uptime at Google, they get talked to about that and say, you need to push harder. You need to go faster. They only have a certain number of credits, so they don't want the site to be down all the time or anything like that. But they want their teams to go really, really fast. That's how they can stay ahead of the competition. They understand also, in addition to running those kinds of experiments, that repetition leads to mastery for introducing failure, which was the third outcome. And teams at Google and Amazon, on their site reliability kind of engineering teams, do these things called game days, where they actually introduce failures into the systems. They'll do things like turning off an internet connection, or turn off power to a data center, or introduce flapping with BGP, or all kinds of things like that. Why? Because they want to know, are their teams trained well enough? Do they have all the tools that they need to be able to understand how to fix these problems? Can they handle it? They want to know, are these failures that we anticipated? There's lots of failures that we can think about and say, okay, we are going to do this in this case and that in that case. But introducing faults can often surface things that we didn't even know existed. So they're introducing these faults to be able to see things that they wouldn't ordinarily see just by sitting down and thinking about it. And they want to know what happened. How was it fixed? Why was it not fixed? What are the reasons for all the different components of the reaction that the SRE teams have to these failures? They want to take the outcomes of that and they want to feed back that information into the system to make themselves more resilient and more reliable. Another example of this is Netflix. Netflix has the Chaos Monkey, which is part of the Simian army, that goes around and turns off AWS instances, like pulling the plug on a power of a machine in a data center. They want to introduce failures into the system like that? They want to cause outages? Are they crazy? Well, no. If they expect that the failures are going to happen, then they can build the systems to expect that those failures are going to happen. They actually build resilience and reliability into the systems. The failures are going to happen anyways. You can't pretend that the failure is not going to happen. But if you're prepared for the failures to happen, if you've repeatedly tested, repetition, mastery, remember that? If you test those things, then you can handle those failures gracefully. Another example of repetition leading to mastery is I worked somewhere where they used to try to fail over from one data center to another data center. And the first time they tried to do this, it didn't work at all. The next time they tried to do it, they took the feedback that they learned from the first time and they did it in about 12 hours. The next time, 6 hours. The next time, an hour and 30 minutes. The last time I heard, they were closing in on 5 minutes to be able to switch from one site to another. That's kind of crazy, right? We went from not being able to do it at all to being able to do it in 5 minutes. That's an example of repetition leads to mastery. Practice makes perfect. So barriers to the third way, one would be poor throughput through the system. If our experiments take too long to set up, or our experiments take too long to recover from, or our experiments produce some outcome that we want to test, and we can't get our work through the system to be able to test that, that's going to really hinder our culture of experimentation. And the second way would be an inability to measure success, just like the second way of DevOps. if we introduce failures into our system, but we're flying blind, how are we even going to know that there was a failure? How are we going to know how to fix it? We have to have good instrumentation of whatever we're going to test so that we actually are able to take that feedback and put it back into the system so that we can get closer to mastery. If you're interested in these kinds of topics, there's some links here about the Simian Army by Netflix, and there's a great conference that happens called SRECon, which is all about site reliability engineering. In this video, we talked about the culture of experimentation. We learned that repetition leads to mastery. This is going to be the last video of section 1 when we talk about the principle of Kaizen, the idea of continually improving. See you there. Hi, welcome back. This is the last video in this section, and it talks about the principle of Kaizen. In this video, we're going to look at Kaizen, this idea of continuous improvement, and then we're going to take an example from another high-performing organization, Toyota Motor Systems, who is famous for implementing these kinds of practices. So Kaizen is a Japanese business philosophy focused on continuous improvement. We've talked about it earlier. We know that nobody is perfect, and we know that we can always get better. Even though we know that we'll never achieve perfection, that doesn't mean that we're not going to strive to get as close as we can. In the third way of DevOps, it was a culture that emphasized that repetition leads to mastery. We want to always get better. And that is the idea of Kaizen, this idea of continually getting better, doing whatever we can to do to get better. Kaizen is part of Lean. And Lean, you can see a number of different principles of Lean on the screen right now, of which Kaizen is one. When we talked about Eric Ries's Lean Startup, that was influenced by this Lean manufacturing principle. Manufacturing means that something happens in a factory. We talked about how a factory and our development of software are very similar. These ideas in Lean, and certainly the idea of Kaizen, all fit in very well together to this idea that we're going to get better, and we can do that by simulating the things that would be done in a factory, like better flow and feeding back information in and things like that from the 3 ways. So Lean has an emphasis on a number of things. The first we'll talk about is systems thinking, just like with the first way of DevOps. Another thing that it emphasizes is quality. We don't want to just go fast, right? We actually want to go fast and have high quality. We don't want to pass defects downstream in our system. It emphasizes process control. This is things like automation, things that make sure that whatever we're doing is repeatable and is successful whenever we do it. We want to practice having minimal inventory because that means that we can continually move inventory through the system. So why would we want to have lots of inventory that we've paid for and we're not able to get money from in the hands of our customers? So we want to practice having minimal inventory. And this principle of Kaizen, this principle of getting better all the time. Toyota is really famous for doing this as part of what they call the improvement kata. It is something that they teach their employees. It's something that their management teaches to people who are coming up below them. It is part of the culture of the company to practice this improvement kata, this principle of Kaizen. And everybody is encouraged to contribute to the idea of making the company better, from the executives at the top all the way down to the line workers who are assembling the cars. And these line workers are empowered to be able to do this by having what's called the andon cord. And the andon cord runs next to the line. And if a worker pulls this andon cord, the line stops. And they pull the cord to say that I've thought of a way that we can improve something. And they can take that information and feed it back into the process of building cars so they can build cars better. And every month or year or day, they're improving. They're going to be better than the previous month or year or day. And the andon cord is actually pulled thousands of times a day so that they can feed back that improvement into the system. And this idea is part of the improvement kata. It's part of the culture that is taught at the company. Toyota is so confident in their ability to constantly improve that when people ask them, why would you allow people to write books about how you operate, they're just going to copy what you do. And Toyota says, by the time that book is published, we're going to be so far past whatever that book is describing that it doesn't matter. If people want to implement things that we did ages ago, that's fine, because we're going to be way past that. We're going to be so much better than we were at that time. And even if you could copy the things that they did, even if you could cargo cult those things, it'd be almost impossible to replicate their culture, this culture of improvement, this culture of Kaizen. No wonder they're the world's #1 automaker. If you want to know more about some of these things, you can read about the 3 ways from Gene Kim. I have a blog post about where DevOps is and where it's come from and where I think it's going. And you can also read Eliyahu Goldratt's The Goal, which is famous for looking at the system and understanding how to optimize things like manufacturing. In this video, we talked about Kaizen. And in DevOps, we're always trying to get better, both as individuals and as teams and as organizations. And this is the end of section 1. In section 1, we talked about what is DevOps. We talked about the 3 ways of DevOps, about optimizing flow through the system, about feedback loops, and about a culture of experimentation. And then finally, we've talked about the principle of Kaizen. In the next section, we're going to look at the CAMS model to describe DevOps, a different axis to examine DevOps from. We're going to learn about culture, automation, measurement, and sharing. Let's get started. Hi, welcome back. In this section, we're going to talk about the CAMS model, another vector for looking at DevOps. In the first section, we talked about the 3 ways. And the 3 ways were more about the goals of DevOps, the things that we were trying to set up. The CAMS model is a lot more about the ways of DevOps, the things that we do, the things that we practice in order to be able to have an effective DevOps culture. So we're going to talk about culture. We're going to talk about automation. We're going to talk about measurement and sharing. This video, we're going to talk about the C of CAMS, culture. So we'll discuss the model at first in general, and then we'll get into some examples, some specific examples about culture. So where did this model come from? Well, it came from Damon Edwards and John Willis, who you may know as the hosts of the DevOps Cafe podcast. If you haven't checked out this podcast, I highly recommend it. They regularly have guests who give all kinds of new perspectives on DevOps that ensures that every single week you're going to learn something new. Well, they were looking for a way to describe DevOps in terms of practices. What are the kinds of things that people actually do that make up DevOps? For example, if I want to go fast, what are the practices that enable that? So they came up with CAMS, culture, automation, measurement, and sharing. There was an idea that they might actually call it CLAMS and put a L in for lean. We talked about lean when we discussed Toyota manufacturing, and we already know that many parts of DevOps borrow heavily from lean. But ultimately, they left it out, and we went with culture as the C in CAMS. And a famous expression is, culture eats strategy for breakfast. Well, what does that mean? It means that there's lots of different strategies that we can have if we want to run our business. We can have executives stand up and say, we should do this or we should prioritize that. But strategies are not the same as actually having something being part of our culture. If you look at the DevOps unicorns, the people who are the highest performing organizations in the world, they don't set strategies for how they're going to operate and then wind up with something that's really great. These things are ingrained as part of their company culture. They're just how their company does business. If they're going to deploy a new service and there's certain things that are expected that are part of that service, that's something that's part of their culture. They don't go around and try to figure out whether or not this is something they should do or shouldn't do, or whether this is the current strategy or not the current strategy. This is part of the culture of the company. And things like feedback and measurement, all those other things can be a part of the culture of the company. However, there was trouble at DevOps Days, Silicon Valley, a few years ago. There were open spaces that were proposed, and during open spaces, people talk about things that they want to discuss. And then they're written on a board, and then people go and vote and choose the different sessions they want to attend. Well, John Willis, one of the originators of the CAMS model, went and looked at the board, and the only thing that was on there were tools. Tools, tools, tools about metrics, tools about configuration management. And John was so upset, he almost, not really, but pretended to take the C from the CAMS model and go home. And the community has recognized since then how important culture is to the company, how important culture is to the way that a company works, how important that culture is to the success of the company when they're practicing DevOps principles. And the community has doubled down on culture and now is definitely recognized as the most important part of the movement. And you'll see that if you attend DevOps Days Silicon Valley or any other DevOps Days, and I hope that you do. So what do we mean by culture? Well, we can see things like service ownership could be part of our culture. There could be developers and teams who are responsible for the software that they write. That's part of the culture of the company. We could have hack events. When do teams get together? What do they do when they get together? Are they empowered to solve their own problems? Are they empowered to explore new things? There could be technical debt grooming. What is technical debt? It's the things that we take on that we know that we're cutting corners because we want to get past a certain problem. We know that in the future, we're going to have to actually spend a lot more time on that thing. But going and making sure that we're not carrying too much technical debt, that we're paying that debt down because we don't want all these things that we're going to have to get to pile up, that could be part of our culture. We could do game days. We already know that this is part of the culture at Amazon, at Google, at other places. If we regularly do this kind of testing to make sure we're resilient to failure, that could be something that we do as the normal part of the way that we operate. We could do destructive testing. How far does that go? Do we unplug servers? Do we pour water inside servers? Do we turn off data centers like with game days? That can be part of the culture of our company. Cross-functional teams are a completely different angle. It doesn't have to be just technical, right? It could be, how is the organization structured? Is it a matrix organization? Is it a hierarchy? Are there silos? How much input do these different parts of the organization have into the overall way that we practice these different elements of our culture? Agile, that could be an element of our culture. Do we do Scrum? Do we do Kanban? Do we do retrospectives? Do we do learning reviews? Do we do blameless postmortems? We understand that being able to learn and get better can be part of our culture. But there's a danger. The danger is this thing called cargo culting. And we'll explain what that is in a minute. We can't just look at what other people are doing, what people at Amazon are doing, or what Google are doing, and just copy those things and say, okay, now we're doing this because they were doing this, and therefore that's a good reason. We actually have to understand why we're doing these things and copy the important parts. We need to incorporate those things into our culture and live those things. Merely going through the motion won't get us there. Cargo culting, the name of it, comes from the South Pacific in World War II, when the different countries were taking over islands and using those islands as jumping off points to attack the enemy. They would bring first people who would build runways, and then they would build ways for the planes to land, and then they would build facilities to store the different things that the planes would bring. And the people who lived on these islands got used to having lots and lots of supplies and all kinds of things that they felt were really important to them just show up. And then after the war ended, none of those things showed up anymore. And so the people on those islands tried to bring back those airplanes by building fake replicas of things that they had thought had brought the planes before. So they would fix up runways, or they would build control towers, or they would build fake planes on the runways, or things like that in an attempt to get the planes back. But the planes never came because we know that building cheap imitations of what others have done is not going to bring real change. We can't just copy what Netflix does. We have to look at the problems that Netflix is trying to solve and how they're solving them and figure out what will work for us. If our company culture doesn't allow for the length of time that it takes to do image building deploys like Netflix does, then how do we get the same benefits that Netflix gets by the way that they deploy things, but in a way that works for us? It needs to be specific to our company and our culture. We talked a lot about culture in this video, and that's only the first element of the CAMS model. In the next video, we're going to dive into the A in CAMS, automation. See you there. Hi, welcome back. In this video, we're going to talk about the A in the CAMS model, automation. We're going to talk about why automate. Why is automation even the second letter in the CAMS model? Why is that so important? And we're going to talk about some examples of automation. So why automate? Well, we know from the first way of DevOps that we want to go fast. We want to have flow through the system as quickly as possible. When we do things like check our code in and we have continuous delivery automate tests, when we are able to stand up infrastructure and environments with automation, these are examples of things that we can do that enable us to go fast. They are the A in automation. The goal of everything we're trying to accomplish is to get our work into the hands of our customers as quickly as possible, and automation actually allows us to do that. Well, why don't we just hire more people, right? If it takes 2 people to build one environment and we want to have 2 environments, maybe we hire 4 people. That could work. Well, it turns out that that could be a problem. Number one, it's really expensive to just keep hiring more and more people. Everybody's a headcount, everybody has vacation time and health insurance and all the other exciting things that come with hiring people. And we can't just keep doing that because that's going to impact the business and our ability to be profitable and successful. Also, it doesn't scale. Many hands don't make light work over a certain size. Once we get to have too many people, we can have communication problems. We can have problems not only between teams like we would normally have that we're trying to combat with DevOps, but we could have problems within a team, where there's just a lot of people who have to be informed about things that are going on. We could also have resource contention. If an administrator is checking out a DNS zone file and another administrator is waiting for that, or they're waiting to get time with some piece of equipment, we can actually have resource contention. If we invest in automation, we can solve a lot of those problems because the computers actually will do that work for us. We get the benefits of our investment in automation over time. Maybe it takes us a few weeks to write the automation to build a test environment. But every single time we build a test environment after that, we're going to get that benefit. And if it's something that you can use over a long period of time, you're going to save much, much more time in the long run than you would worrying about the amount of time we originally invested to build that automation. Another problem is humans are error prone. They make mistakes. If we hire more and more people, we're just going to have more and more errors. There's nothing we can do about that. That's just the nature of humans. There's an expression that people put on a slide once that I saw at a talk that said, when people do things that computers can do, the computers get together late at night and laugh at us. Think about that. I mean, the computers only do the things that the humans tell them to do. They don't make mistakes unless the humans made the mistakes. If we've actually used a process over and over, then why would we want humans to do that? That's silly. That's a waste of humans' time. We're much more able to reason about problems and come up with new ways of doing things and going faster than we're good at sitting there and doing the same thing over and over. If we automate, we get faster results, and we get more repeatable and more consistent results at the same time. So one of the strongest predictors of high IT performance is the ability to provision environments at will, production-like environments. We have to be able to stamp those out. We know that it's always better to fail early, to fail not in production where it's not going to affect our customers. And in order to be able to test things early in pre-production environments, we need to be able to stand up those environments. We need to be able to stamp them out, because this way we can do all the kinds of testing that we want without our customers feeling the pain. So there are some examples we can talk about for automation. We can talk about infrastructure as code, like configuration management, things like Puppet and Chef and Salt and Ansible. We can write the code for those things, and we can use those to build production-like environments because we're using the exact same code that's used to build the production environments. We're just doing it in a different place, maybe at a smaller scale or things like that. But it's the same code. We can talk about things like a continuous delivery pipeline, which we mentioned, where our tests are automated. It enables us to go fast because we don't have to sit there and wait for humans to work their way through tests. The tests are going to run based on whatever we create for the computers to do. The Simian Army is an example of automation. They're automating the testing of their infrastructure. They're making sure that the infrastructure is continually tested, just like we might do with a continuous delivery pipeline for infrastructure. You can use an orchestration engine to do automation. An orchestration engine can help us automate deployments. If we're using the same tools for our pre-production environments as we're using for our production environments, then we're going to have a high degree of confidence by the time we get to our production environments that the things that we're using, the things that we're doing, are going to be successful when they finally get to production. In this video, we talked about the A in automation, and we talked about some examples of what automation would be. In the next video, we're going to talk about one of my favorite topics in DevOps, measurement. See you there. Hi, welcome back. In this video, we're going to talk about the M in the CAMS model, measurement, one of my favorite topics. I don't work at a metrics and monitoring company for no reason. In this video, we're going to take a look at why measure. Why is that important? Why measure anything at all? We're going to talk about what to measure. And we're going to give some examples of measurement and things that you can use to do measurement. Why measure is a great question. We've talked about Kaizen, the process of continual improvement, earlier. Well, how else do we know if we've actually gotten better unless we measure? How do we know if the place that we are now is better than the place that we were when we started? How do we know if our cycle times are down or if they're up? How do we know if our servers are overloaded after the last deployment? There's lots of different things we can measure. We can't just go by feel. We actually have to make our decisions with data. In DevOps, we're always trying to get better, but we need to be able to prove that we've actually gotten better. We can't just feel our way through it. Jim Barksdale said, if we have data, let's look at data. If all we have are opinions, let's go with mine. Jim was the CEO of Netscape, one of the predecessor browsers to like Firefox now. And it's a great quote. And I think Jim was really spot on. We can't just rely on gut feel. We have to measure the things that we're doing so that we know if we've actually gotten better or worse. We can measure things like CPU utilization, response time, memory utilization, packet loss. Did the last change we make to the network result in more packet loss? These are kinds of things that are really important for us to make informed decisions about the choices that we're going to make. How do we know if we're improving the process to go from the business to the customer? We have to measure these things. So there's some great quotes about monitoring. At a place that I used to work, we used to say, if it's not monitored, it doesn't exist. We would tell the developers, we will not be responsible for things that you put in production that you don't make available to monitor. You have to give us statistics. You have to give us response times. You have to give us all kinds of things in operations to be able to understand the nature of the application. Monitoring is critical. We would tell them, literally, if you don't put this into your application and something goes wrong with it when it's in production, we're not touching it. We're not going to fix it. We're not going to help you. You are obviously not invested in the uptime of your product, so we're not going to be invested in it either. So there's lots of things like that we can measure, right? We can measure response times, but we can also measure lots of other things. And there's a quote from Etsy, the online marketplace, where they used to say, if it moves, measure it. And there's other things that move. There's things like our KPIs, which we've alluded to before, our key performance indicators. How many people signed up today? How many people who signed up converted to becoming paying customers? How much revenue do we make today? What are our operating costs? How many call center tickets are coming in? How much support room activity is there? If I have a CPU graph that says that everything is fine after the last deployment, but my customer support calls are increasing by 400%, you can bet that CPU graphs are not telling you the entire story. And when we combine our KPIs with our technical graphs, then we're actually being able to get a view of the entire system, just like we talked about in the first way. So here's some examples. We can do monitoring with instrumentation platforms like Graphite or OpenTSDB or Grafana. And we're going to cover some of these in much more depth later on in the course. We can get things from information radiators. Information radiators are screens that you have around your office or maybe just around your desk that will tell you graphs that you want to see very often, because part of understanding anomalies are understanding what the normal is, what the baseline is. If you know what the normal looks like, then you'll notice things that are strange. We used to have people that would come into the ops area at a company I worked and they'd say, "What is that?" We'd say, "Oh yeah, what is that?" And we'd investigate it because we had these information radiators around that would allow us to see those kinds of things normally. We can measure things like we said, like process improvement, cycle times, mean time to recovery, right? Netflix is trying to get their mean time to recovery down to 0, their MTTR down to 0. They want it to be instantaneous. Remember the data center failover story that we talked about earlier. They went from 12 hours to minutes in the end. And those are the result of being able to measure process improvement. So that stuff is important as well. So in this video, we talked pretty deeply about metrics, and we're going to talk about them even more in the following sections. In the next video, we're going to talk about the final part of the CAMS model, sharing. Hi, welcome back. In this video, we're going to talk about the final part of the CAMS model, the S, sharing. We're going to take a look at why is sharing so important? Why is sharing such a critical component of practicing DevOps? We're going to look at examples of sharing, and we're going to do a brief summary of this section, the CAMS section of the course. In my opinion, there are 3 components of sharing. The first one is visibility. With visibility, everybody needs to be able to see what the progress is in all parts of the organization. Just like we talked about with the first way, we don't want to have any local optimizations. We want to make all the work visible to everybody so that we know if one team is going to create something that's going to cause a problem for another team downstream, or things like that. With visibility, we're talking about what you did. It allows us to get feedback early, just like in the second way. We don't want to wait to get feedback on something that we're working on. If there's a product owner and they say, "Hey, can you build me this product to my development team?" And I say, "Sure, no problem." And my development team goes off for 2 months. They develop something, they bring it back, and that product owner says, "This isn't the product that I wanted." That's a problem. We need to have this visibility. We need to fail fast. It's really expensive to go off and build something for 2 months only to find out at the end it wasn't the right thing. If the product owner knows what we're building at all times, if they can come at the end of every iteration, maybe every week or every 2 weeks, and see, "Oh, you built this? Okay, well that's good," or "This isn't exactly what I had in mind," or "We should make a minor course correction." That kind of ability, that visibility, that's super important and allows the business to go very, very fast. That's really good for flow. And we need visibility in order to have that. The next component is transparency. Visibility is important, but transparency is also important because we need to have everybody working towards the same goal. If visibility is about what you did, then transparency is about why you did it. And things break down if we don't have alignment throughout our organization. Instead of that one team going off and doing something that could create a problem for other teams, if we don't have transparency, that one team could go off and just build something that isn't what the rest of the company is working on. And if we don't have good transparency, if things are not aligned between different groups, that's when we start to develop bad things like handoffs and things like that, which we know are bad for flow. The third component of sharing is knowledge transfer. We don't want to have constraints in our organization. We don't want to have one person be the only person who knows how to do something, because how is that person ever going to take a vacation or go do something with their family or anything like that? We want to be able to share knowledge between all the different people who are working on things. And this is why cross-functional teams are so good, because different members of the same team will naturally share knowledge with other members of that team about how do I do deployments, how do I do this, what's the process for that. And the other part of that is that collectively we're smarter than any of us are as individuals. We want to have lots of input. We want to have people sharing their ideas between each other so that we can actually come up with the best ideas possible when we're trying to actually solve problems. So let's talk about some examples of sharing. One example would be the daily stand-up from Agile. For people who don't know what that is, you literally stand up every day at a meeting and you say, what did I do yesterday? What am I going to do today? And if I have any blockers. And when you raise those kinds of blockers, when you make that stuff visible, that's when management knows that there's a problem, and it's their job to clear blockers out of your way. It's management's job to increase flow through the system by making sure that everybody has the resources that they need to get their work done. The daily stand-up is one way where we can surface the things that we're working on. We can give visibility into the things that we're doing every day. Another example would be retrospectives, things that we could do at the end of iterations in Agile or learning reviews. We share what's happened. We share so that we can get better. This is the culture of Kaizen that we've been referring to. We always want to get better over time. And in retrospectives, that's our opportunities to make these huge leaps forward, because we have a situation that presented itself that we can actually learn from. And sharing is how we learn. Another example would be documentation. Really, writing things down, helping others understand is really important. If code is well documented, then it's much easier for people to understand and come up to speed on that code. You don't want someone to sit there and try to figure out, what did this mean? Why did they do this? That takes a long time, and that's bad for flow, and that's bad for speed. So documentation allows us to go fast because it gives people insight through transparency into, why did I make the decision to do this? Another way that we can do sharing is brown bags, when we can sit down at lunch and talk to our colleagues about things that we've investigated or things that we're working on. We can give tech talks internally. We can invite outside speakers in to give tech talks. Another thing that's becoming popular are internal conferences. I used to work at a place where we used to have internal DevOps mini conferences. And it's funny because one of the most popular parts of those internal mini conferences was what we talked about earlier at DevOps Days, the open spaces, because people were able to talk about topics that they felt were important, and they were able to share with their colleagues, this is how we do this in security, this is why we do this in security, this is what the release people were thinking when they made this process like this. All kinds of different examples of sharing can happen inside these open spaces. Chat ops is a great way to share, and we're going to discuss chat ops much more in depth later. But the great thing about chat ops is that everyone can see the work when we do it. You want to know how to do a production deploy? Watch someone do a production deploy. You want to know when a deploy went out? Go look at the history. This is really powerful for the organization because there is a lot of visibility into the things that we're doing. We bring knowledge transfer, we bring transparency, we bring all these other elements into chat ops because there's a continual record of, I'm doing this, this is why I'm taking this action. For anybody who wants to do this in the future, obviously the commands are documented right there. So chat ops is really a great way to do sharing. In this section, we talked about the 4 components of the CAMS model: culture, automation, measurement, and sharing. In the next sections, we're going to deep dive on each of these sections with concrete examples, with code, with things that you can see on your screen that are examples of all the different kinds of tools and techniques that we've been discussing. In the next section, we're going to deep dive into the C in the CAMS model when we discuss establishing a DevOps culture. Hi, welcome back. In this section, we're going to take a dive into the C in the CAMS model, culture, as we discuss establishing a DevOps culture. We're going to take a look at a number of different aspects that make an organization successful that has an established DevOps culture. Just making these changes isn't enough to guarantee a successful transformation or to master DevOps, but most successful DevOps cultures implement these practices in one form or another. And again, we'll relate these practices that we discussed back to the 3 ways that we started the course with. In this section, we're going to look at a traditional software development lifecycle versus a DevOps SDLC. We'll talk about the concept of service ownership and how that can drastically improve the quality of the software that we deliver. We can talk about hack events and their ability to transform the culture of our company. We can talk about game days and destructive testing and how they can make the difference between an average organization and a high-performing one. And finally, we'll look at agile and cross-functional teams and how they fit into a DevOps culture. In this video, we'll discuss traditional versus DevOps software development life cycles. And to do that, we'll first look at a traditional SDLC. We'll look at problems with a traditional SDLC as we compare them to a DevOps SDLC. And we'll talk about how a DevOps SDLC relates back to the 3 ways. So for most people who have worked in a software development organization, they're pretty familiar with what this looks like. In a traditional SDLC, we have the product organization that decides what the customers want. They write specs and they negotiate with the development team to deliver something. The development team will go and own it. They'll do development, they'll do testing, maybe they'll do one after the other, maybe they'll do them at the same time, but eventually they'll feed whatever they've developed into the release team, saying that whatever they've developed is ready for release. Now the release engineering team is going to feed it into whatever tool chain they have or processes they have in place in order to make the feature ready for release. Oftentimes this means they have to get on a quote-unquote release train where they actually batch up changes so that it all goes out at a single time. When developing on-premise software, this process is even more dramatic because we don't want to saddle our customers with a continual stream of patches that they have to continually apply. Finally, the software is deployed or handed over to operations to deploy. And at that point, operations becomes responsible for the system, for the software, keeping it running, keeping it functioning, all the things that are required. And this piece of software can remain in production for many, many years. With the rise of DevOps methodologies, people started to realize that the place where the software makes money for the company is only when it's running in production. While there's a lot of upfront work performed by development and engineering and release teams, there's no money being made if that work's not in the hands of our customers. To go back to that factory metaphor we talked about, any software that's developed but not released to production, it's like unused inventory in a factory. It's been paid for, but it's not delivering benefit to the company or its customers. This is exactly the reason that Toyota developed just-in-time manufacturing. They didn't want to purchase and store large quantities of inventory that they'd paid for. It was just sitting in a warehouse somewhere. So it's the same thing with our software. The longer our software sits waiting for release, the longer we have to wait to make money on that feature, or find out if our customers will even use it, or find out if there's any problems that we would only be able to detect once the software is running in production. The more the software sits and waits, the more money we actually lose. On top of that, it's not even that the software makes it to production, but the software actually has to run well. We know that if the site's down, our customers can't purchase the product. They can't operate their business. They can't get the information they need. That's what they're paying us for. So now, not only do we have to get our software to production, but once it's there, it has to perform well, it has to have minimal downtime, and it has to keep our customers happy and engaged. So how do we do this? Well, this is the strategic differentiator. That's the DevOps SDLC. In the DevOps SDLC, we don't wait a long time to get our code into production. As a matter of fact, we streamline the delivery pipeline to get our code into production as quickly and as safely as possible. We don't throw software over the wall to QA or operations. We work closely with those functional areas, and we have cross-functional teams, if we're lucky enough, to be able to get the software out into production. In the DevOps SDLC, we recognize that the proper operation of the software is how our company is going to succeed, and therefore, it's at the center of everything that we do, just like we see in the diagram. We can't do that without planning, but after planning, then we do coding, and then we build, and we test. But once the software is deployed, the process doesn't end there. We release the software, and we monitor it as we're operating it, and then we take the results of what we learned, we take the results of instrumentation, we take the results of the performance that we've seen, and we feed that information back into the next planning phase. We're always and continually striving to have the best software running in production as we can for the benefit of our staff who don't want to be woken up in the middle of the night, and for our customers who expect our software to be of high quality, including security and high performance. So how does this go back to the 3 ways? Well, the first way we talked about increasing flow. If we're working to get our software from our developer desktops into production as quickly and safely as possible, then we're trying to optimize flow. The more quickly we can do that, the more quickly we can get it into our hands of our customers, that's the more quickly that we can actually get feedback, which is the second way. We had to shorten and amplify feedback loops. If we get detailed instrumentation on the software running in production, the M and the CAMS model, then we can make the necessary adjustments to improve the software. Moving from the traditional SDLC to the DevOps one allows us to do exactly that. That's why at the end of the cycle in our diagram, it feeds back to the beginning. We're always looking to improve what we have in production and use each and every opportunity as a tiny experiment to make our software and our processes better. The third way was about a culture of experimentation and learning from failure, and this is only possible if we can deploy quickly and get fast feedback. Just like we said, the third way relies on the first and the second way. If we batch up large amounts of changes instead of doing small incremental changes, then we're not going to know what's going to happen when the software goes out to production. Would you want to reason about the effect of one change? Or would you rather reason about the effect of 1,000 changes all being applied at once? I know which one I would choose. In the third way, the culture of experimentation is only possible once we've moved from our traditional SDLC to a DevOps one. This video looked at the traditional SDLC versus DevOps. In the next video, we're going to talk about the concept of service ownership. Just like how the DevOps SDLC differs from the traditional SDLC, the concept of service ownership is a way to radically change the culture of our company and how our software is operated and delivered. Hi, welcome back. In this video, we're going to continue with our examination of culture in DevOps as we look at the concept of service ownership. We're going to talk about you wrote it, you run it. What does that even mean? We're going to look at Google SRE teams and their approach to the concept of service ownership. We're going to look at feature flags and dark launching, which are 2 techniques that teams that own a service can use when they're deploying their software. You may not know who this is. This is Werner Vogels. He's the CTO of a company called Amazon. You may have heard of it. Werner popularized this phrase, you wrote it, you run it, which means you're responsible as a software development team for how the software that you write runs in production. You are so responsible for it that you don't even hand it off to an operations team to run like you may at a traditional place. You're responsible for instrumenting it. You're responsible for making sure it runs properly. You're responsible for making sure that your customers are having a good experience with it, and this is the software that they need. However, if there's a problem with your software when it's running in production, you're also the one who gets paged. It's kind of amazing how after getting paged at 3 o'clock in the morning enough times, the quality of your software goes up dramatically. This idea that people who are responsible for their software running in production is popular with lots of different companies, including some like Google. At Google, you're also responsible for your software running in production. And as you develop your software, you can put it into production, you're responsible for it there as well. After your software has been running for a while in production, you can actually work with the SRE teams at Google, the site reliability engineering teams at Google, and demonstrate to them that your software is of sufficient quality for them to actually take a handoff from you of your software. Your software needs to be documented, it needs to be instrumented, it needs to be proven to have very little downtime, all kinds of things that would be responsible for you or for them to operate your software in production. If you're able to get your software handed off to an SRE team, then they will be the first responders if there's a problem with your service. And there's SRE teams at Google for all kinds of things like Gmail and Docs and all the different various properties that they have. However, if it's demonstrated that even after your software makes it to production and the SRE teams have taken it over, that your software is not of sufficient quality, then you're going to get paged again at 3 o'clock in the morning until you can prove that you can meet the acceptable levels of criteria that were set by the SRE team. So how do we gain confidence in our software? How do we know if our software is going to run well in production? Well, one technique that you can use to do this is called feature flagging. And in feature flagging, we set a flag that can be read by our software to determine what it's going to do when it reaches a decision point. So, should the code choose path A or should the code choose path B? And oftentimes we set these feature flags in something like Zookeeper, if you're familiar with that. And these flags can be all kinds of different things. One example would be, should a color for a button be blue or green? If the flag is set one way, we make the button green. If the flag is set another way, we make the button blue. And this feeds into our idea of the culture of experimentation, right? The third way of DevOps that we talked about. Maybe more people click on the button when it's green. Maybe more people click on it when it's blue. The only way we're going to know that is if we run experiments, and using feature flags is a way of actually doing this. But it doesn't have to be something simple like a button color. It could be something more complex like an algorithm. Do we want to pass the customers through this algorithm or that algorithm? Which algorithm performs better? As we send customers through algorithm A, maybe we have instrumentation that shows that people click faster or that we have better response times or things like that. But we can actually test our software running in production by using this feature flag. Another example would be what percentage of customers get a certain experience. We can actually canary our software in its rollout to our customers. This idea of a canary comes from the old days when people used to work in mines and they wanted to know if the air in the mine was safe. So they would put a canary in the mine. If the canary came out okay, then the air was safe, and if the canary came out dead, they knew the air was not safe in the mine. Well, we can do similar kinds of things with our software. We can roll out our software to 10% of our customers and find out whether they're going to have a bad experience, just like the miners would have had if they went into the coal mine with bad air. But we can roll out our software this way. We can roll it out to 10% of customers, then dial that feature flag up to 50%, and eventually we can run it all the way up to 100%, and then we don't need this feature flag on that piece of software anymore. We can also say which customers get an experience. A lot of times when we're rolling out our software on our website that we're running in production, who's going to be the first people to test that? Well, it could be internal customers first. We can set a feature flag that says, if you're in this group number, then you get this new feature. If you have these specific user IDs, you get this new feature. So we can actually test things ourselves. Do we want to have beta customers for this? Do we have people that we're close with, that companies that we've worked with for a long time? Maybe we can put their IDs inside this list of people who get this feature flag. And this is a way of rolling things out so that we can actually test how our software is going to behave before everybody in production needs to get it. And one of the last cool things about having feature flags is it's great for operations teams. If we have a feature that's running in production and there's a problem with it, the operations teams can actually turn this feature off if it's causing a problem. This is so powerful, these ideas of feature flags, that lots of companies use this to release all of their software. And this ability facilitates something that we also call dark launching. The most famous example of dark launching right now is probably Facebook rolling out their Messenger product. And with dark launching, you can have this turned on or off via a feature flag. When Facebook wanted to roll out their Messenger application, one of the biggest problems was they needed to solve this concept of presence, this idea of whether somebody is online or offline, because you don't want to start a chat with somebody who's offline because they're never going to answer you. So what Facebook did is they actually made it so that when you visited their site, you ran code on your computer that looked up the presence of your friends. But nobody who was running the software knew that they were running the software. Facebook tested the software for months or more than a year to see whether or not they were able to detect presence, whether they could handle the volume on the back end, whether this thing would even work. And then when they decided to roll it out, they only rolled it out to a percentage of customers, and they kept rolling it out because how else do you launch something to 1.5 billion customers? And this idea that the customer doesn't even know that they're exercising code paths for you, yet you're able to get real production data, is this concept of dark launching. And it's all about having well-tested software so that when we actually want to turn on this software for our regular customers to have as their regular experience, we know that this software has been well tested. In this video, we talked about the concept of service ownership, part of delivering a quality service to our customers. In the next video, we're going to talk about hack events, one of my favorite things to do as part of the way that we practice DevOps. See you there. Hi, welcome back. In this video, we're going to talk about hack events. We'll talk about what a hack event is and why we would want to do one. We'll talk about how to run a hack event. I've run a number of hack events over the years, so I have some ideas about what I think works well. And we'll talk about hack weeks. Is that something that people really do? So a hack event or a hackathon, depending on whatever you want to call it, is an opportunity to practice some of the different elements of the three ways that we've discussed. On one level, it could be part of the third way, the culture of experimentation. It's an opportunity to actually try things that I've never done before, or my team's never done before. Or it could be the first way, an opportunity to increase flow. Maybe there's something that's holding my team up. Maybe there's something that we want to do that can make things go faster. So we could do those kinds of things during a hack event. As an example, technology you wanted to try. That could be Node.js maybe, or Docker. Maybe we're looking at doing Docker on my team, but no one's ever tried to do that before. So this is an opportunity to try out a new technology. And maybe it's something that's adopted and maybe it's not, but we've talked about the idea of Kaizen, of self-improvement. So this is an opportunity to get better, to try new things, to improve. And that's always good for employees. It could be something to help with your daily work. Maybe there's something that we can do to improve flow. As an example, in one of the hack events that I participated in recently, we had noticed that a lot of times when there was a problem with some customer, somebody would have to figure out who that customer would be. So they would go to a database, they would run a query on the user ID, and it would come back and they'd say, oh, it's company X, Y, and Z that's having a problem. Well, it seemed kind of weird to have somebody continually going off to some database and looking something up and then coming back to the chat room to talk about it. So what we did is we modified our chatbot. So we could say, chatbot, what is user ID 12345? And the chatbot knew how to run this canned SQL query against the database, and it would go look up that information and it would return it right into the room there for us. And that actually helps to increase flow, right? We don't have to have somebody go off and do something on some side channel. It's just part of the flow of how we actually do our daily work. And this is something that we improved in our work life during a hackathon. It could be a group event. So this could be an opportunity for team building. We could do it during an on-site, or we could do a virtual hack day across multiple sites. But it gives an opportunity for you to work with different teams. I could work with a network engineering team maybe, and I don't work with them normally. But being able to work with people that you don't normally get to work with opens up lines of communication. And those open lines of communication help to increase flow across an organization. It's much easier to make things go faster if you have a relationship with somebody else, because everybody knows what the other person is interested in. They know what their priorities are, and they can keep those things in mind. And that allows us to improve our speed of delivery, which, like we've said, is good for DevOps. One weird thing about hack events when you're trying to pitch them to management is sometimes it's hard for them to understand why you would want to do this. And a lot of times they'd say something like, well, what is going to come out of this event? And the problem with a hack event is there's no guarantees. We don't know what people are going to experiment with. We don't know what people are going to try to learn. None of that stuff is decided ahead of time, and most people could start a hack event and change their mind if they want to, or go in a different direction. So it's really hard to guarantee what the outcome is going to be, except that it's always a success. I've never participated in a hack event where people didn't grow as individuals, as teams. I've never seen an entire hack event where somebody didn't come up with something new, something exciting. It's always a success. That's the only guarantee that you can give to management about a hackathon or a hack event, is people are going to learn, people are going to get better. We just don't know what that's going to be until we get to the other side. So how do I run a hack event? Well, one question is, how long should it be? 24 hours, 8 hours, 5 days, a hack week? My suggestion, if you've never done this before, is to start small. And that applies for both the event and for the projects. Iterate, iterate, iterate. That's the key to success in a hack project. I've seen so many hack projects where somebody tries to do some huge project, and at the end they're spent in the last 20 minutes just huddled over their keyboard, smashing keys, trying to get something working at the very last minute. That's too stressful. And that's not the goal of a hack day. We're not trying to actually stress people out. So start small. Work with a manageable project. Once you've got that manageable project working, then iterate on that. Make it better. Expand it. So that at the end of the hack event, you'll always have something to present. Maybe it's not the thing that you set out to do completely in the beginning, but at least it'll be something that's workable. What about prizes? And how should they be decided? The prizes can be anything. I've been in hack events where the prizes were just who had the best project. I've been in hack events where they've given out trophies or Amazon gift cards or iTunes gift certificates or things like that. A lot of times people aren't participating, especially at work, in a hack event so that they can win prizes. They're doing it so they can get recognition for something that they did that was cool. They're doing it because they want to have the opportunity to be creative, to learn something new. People don't really care about the prizes all that much, but they're really nice when you have them, and they're really cool. But who should decide who's going to win? In my experience, it's best to have peers be the ones who decide. If you have a bunch of executives are the ones who decide, then a lot of times people aren't going to be creative and they're not going to feel free to explore, because they're going to think about what can I do that's going to make the boss happy. And that's not really the goal of a hack event, is to make the boss happy. We do all the work that our bosses ask from us during our regular workday all the time. That's what we do. That's what we get paid for normally. In a hack event, we want people to be able to explore. And if the boss is the one who's deciding, then that's really going to hamper that. So often we just try to make a rule that everyone who participated in the hack event, those are the people who can actually judge. So who can participate in a hack event? Anybody can. Anybody in the company can participate in a hack event. It doesn't have to be just engineers. I worked at one company where when we'd have our hackathons, the receptionist who sat at the front desk was part of the QA team for one of the hack teams. The hack team was developing something that was on the front end, and they needed someone to click on the GUI and make sure that everything was okay. And the receptionist was actually part of the team and was clicking around for them and finding bugs and reporting them back and things like that. And like we said, getting the ability to work with people you don't normally work with is really powerful. And so anyone should be able to participate in a hack event. Presentation format. Well, one rule of thumb I have is you have to limit how long people can present. Otherwise, if you have a lot of people, hack events can go on forever. We don't want that. We don't want people to get bored at the end because they've been sitting through way too many presentations. So I like to limit them to maybe 5 minutes for a presentation, but you should decide what works best for your company. Another rule I have is that demos are required. You can't just put up some slides and say, I did something. You actually have to show working software, just like out of the Agile Manifesto. If you can't show the software working by demoing it, then maybe you make a video. Because sometimes if I'm going to boot a machine, nobody wants to sit there and watch a machine boot, and that might take more than the 5 minutes that I have. So you can make a video of whatever machine is booting and just cut that part out like we do with video editing and say, here's the machine starting to boot. Okay, the machine is booted, and now I'm going to do my thing. So demos are always required because we want to have working software. We want there to be a point of what we developed. And that leads to the last rule. If software is not working or whatever this hack event isn't working, then that project isn't eligible for prizes because we actually want people to start with a small project and build on it and have working software at the end. And if you explored stuff and you didn't really get anything working, that's fine. You kind of won something for yourself. You got to learn about something new that you'd never tried before. But my rule has been you don't get to have a prize for just exploring things because that's something that is beneficial to you anyways. So this reinforces the idea also of starting small and building on it, like we said. And hack events are a big part of some cultures. This is from a Dropbox hack event. And the important thing to understand about running a big hack week like this is that you have to have management support because it requires lots and lots of planning. Unlike sometimes where people want to ask for forgiveness, not permission, in this case, you absolutely have to ask for permission, not for forgiveness, because you're going to take up a lot of employee time working on this kind of thing, and it's not the kind of thing that you can just do on the side. If you do stuff like this, you're going to be part of companies that actually take this very seriously and make it a part of their culture, like Facebook and Twitter. This is the opportunity, if you do a hack week, not just a hack day, to do things that are called moonshot projects that give you the ability to take big risks and see if there's something that you can come up with that maybe we've always wanted to do, but we never had the opportunity, or something that we've never thought of before. So why don't we just do hack events as normal ways of doing business? Why don't we just put it in the project management queue, whatever the project was that we were going to work on, and do it regularly? Well, we all know if we've worked at enough companies that other things always get in the way. There's always some new feature that has to go out, or there's always some other thing that's necessary for the business to meet some goal or some milestone that get in the way of these other kinds of ideas that we wanted to do. Maybe the idea of working on Docker isn't something that people are going to put aside time for. But having a hack event or having a hack week is part of this idea of a culture of experimentation. And this is a huge part of a lot of really successful companies that we all look up to. In this video, we looked at the idea of hack events. In the next video, we're going to talk about destructive testing in depth and how that makes our software better. Hi, welcome back. In this video, we're going to continue to look at the culture of DevOps as we examine destructive testing. We'll look at destructive testing and we'll talk about how to make that part of our culture. We'll look at the definition of done and how we make that part of the way that we develop our software. And we'll look at failure Fridays and how we can make that a part of the way that we run our services. We've already talked about game days and Google SREs. We've already talked about Netflix and the Simian Army, but we don't have to be as big or as complicated as Google or Netflix in order to bring this concept of destructive testing into our culture. We know we want our systems to be resilient. We know from the third way that repetition leads to mastery. So how do we incorporate this practice of destructive testing into our culture? Well, one way can be through the definition of done, which comes from agile. And the definition of done is the set of criteria that decide when a service is ready to go into production. The software development is complete, the number of unit tests that we have is sufficient, we have code coverage, we have all the different things that could be decided that make our software ready for production. Well, one of the things that we can do as part of the definition of done is destructive testing, because we want to know, how do we know when our service is ready for production? We know from the DevOps software development lifecycle that when our software is in production, we get feedback, but we don't want to put our software into production if it's not ready. So we need to figure out what are the failures that could happen when our software is actually running in production. And in order to have this, we can create a go live checklist. And the go live checklist can be part of the definition of done. That's the acceptance criteria that would come from an operations kind of group. And it can ask, do we have things in place like health checks? It can ask, do we have like the virtual machines or the hardware that's necessary for the service to go live? But it can also have the concept of destructive testing. It can be part of getting ready to go live. We can have everyone that's involved in the service get together and go over the expected failure modes that we would expect to see when the software is running in production. And we can also talk about how to recover from those failure modes. If we practice this failure and the recovery of it, then that's going to lead to mastery. That's going to lower our MTTR, our mean time to recover. We want to get this fast feedback because we know already that it's cheaper to fail in a controlled environment. It's cheaper to fail when everybody's there than during the middle of the night or something like that. So we want to know what failures can we introduce. And there can be lots of different kinds of failures. There can be network failures, power failures, all kinds of things like that. And the different failures will be specific to how you operate your business. But what if our software is already running in production? This technique called Failure Fridays is something I learned from a company called PagerDuty. For people who don't know, PagerDuty is a company that you can send alerts to whenever you're having a problem, say with a production service. And PagerDuty will go and notify the correct people that you're having a problem with your service in production. One of the things about PagerDuty is they need to be much more resilient and available than even the services that rely upon them, because they're performing this critical function when these companies are actually having problems. So PagerDuty does a technique called Failure Fridays. And what they do is on a Friday, they pick one service, just one, that they use as part of operating PagerDuty. And they get all the people involved in running that service. So they get the ops team, they get the service team that developed it, they get any other teams that are required to operate the service, and they get together for 1 hour on a Friday, and they fail the service, and they bring this service back from failure. Most of the time, customers don't even notice because they've got such great resiliency built into the PagerDuty infrastructure. Sometimes they have an impacting failure. Is that a problem? Sure. But wouldn't you rather find out about that problem when everyone's around the table in the room? Or would you rather find out about that problem in the middle of the night at 3 o'clock in the morning, where you have to raise people from bed and get them to come and try to figure out what's going on? I know which one I would choose. This culture of experimenting with failure is an important part of destructive testing, and it's an important part of having a very solid DevOps culture. In this video, we talked about the definition of done, and we talked about Failure Fridays as examples of destructive testing. In the next video, we're going to talk about cross-functional teams and how they're a powerful tool for establishing a DevOps culture. Hi, welcome back. In this video, we're going to continue our examination of the culture of DevOps as we talk about cross-functional teams. We're going to talk about why cross-functional teams are so good. We're going to talk about how they work, what's their composition, and we're going to talk about the results that you can expect when working on a cross-functional team. In the first way of DevOps, we talked about how we were always seeking to increase flow. And we also talked about how handoffs were killer to flow. However, on a cross-functional team, we can virtually eliminate handoffs. Because on a cross-functional team, all the roles that are necessary to deliver software from concept to production are present on the team. If we need network engineering or we need quality engineering, those members are on the team. We have everything that's required. We also have alignment. All the people on the team have the same goal, to deliver that piece of software that's required into production. So how would it work? Well, this is a spider chart that would represent a sample cross-functional team. On a spider chart, the closer you are to one of the axes, the more skill or specialization you have in that axis. You can see, even from this spider chart, that nobody's only on a single axis. Some people might have more skills with systems, some people might have more skills with development, but people also have skills that are present from their teammates. So here we have a developer maybe, a network engineer, a systems engineer, and a quality engineer. And each of the people on the team can actually contribute in their area plus in some other areas. And over time, they're actually going to get to understand other people's areas because they're going to work closely with one another. They can contribute different skills, but they can also help each other out. There's always probably at least one other person on the team who can help you with whatever your specialization is. The fact that the team has the same goals makes this super important because I'm going to help my teammates to achieve the goal, not just work on my specific functional area. But what about if I'm at a small startup? We don't need cross-functional teams at a small startup because we behave as a cross-functional team in a small startup. If I only have one operations engineer and one developer, we're going to be working closely together anyways. So what are the results of working on a cross-functional team? Well, we get to understand each other's jobs. Everybody grows. This is part of the idea of Kaizen, of improvement. Nobody loses any skills, even though our diamond on the right here is very, very well balanced. The idea is that the team becomes balanced over time, and we get to understand other team members' needs and skills. We get to know them as people, and we understand the things that are important to them in terms of their job. And this understanding of what the other team members need, these things that we can keep in mind as we're developing our software, as we're delivering our service into production, this is where the DevOps magic happens. Because if I understand what my developers need, or I understand what my network engineers need, then I can actually keep those things in mind while I'm developing the software and while I'm delivering it to production. And that will help me not only go faster, but it will also help me help them in what they're trying to accomplish. Does that mean that there's no role for X on the team or Y on the team? No, we're still going to have specializations, but specialists are not required for everything. What if you want to take a vacation? I mean, holidays are very important for team members to rejuvenate. That actually helps the team. If we have shared understanding of what other people's roles are on the team, then we can help cover for them. Do you really want to be the only one responsible for your component of a service? What about when we're firefighting? Think about how important it would be to understand what other people's needs are for their specialization when we're trying to fight a production outage or something like that. We don't want a single person to be a constraint, or that person can never go on vacation, or they can never take a break. With a cross-functional team, we have shared responsibility. It goes back to this idea of you wrote it, you run it. A team can take an idea from idea to production as quickly as possible. In this section, we talked about the traditional software development lifecycle versus a DevOps SDLC. We talked about service ownership. You wrote it, you run it. We talked about how to run a hack event and what's so great about hack events. We talked about destructive testing and how we can incorporate that into the development of our software, as well as once our software is in production. And in this one, we just talked about cross-functional teams. In the next section, we're going to look at the first part of A, automation, when we examine configuration management. See you there. Hi, welcome back. In this section, we're going to talk about the A in the CAMS model, automation. Specifically, we're going to discuss configuration management. We'll look at it from a couple of different angles. We'll look at why automate at all. Why are we even going to do configuration management? We'll talk about doing some configuration management, and we'll use SaltStack as our example. We'll talk about configuration management for distributed systems, because often we're not just managing a single server, we're managing a fleet of servers. We'll talk about containers, one of the most popular new topics in DevOps, and we'll find out how they're the same or different from configuration management. And then finally, we'll look at building and running a Docker container ourselves. In this video, though, we're going to ask the question, why automate? We'll talk about why you should automate. We'll discuss Kickstart and Jumpstart, which are technologies that people have used to build machines for years. We'll talk about where they fall down. We'll discuss systems in production and how Kickstart and Jumpstart are not sufficient to be able to configure our production systems. And we'll talk about how configuration management solves the problem. So there's the question, why automate at all? Well, here we have a server and we have an operations engineer. And the operations engineer's responsibility is to manage the server. No big deal. And we can even give more servers to the operations engineer. They can do that. The company's growing. Then we can actually start adding more servers. And after a while, the rate of servers coming in is actually going to get a little bit faster. So what are we going to do? We're going to hire another operations engineer. Okay, now I've got a lot of servers and I've got a few operations engineers and they're managing it. But what happens when the company actually really starts growing and we start hiring more developers and we start getting all kinds of new technologies? Then we're going to have to hire a bunch more systems administrators or operations engineers. Okay, this is starting to get a little bit weird. I'm going to be managing a lot of servers, but I'm also going to be managing a lot of operations engineers. And then I'm going to add more servers because our company's really picking up steam and we're doing really well and we're making lots of money and all the operations engineers have their hands on all the servers all the time making changes, and everybody hates their jobs because they're doing the same things over and over and over again on all these servers and they're having to keep track of what's going on. So let's get rid of that entire paradigm and look at it another way. Now when we're starting our company, we have a bunch of servers and we have teams of operations engineers to manage them. But instead of the operations engineers going around and getting on the servers and changing things, they're going to invest in automation from the beginning. So now, when we add servers, it's no big deal. And we don't actually have to hire any more operations engineers because we can use our automation to be able to manage the servers. With automation, we get benefits like consistency. We talked about one of the predictors of high performance in operations organizations and IT teams is the ability to build the same servers and build environments over and over and over again. But with automation, we get this consistency. We make sure that every time we build a server, it's going to be the same. We also get compliance. Not only when the servers are built are they the same, but they're maintained to be the same. I like to say that configuration management tools are like a compliance engine. You can report on it. You can look and make sure that every single time it's run, the servers are correct. You get repeatability, like we said. Not only with consistency are all the servers identical to each other, but anytime I want to build a server, I'm going to get the same server every single time. You get testability. We can write unit tests. We can write functional tests. We can write integration tests. We can see and make sure that when the servers are built, they're going to come out exactly like we intend them to do. Just like if we were going to do regular software, we want to write tests to make sure that our software is behaving appropriately. When we develop servers with automation, we can make sure they're going to come out appropriately as well. It saves time building. It's just faster. If I need to spin up 5 machines and I don't have to get on and do things by hand, I can build 10 machines or 20 machines, and it doesn't matter. Everything goes quickly. And not only does it build quicker, but when I want to maintain things, it goes quicker as well. Say somebody comes to you and they say, I need this new piece of software installed on all the servers. Do you want to make a project plan and try to figure out when it's going to go to server A and when to go to server B and try to get a whole rollout thing? Or do you want to write the software that it takes to deploy that and then deploy that software to your configuration management system so that all your servers are brought into compliance? So one of the ways that people used to try to solve the problem of automating building of servers was this idea of kickstart or jumpstart. And they come from Red Hat Linux and from Solaris. And they were build tools. They were a way of using build scripts and a couple of other fancy techniques to build the same server every time. And it doesn't have to be bare metal, like for Jumpstart and Kickstart. It could even be for cloud servers. We could use Chef or something like that to run on first boot and configure the server just the way we want. The problem is that when we do stuff like this, we get some of the benefits of repeatability, but we don't get the compliance and we don't get the consistency, because once the scripts are run the first time, that's the end of it. We take these servers and we set them adrift on a bit of network, and they occupy that little bit of network, and people get on and they change things. The problem is when people want to go and change things is now I have a fleet of servers. And sometimes when I have a fleet of servers, somebody wants to run an experiment. So they might take a server out of the fleet. But when I'm running my tools to actually configure everything, I now have to keep track of the fact that that server was taken out of the fleet for testing. So it's not hard. I can keep track of one server. But then there could be another server that's unavailable for something else. It could be unavailable because of a network partition that's temporary. It could be unavailable because a disk failed. It could be unavailable because it hasn't even been built yet. And we're going to make this change, but we haven't applied this change to our build scripts. So now I have to remember to go back and make this change to our build scripts so that if I build a server, then I get that. But I also might have to keep track of other servers. And okay, my first server comes back and we fix that up because I remember. But then another server goes out and another server goes out for one reason or another. And I get into this mess of trying to keep track of all the different variants. Is my server out for testing? Is my server out for a disk failure? Is my server out for being rebuilt? Is my server out for all kinds of different reasons? What's the solution to this? Well, we know the answer, right? The answer is configuration management. And these are some examples of configuration management tools that you could use to do this. And we're going to use Salt and Puppet later on as examples. So with configuration management, it's actually very different. I can have a server go away. I can have 2 servers go away. It doesn't matter, because when those servers come back, they're automatically brought back to the correct configuration. They're automatically brought back into compliance. And this way, I can manage tens of servers, hundreds of servers, or thousands of servers. And as long as I do my configuration management correctly, I'll know that any one of those servers is going to be in compliance with every other server. And not only that, if I lose a server and I bring a new server in, I know that that thing's going to be okay too. In the next video, we're going to talk about configuration management with SaltStack. And like I said, we'll do Puppet later. The important thing to remember is which tool we use doesn't matter. This is not a video course on configuration management. Showing things about configuration management is part of our understanding how high-performing teams practice DevOps. As Bridget Kramhout says, containers are not going to fix your broken culture. If you get too caught up in which tool is being used, you'll never master DevOps. I'll see you there. Hi, Welcome back. In this video, we're going to talk about configuration management with SaltStack. We're going to discuss how to use configuration management. What are the ways to approach the use of configuration management? We're going to make our very first salt state, which will be pretty simple, but from there we'll be able to build on it, and we're going to make your very first salt state, where you'll actually be able to configure a virtual machine, and then we'll talk about where to go from here. What you'll need? Well, you'll need a Unix virtual machine, preferably Ubuntu 14.04, which is one of the long-term supported versions of Ubuntu. And you can expect the examples in this video to work if you match this version through at least April of 2019, when LTS support runs out, and probably longer. You'll also need network connectivity. If you use a virtual machine in the cloud like I will, you'll need to be able to connect to it. And if you use a local virtual machine, then you'll still need to be able to download packages and install them. So why a virtual machine? Well, one reason would be you can recreate it at will. So if you want to try things on there, if you mess something up, if you make a mistake, you can always destroy the machine and build another one. That's powerful because it allows us to experiment. Remember the third way of DevOps, the culture of experimentation? With a virtual machine, we can experiment on the host, we can try things out, and if we have a problem with it, like we said, we can destroy it and recreate it, but it gives us the freedom to experiment until we find ways that work for us. It gives us practice with ephemeral infrastructure. A lot of modern computing now is done in the cloud, and the idea of being able to destroy machines and bring them back and practice with this life cycle is important, so we should practice with ephemeral infrastructure. And lastly, failure happens. The reason that we have the window in these slides is because there's an old thing that says, if you really want to know how good your configuration management is, walk into your data center, grab a machine, walk over to the window, if your data center had a window, and throw it out the window. How long would it take for you to replace that machine to recreate an exact copy of that? And so in our case, we know that failures happen. We know that in the cloud, virtual machines are destroyed, they go away, there's problems. So we want to get accustomed to this idea that failure happens and using configuration management to recover from it. So how do we use configuration management? Well, the first rule is we enforce our states or our compliance with our states using states, manifests, recipes, whatever they're called in your configuration management tool of choice. We just want to make sure if I want to have a package installed, that I do that inside my configuration management code. The next rule is no snowflakes. If I hand edit a machine and I throw that machine out the window, then I'm going to have to hand edit that machine again. I don't want to do that. I want to actually have machines that are all completely repeatable. We're going to practice concepts that are in infrastructure as code. When we do develop infrastructure as code, we're developing code, just like if we were writing an application. So that means we're going to do revision control. Doesn't matter that this is infrastructure that we're working on. This is configuration management. It's infrastructure as code. We want to be able to track who made changes, when they made the changes, what the changes were. Use Git, use Subversion, use something like that, but we should use revision control. We want to be able to write unit tests. So is the code going to do what we expect? Is it going to substitute the right variables in? Are we going to get the desired output that we want? We should use unit tests to be able to determine whether that's the case. Integration tests. Are the interactions with other systems or other components behaving exactly as we desire? The only way we're going to know ahead of time is to do integration tests. We don't want to find this thing out when something's in production. And last, do code reviews. Just like when we're developing any other kind of software, we want to have somebody else look at our code and make sure that there are not things that we could do better. Remember, we talked about this culture of Kaizen, this culture of self-improvement. The only way we're going to get better is if we get feedback, and code review is a great way to get feedback. So we're going to do our very first salt state. In order to run our very first salt state, I have some documentation up here that you may want to load up in your browser ahead of time. These things are going to be pages that we're going to use as we're developing our very first state and it might be handy to have them available. So let's get started. I have a virtual machine. You can see here from the Amazon console that I launched it. And we've got a terminal open, actually 2 terminals open on this virtual machine. And there's not much going on here, as you can see from the LS, that it's pretty boring. There isn't anything going on. So in order to get something going on, let's install Salt. So I have my documentation here, and it says that if I want to install Salt, I need to bootstrap my minion. And we're going to do what's called Salt masterless, where we're going to actually run the Salt code directly on the command line. So we're going to copy and paste, and that should come down very quickly. And now I have a bootstrap, which we didn't have before, which is cool. And then I'm going to actually install Salt. And through the magic of video editing, this will take no time at all. Okay, great. So Salt's installed, and we have the latest version. Now, we need to do some things in order to get this Salt working. So down here, when we're running masterless, it says that we need to create a state tree, and we need to create a top file under srv salt top.sls. So I'm going to select this. I'm going to go back to my virtual machine, and I'm going to make that directory tree for us. And I'm going to change to that directory. And now I'm going to create my top.sls. Now, the thing is, we're not actually going to make a web server. So if we're not making a web server, let's make something else. Let's make a graphite server. And we're going to use graphite as an example a bunch of times in this course. Now, in order to make a graphite server, I'm going to need to create a graphite.sls that matches the entry that we have inside of our top.sls. So in there, I'm going to need to install some packages. So what packages do I need to install graphite? Well, I've got my instructions here for how to install graphite, and it says on 14.04 Ubuntu, I need to install graphite web and graphite carbon, as you can see right here. So, to install packages in Salt, let's see how we do that. Oh, I can say that I want to install packages, something like this. So let's copy that, and then we're going to fix it up. So I don't really need to specify the repo because that comes automatically with Ubuntu. So I'm going to say I want graphite. And packages installed. Which packages? We said we're going to do graphite web, and we're going to do graphite carbon. And we don't need this. So now that I've got that, I need to actually find a way to run this. So let's go back to our handy dandy documentation, and it says that if I want to run it, I can do a local state apply. So let's try that. And we're going to let that run, and Salt will do its thing, and Ubuntu will do its thing, and through the magic of video editing, this will take no time at all. And there we go. We've got our stuff installed, and if we do a dpackage -L, we can look for graphite. And we can see that we have graphite carbon and graphite web. Those are both installed. And those were installed by Salt, and thank you very much, Salt, for installing those for us. But if we're going to run graphite, we might need to tune the system a little bit. So let's get ready to do some tuning. So I'm going to VI my top file again, and I'm going to say that we're going to do some tuning. And that means I'm going to actually have to edit a tuning.sls. So what am I going to do in there? Well, let's say that we want to change the number of file descriptors that the machine's going to have available. So on this other machine, I actually have a terminal that shows exactly how many file descriptors are set. and we can see it's in the fs.file-max variable. So in Salt, I actually have the ability to change those things. So I'm going to go over here, and it shows that VM swappiness is something that I can set with Salt. And so for us, I want you to figure out how to set the variable for the files and run that, and then hopefully you'll get the same answer that I do for how to change the syscontrol variables. So why don't you go ahead and try that. And here you go. This is what I changed it to. Hopefully you got the same answer. So that was a simple example of using Salt for configuration management, and we ran it as a local apply. In the next video, we're going to know that running a single server is probably not something we're going to do in the cloud. We're probably going to run a fleet of them. So we'll look at using configuration management for distributed systems. See you there. Hi, welcome back. In this video, we're going to talk about configuration management for distributed systems. We're going to review our current Salt state that we developed in the last video. We're going to install a Salt master and a minion, which is actually how you would run Salt if you were going to control a fleet of servers. The minions would call in and talk to the Salt master, or vice versa. We're going to verify connectivity between our Salt master and our minion. We're going to improve our Salt state. We're going to have it do more than it did when we started. And we're going to serve our state from a Salt master, just like we would do if we had thousands of machines calling in to be managed with configuration management. So the current state that we have installs two packages. It tunes the operating system to change the number of available file descriptors. And it runs locally only, so we can't use it to control an entire fleet of servers. However, we're going to improve this. We're going to make our state, and we're going to connect it to a Salt master, and we're going to start the Carbon Relay service while we do it. For this demo, you're going to want to have the following URLs open in your browser. They'll actually help you for the things that we're going to do. So let's get started. So I have a virtual machine that I've started, and I'm using the Google Cloud Platform for this virtual machine, unlike with the last one where we actually used Amazon. The reason is because, as we've said, the tools itself don't matter. It's what we're trying to accomplish. So we should be able to use lots of different tools as long as they accomplish the things that we're going for in DevOps. And I've actually gone onto my virtual machine and I've cloned the GitHub repo for this course. And you can see here that I've got the graphite, the top, and the tuning SLSs all available. So let's set up our machine to be a Salt master. So I'm going to make an SRV Salt. And I'm going to copy these files into there. Great. So now I actually need to install a Salt master as well as a Salt minion. So there's Bootstrap information on the Salt website for how to do this. And we're going to copy this line. And now we have our Bootstrap script. Now we actually want to bootstrap. But I'm actually going to change this a little bit. So we want to have a minion and a master. So I'm going to say -M, which means give me a master as well as your normal installing of a minion. And I want to actually get the latest stable version of Salt, because the development versions, who knows what's going on with those. So through the magic of video editing, this should take no time at all. Okay, great. So our master and our minion are installed. Let's see if they're running. All right, the master is running, but there's 3 services that were all started by PID1, which is a bug in this version of Salt. So let's kill those and restart. Hopefully this bug is gone by the time you actually take this course. So let's check again. And we've got no Salt master processes running, so let's start one. Okay, so now we've got a Salt master process running. Now we've got to tell our minion that we want it to talk to this Salt master. So let's edit etc salt minion. And we're going to look for the part where it sets the salt master, which is right here. And it doesn't know about a machine named salt, but it will know about a machine named localhost, which is where our salt master is actually running. Now we're going to restart the minion so that it picks up the new configuration. And we can see that we have a new minion process started. Great. So let's have the minion call in and talk to the salt master to find out what it's supposed to do. So salt call state.highState. And we'll see that there's a problem because the salt master doesn't recognize this minion. And this is pretty common with lots of different configuration management systems, that there's keys to be exchanged. And when you deploy Salt or Puppet or things like that, you'll have to figure out exactly how you want to manage the keys. But for our purposes here, we'll look and see what's going on. Salt key minus L. And we'll see that this unaccepted key is there. So let's accept it. Yeah, okay, great. So now we're going to try again, and we'll see that we can actually run this high state. And okay, so that took a little while because it actually had to go and download some packages. So now we actually want to see if the salt master can talk to the minion, because we know that the minion can talk to the master. So let's do a sudo salt star test.ping. Hey, our minion answered. Great. So now we know that not only can the salt minion talk to the master, but the master can reach out and talk to the minion as well, which is one of the cool things about salt. So let's improve what we have for the salt master in the manifest. So we're going to go to SRV salt, and we're going to edit the graphite one. We want to make this a little more complete. So we're going to start a carbon cache. And we know from salt that we can actually control services. So let's go to find out about services, and we can see right here, and we can see right here that we can have service running. And we're going to put that into our manifest. Great. Now that that's in there, let's try our test.ping, but instead of doing a test.ping, let's tell it to run a high state. And this is saying, any minions out there, run a high state. And look at that. We actually have carbon cache as something, and it says it's running. And because we had done enable is true, just like here, anytime this machine reboots, we're actually going to have the carbon cache start for us, which is going to be super awesome. So, if you want to know more about salt, you can look here. There's plenty of resources available from Pack Publishing for you to learn lots more about salt and how to use it. In the next video, we're going to talk about containers. We're going to skip a little bit past configuration management and talk about one of the most popular topics in DevOps today. See you there. Hi, welcome back. In this video, we're going to talk about containers. We're going to talk about what containers are, where do they come from, why are they different than things we've had in the past. We're going to talk about the advantages of containers. What's so great about them? Why are people excited about using containers? And how is that different than configuration management, which we've been discussing? And last, we'll talk about when do you use containers, when should you use configuration management. So we've talked about, in the third way, the things that we're really going for is 1, optimizing flow, 2, getting faster feedback, and 3, running more experiments. Well, the great things about containers is they actually allow us to do all 3 of those things. So where did containers come from? Well, for a while, we've had packages. So Debian packages, or RPMs if you were on a Red Hat system or a SUSE system, and packages were great. They're a great way to get the bits onto a host that you needed to run a piece of software. So if I wanted to run Graphite and I needed to have the web front end, then I was going to need something like an Apache server or an Nginx server. And I would have to do dependency management and make sure that I had all those things installed on the host if I wanted it to work well. So that was okay because we could actually keep track of those things. And after that came things like jails and BSD and zones and Solaris. And this is a way of getting isolation in processes. We don't want processes to all be competing necessarily for the same resources on a host, and things like jails and zones were ways of actually getting some kind of isolation. Well, eventually, Linux got LXC, which is basically a combination of being able to package things up, control for dependency management, and have isolation. And those are containers. And the interesting thing about containers are we call them containers because they're a standard way of getting bits, in our case, from one place to another. Just like in shipping, when they finally decided to do standardized shipping containers, it was a standardized way of getting material from one place to another. And these parallels are really strong because shipping containers revolutionized the shipping industry, and containers in computers are actually becoming really the default way of packaging and managing these bits if we want to be able to run things in production, development, all kinds of different places. So, what are the great things about containers? Well, one is they have all the requirements. So, like we said, if we want Apache and Graphite, then we can make sure that all those things are wrapped up inside of a container, and we can ship the container with all the bits that we need from one place to another. It's a standardized way of getting things from place to place. But that's the thing about it, is they're actually the same bits. So, if we want to run a container in development, or we want to run that container in production, it can be the exact same bits. We can take an MD5 sum, and there's SHAs already on containers, of the container to verify that the same thing that we tested and made sure that everything was okay in development, those exact same bits are running in production. You can have isolation with containers. Not to the same extent as virtual machines, but you can actually have process isolation one from another because they're running inside containers. But in addition to that, containers have the ability to do things like share libraries. So they're actually more efficient. It takes a lot less memory to run multiple containers of the same thing than it would to run, say, multiple full versions of those things, or especially not multiple full versions of those things on multiple virtual machines. You can even run multiple containers on the same machine because of this, where if you were trying to run multiple virtual machines, you'd probably wreck the machine. So this makes it great for environments like integration testing or development, because in a development environment now, I don't actually need to run, say, 6 or 8 or 10 VMs to emulate my microservice architecture. I can actually just do that with a number of containers. And that's great. So now I can start and stop these containers in a fraction of a second. I can start and stop multiple containers at a time on a single machine. So if I want to actually do something like integration testing or unit testing, even better, I can actually fire up, say, 30 containers to do unit testing and run them all in parallel. And I don't have to wait for the start time for 30 virtual machines to start, which could take an awful long time, especially if we're thinking about the second way of DevOps, getting feedback. I can get fast feedback much more in a container than I can with my virtual machine. And the containers are efficient. The ability to start and stop in a fraction of a second is because they can also do things like store things in the file system cache, because containers have the special property of the way that they do file systems. So when do I use which? Well, to be able to deliver software rapidly, maybe we should use both. For configuration management, we can use it for things like configuring the pipeline. We can do it to run unit tests, to actually call the containers. We could use it to build the containers. We can use it to move the bits from place to place so they're ready to go onto the host. We can use it to configure the host. The containers are going to have to run somewhere. They're going to need software like maybe Docker, the engine for Docker, and all that stuff can be done in configuration management. We're going to need to configure the repositories for these containers. We have to serve the bits from somewhere. The bits, we don't have to just ship them around via SSH or anything like that. So we can use the configuration management to build the system that's required to be able to run the containers. Once we have that system, then we can use a container to package up all the dependencies. If we want to move from Ruby 1.9.3 to 2.3 on our production application, we don't have to mess around with RBM or Ruby or any of these other things. It's no problem. We can actually just package up this Ruby in the new container and use that to do an instant upgrade, because we can actually spin up these containers in fractions of a second. We can use containers when we want to configure the application. We can put configuration files. We can tell it about service discovery. We can tell it where to store the data. All kinds of things that are important for the runtime. And we can also use it to configure the runtime. So we can tell which ports we want it to listen on. Do we want it to bind to port 80, port 443, to a high numbered port? All kinds of things like that are things that we can control with the container. So talking about containers and how cool they are is fun, but building a container is even more fun. In the next video, we're going to use Docker to practice building and running a container. See you there. Hi, welcome back. In this video, we're going to look at building and running a Docker container. It's going to build on the concepts that we learned in the last video when we talked about containers in general. This is also the last video of this section. We're going to take a look at installing Docker, the software, and making sure that the engine is there for us to use. We're going to build a Docker image that we can turn around and run as a Docker container, and then we're going to prove that this container is actually running the software that we built by checking it out. So if the last video was about what containers were and how useful they are, then this will be a demonstration of how to actually apply what we talked about and see it in action. In order to do this video, I suggest you have the following URLs open in your browser. One is the installation instruction for Docker in the version that I'm going to use, and the other one is the GitHub repository for the course. So I've actually taken the time to spin up a virtual machine in AWS. Yes, we did AWS, then Google, then AWS. Like we've talked about, which tool you're using isn't important, it's what we're trying to accomplish. This is why we don't get attached to our tools too much in DevOps. I've also checked out the repository and changed into the video 5, which was the one that I have the software that we need for this section. I've also checked the version of the kernel that's running on this version of Ubuntu 14.4, and this is a modern kernel, so we're actually able to run Docker. So let's install Docker. We're going to go over to our installation instructions, and we'll see that there's a curl command that we can use to actually get Docker installed. Now, you'll see a little bit further down, there's optional configurations for Docker on Ubuntu. Remember in the last video, we talked about when do you use containers versus when do you use configuration management? These optional configurations are a great application for configuration management. All right, let's get Docker installed. So we're going to run our curl command, and it's going to go out and get all the things that are necessary. And we know through the magic of video editing that this will take no time at all. Okay, great. So Docker's installed and it should be running. Let's check. Sudo service docker status. Okay, so our Docker engine is running. If you're working on an operating system that doesn't automatically start the engine for you, then you're probably going to want to double check and make sure that that's actually there and available. Now, is this Docker installation actually functional? Well, let's start what we do with every piece of computer software. Sudo docker run hello world. And we can see that Docker is not able to find the image locally. So what it did is it went out, grabbed hello world, took it down, and ran it. So there we are, hello world from Docker. Well, that's cool. Well, it'd be even cooler if we did it with our own. So let's look at making our own Docker image. So I have this Docker file here, and if I cat the Docker file, then I'll see what is actually contained within. So we can look at the instructions, and it says from Ubuntu, which is great. We're going to run as an Ubuntu thing, which is great because we're running on Ubuntu. We're going to label our image with a description of Mastering DevOps version 1.0. And then what it does is it goes and it runs some apt commands to install Graphite Carbon, which will also bring in whatever dependencies are available. We will grab port 2003 and make that as part of the container because port 2003 is what the Carbon relay listens on. And we're going to define where to write the data. Docker deals with immutable images, so we actually have to tell it where we want it to write the data because you can't write to an immutable file system. And finally, we give the instructions for starting up the Carbon cache. You'll note at the end it says no daemon because we don't want the daemon to fork off into the background and have Docker think that the process actually exited. So we're going to actually give it the no daemon right there. So let's see if port 2003 is already listening, because then we'll know whether we're able to successfully run our software later on. So we'll check localhost. What's listening there? Nothing. Nothing's listening on port 2003. All right. Well, let's build our Docker image. Sudo docker build. We're going to tag it as dmango graphite. And we're going to tell Docker the things that it needs to build the image are right here in this directory. And Docker is going to go, it's going to grab a bunch of different things. It's going to grab our dependencies, and it's going to build us an image. The first time it builds the image, it might take a little while to pull down some of those things. The next time it would build the same image, it would use the advantages of its file system layering that it does to be able to use the things it's already done. And the second time we build things, they'll go much, much faster. So let's let Docker build. Okay, great. Our container is built. Well, our image is built. We're going to have to run the container soon after. So let's look at our images. Sudo docker images. There we are. We have Graphite, which is the one that we just built. We have Ubuntu, which was the operating system that was built 10 days ago. And we have our Hello World that we already pulled down and ran as our demonstration. So now that we have our image, let's actually run it as a container. So sudo docker run it, detach when we run it, and we're going to use port 2003. We'll map that to port 2003. That makes a lot of sense. We're going to name it DevOps, and we're going to use the dmango graphite image to do it. Boom. That was our container starting so fast. So let's see what's running. So if we do a sudo docker ps, we can see there's dmango graphite, and it is running for 12 seconds, and it has port 2003 mapped to port 2003. If we wanted to see what else was running, we could see that we also still have our Hello World container that we pulled down 4 minutes ago and ran, and it exited. So let's do our test. Is the container listening on port 2003? Localhost 2003. Ta-da! We have a running Docker container running our software that would be available for different clients to connect to the Carbon cache and submit their metrics. And we'll talk more about that in other videos. So, in this section, we talked about configuration management. We talked about what it's useful for. We did our very first configuration management example with SaltStack, where we installed some packages. Then we built upon what we had done there and showed how you would actually run configuration management for distributed systems if we wanted to manage dozens, hundreds, or thousands of servers. We talked about containers and how useful they are, and then we showed an example of building and running a Docker container. In the next section, we're going to continue to explore the A in the CAMS model automation. We talk about continuous delivery, and we'll learn how continuous delivery ensures high quality from development to production, allowing us to move quickly and safely the entire time. I'll see you there. Thanks. Hi, welcome back. In this section, we're going to continue our examination of the A in the CAMS model as we discuss continuous delivery. We're going to ask, what is continuous delivery? and we're going to make our very first test environment with Vagrant. Then we'll go on and do some more advanced work with Vagrant to show some of the things that you can actually do. And then we'll look at server spec, where we'll see how you can actually test your infrastructure code in very much the same way that you would test any other code. And then at the end, we'll ask, am I ready for production? Where we'll talk about different deployment models that you can use when you're practicing DevOps. In this video, we're going to talk about what is continuous delivery. We'll define continuous delivery so that we know exactly what we're talking about, and then we'll talk about what a continuous delivery system looks like. And finally, we'll discuss continuous deployment. Isn't that the same thing as continuous delivery? So, you remember this model from a few sections back where we talked about how software can go from development into production. Well, in continuous delivery, we're not going to worry about the operations part, but we're going to focus on the piece right here in the middle, development and testing. This is how we get our software ready to go to production. There's a couple of principles that you should keep in mind when you're thinking about continuous delivery. One is your pipeline should be automated and repeatable. You want you to have a reliable delivery pipeline for your software to get from your desktop all the way out to production. If you can't repeat the same process over and over, then you're not going to have very much confidence that what you've built and that comes out the other side of the continuous delivery pipeline is something that you're ready to put into production. You'll have some kind of feeling about it, but that's not really what we're going for here. And we also want to use the same methods to deploy to each test environment. So whatever methods I use for production, I should try to use as far back to the beginning of the pipeline as I possibly can, within reason, of course. Another part of automated is we want it to happen on every commit, or at least very close to every commit if it's something that we have to do on an interval because tests can take a really long time to run. Because we don't want to have any gaps where software can sneak through to production and not actually be tested well enough. We also want to make sure that we can get fast feedback on our tests. And like is obvious, if we want it to be automated and happen on every commit, we don't want to have any manual starts. We actually want this to be really quick because we want to be able to run to the pain. That means that any part of our continuous delivery pipeline that's causing us to go slow or is really painful or involves manual intervention, we want to automate those things. The authors of the continuous delivery book, Jez Humble and Dave Farley, like to say, if it hurts, do it more. The pains are your bottlenecks. If you remove the bottlenecks, the whole system can flow faster. If you've ever automated something awful, you know exactly what I mean. It's just like we talked about in the first way of DevOps. We want to optimize flow, and anything that we can do when we run to the pain, anything that we can do to make the painful parts of our delivery pipeline much, much easier is helping to optimize flow. Our delivery pipeline should be version controlled. Otherwise, it could be impossible to reproduce. So not only does the software that flows through the pipeline need to be version controlled, but the actual continuous delivery pipeline itself needs to be version controlled. Doing this, having our software in version control and our continuous delivery pipeline in version control, allows us to stand up test environments. And like we talked about, being able to stand up environments on demand is a sign of high-performing teams. We want to use the same bits as well when the software is going through testing as when it goes through into production. We want to be able to prove this. This is what we talked about before with containers and why they're so attractive for this. We can actually verify that the bits that we tested are the same bits that are running in production. And we should be able to recreate the exact bits that were used to go to production anytime we want. Our software should also be always deployable. We always want to have shippable working code, and our continuous delivery pipeline will be able to help us prove it. Anytime something goes to production, we want to know before it ever gets to production that that code is going to succeed as best as we possibly can. And the more testing that we do, the more we can actually have confidence in that software. And last, the continuous delivery pipeline is everybody's responsibility. Just like in DevOps, everybody needs to be responsible to get the code from development all the way to production. We want to have confidence in those bits, and only by making sure that this pipeline is flowing smoothly and doing all the correct things can we have confidence in that. So what would it look like? Something like this. Here's my developer's desktop. He or she is developing software on there, and they check their software in. And as we'll see soon, you can run all kinds of tests there. The important thing is we want to work in small batches. Like we talked about before, we don't want to reason about lots and lots and lots of changes. We want to be able to reason about a small amount of changes. And after they check in their code, it runs some unit tests. Why unit tests? Because they're fast. Just like we said in the second way of DevOps, we want fast feedback loops. We want to focus on our problems as early as possible because it's so much cheaper to fix our problems in development than to fix them in production. If I'm sitting at my desktop and I write some code and I check it in, and then I get feedback really quickly that says, you have a problem here, there's a bug, I can jump right back into that section of code and fix it right away. That is super cheap. If I check my code in and 2 weeks later I find out that there's some kind of a problem because my code was deployed to production without testing, then I have to go back. I have to look at, okay, what was I doing here? All right, why did I choose this algorithm? What was this all about? Like, there's a lot more overhead to try to go back much later on. So we want to actually get fast feedback. Beyond the unit, and so how long should it take to run these unit tests? Well, according to the continuous delivery book, it should take about 10 minutes tops, about enough time to go and get a cup of coffee. If it takes more than 10 minutes, then we should try and optimize this, maybe parallelizing things with containers. The next step in the pipeline is integration tests. This is where differing systems that have to interact with each other are able to interact. This is where we find out whether the contracts that we have or the SLAs that we have between different subsystems, whether or not those things are being honored. Because it's one thing to have unit tests and see something in isolation. It's a lot different when different pieces of software start interacting with one another. From there, we can go to anything that we want. We can have as many different test environments as we want. And we can parallelize things at this point, or we can parallelize things earlier. Just like we talked about, containers are great for something like this. But the point is, we should be able to run whatever different kinds of tests that we want. So we can run security tests, we can run performance tests, all kinds of things like that. The idea is, the more testing that we do, the more confidence we're going to have when something goes to production. I was working at one company where we were talking with an executive about how we wanted to build a continuous delivery pipeline. And the executive asked, well, how much money do you think it's going to cost to build this pipeline? And we said, the more money you spend, the more confidence you're going to have when the software goes to production. How confident do you want to be? So after we have our continuous delivery run through our unit tests, integration tests, whatever other tests we want, then we're ready for production, right? Do we go to production? Well, we should know the answer to that because we'll have a dashboard that says what the state of the software is, what things passed, what things didn't, and at this point, we have continuous delivery. We can decide as a human whether or not I want to push this software into production, whether or not it's ready to go. Well, what about continuous deployment? Well, with continuous deployment, once the testing is done from the continuous delivery pipeline, if all the tests are passed, then the software automatically goes into production because we have such high confidence in our continuous delivery pipeline that we believe that we can push that software to production automatically without a human making that decision. You can't do continuous deployment without continuous delivery before it. In the next video, we're going to set up our very first test environment, the very first step in our continuous delivery pipeline, and for that, we're going to use a great tool called Vagrant. See you there. Hi, welcome back. In this video, we're going to talk about setting up our very first local test environment with Vagrant. We're going to talk about what is required to set up our environment, what software you need to download to be able to have this local test environment. And we're going to talk about setting up our very first virtual machine. And this will be a little bit different than what we had done with virtual machines in the cloud because it will be on our local machines. We'll talk about working with Vagrant and what commands Vagrant gives us in order to be able to control our virtual machines. And then we'll look at working with the Vagrant file and what are the settings that we can make in there that will allow us to control our virtual environment even further. So to do this, we're going to need to install some software on our machines. We're going to need to install Vagrant, and we're going to need to install VirtualBox. And Vagrant is available here on the HashiCorp website, and you should choose, obviously, whichever operating system is appropriate for you. And you can see there's a few Linux offerings, and there's Mac OS and Windows. I'm going to be giving my examples on Mac OS, and if you're running on Windows, you may have to adjust a few things in the Vagrant file to reflect the different paths and things that are different about Windows. And you'll need to install VirtualBox, and VirtualBox is available here. The reason that we're using VirtualBox is we want to take advantage of some of the specific networking properties that are available in VirtualBox in the next video. So once we have VirtualBox and Vagrant installed, then we're going to come back and we're going to install the Ubuntu 14.04 VirtualBox image. And to do that, we're going to run this Vagrant box add command that's available right here on our screen. And that will download and install this 14.04 LTS version, which should be good for a number of years. And it'll install it in your home directory. If you're on Mac OS or Linux, you'll install in your home directory .vagrant.d in boxes. If you're on Windows, it'll be on C users username vagrant.d boxes. And finally, we're going to need the GitHub repository for mastering DevOps because the Vagrant file that we're going to want to use is available in that GitHub repository. Great. So this would be a good time to pause the video and install whatever you need. And then come back and we'll get started. Okay, so hopefully all of your software is installed, and in order to make sure that we have the right things, we're going to do a Vagrant box list. And you should see when you do that, that you have an Ubuntu Trusty 64 box that's available. And in order to control this, we're going to use a Vagrant file. So let's look at our Vagrant file. So there should be a couple of things you'll note about the Vagrant file. One is at the top, it's set to be Ruby. That's because this is actually Ruby inside the Vagrant file. So you should recognize things like this iterator if you're familiar with Ruby. And that means that we can do all kinds of fancy things inside of our Vagrant file if we want to, if we have some programming background. Next, you'll see that we're going to configure our VirtualBox. It's going to be our Ubuntu Trusty 64, which we've already downloaded. And here we're telling VirtualBox not to auto-update our guest software because we don't need to do that on every boot, especially on this video where we're not going to take advantage of any of those special properties. Then here we're telling VirtualBox to display the GUI when we're booting a machine because it's always great when we're very first working with Vagrant to get that feedback to show us that the virtual machine is actually working correctly. And we're going to tell VirtualBox to use only a little bit of memory because we don't need a whole lot of memory and we don't want to bring down the machines that we're running this on. Down here, there's a shell provisioner, and we'll get back to that a little bit later in the video. So, in order to start a virtual machine with Vagrant, it's actually very simple. We type Vagrant, and this will go and look at the Vagrant file and figure out exactly what it needs. So we can see it's importing the Ubuntu Trusty 64 box, and then Vagrant's going to go and do whatever else is required to bring up a virtual machine for us to do our testing on. And we know through the magic of video editing, this will take no time at all. Okay, great. So our virtual machine is up and running. So what can we do with this? Well, in order to get on our virtual machine, we're going to Vagrant SSH. And this will actually log us into the virtual machine that we just booted. And there we are, Vagrant Ubuntu Trusty 64. So now I actually have something that I can do any kind of things I want with. just like on the public cloud. So let's try to install some software. So if we do a sudo apt-get install, let's put on Apache 2, and let's put on Graphite Web, because we love to work with Graphite. And I'm going to say yes, I actually want to download and install that software, and our Ubuntu box will go out on the internet, it'll grab the things that we need, and it'll install them on the host. And this will go faster or slower depending on your internet connection. So let's let it run. And through the magic of video editing, we know this will take no time at all. Okay, so our software is installed. But is it really? Well, let's check. So we'll do a which Apache CTL, and we'll see that we actually have our Apache CTL there. But what about Graphite? So we can do a dpackage -l, and we can grep for Graphite. And we can see that we have Graphite Web installed. Well, that's pretty cool. We have the software that we wanted, and it's on a virtual machine, which means that we can do whatever we want with it. So I can ls, I can see that there's nothing on here. I can say which ls. Oh, that's in bin ls. Well, sudo remove bin ls. Now I don't have an ls binary. Oh gosh, this machine's all messed up. All right, let's get out of here. So we're going to exit, and once we do, we can do a vagrant status, and we can see that our virtual machine is actually running. But I really messed up this machine. I can't even ls on that host anymore, so let's get rid of that box. So we'll vagrant destroy -f, and vagrant will happily destroy the virtual machine that we were running. Virtual machine's gone. Now if I do a vagrant status again, I can see that I don't actually have a virtual machine running. So when we bring up a virtual machine, installing a package every single time we want to do testing, that can kind of be a pain. So how can we make that easier? Well, let's actually edit our vagrant file and make it easier. So here we're going to go down to our shell provisioner, and we're going to uncomment that. And we're going to make it so that the shell provisioner actually runs whenever the virtual machine starts. And we can use different shell provisioners or Docker provisioners or Puppet provisioners or all kinds of other provisioners that are available in order to configure the virtual machine. But for these purposes, let's just go with the shell provisioner. Now we can do a vagrant up, and we'll have vagrant bring up our box again. And being able to destroy machines, bring machines up, destroy machines, bring them up, and do all kinds of things in between allows us to do experimentation, just like we talked about in the third way of DevOps. And with a virtual machine that we can control like this, we can iterate on exactly what we would want our virtual machine to do. So let's let this go, and then we'll check out our virtual machine. Okay, we can already see that the booting of this virtual machine looks a little bit different than the last one that we did. So let's vagrant SSH in and find out about it. And now I'm on my host, and if I do a which Apache CTL, I actually have Apache CTL. If I do dpackage -l, and I grep for Graphite, I actually have Graphite installed for me already. So these are things I don't actually have to do anymore. If I do an ls, I can see that my ls binary is there because this is a brand new virtual machine. And so we can keep doing this. We can change our shell provisioner. We can do whatever we want so that we have the perfect test environment for us whenever we want to boot this virtual machine. And once we're done with this virtual machine, we can always go back and vagrant destroy. And Vagrant will happily clean up this virtual machine for us and make it so that the next time we boot, we have a nice clean virtual machine again. So in this video, we set up and launched our very first test environment. And we know that getting feedback early in the process is much cheaper than waiting till things get closer and closer to production. In the next video, we'll do a little bit more advanced configuring and launching with Vagrant. See you there. Hi, welcome back. In this video, we're going to look at configuring and launching with Vagrant. We're going to look at a more advanced Vagrant setup in our Vagrant file that does a couple more interesting things, including allowing us to work with multiple machines. Then we're going to look at how we can use Vagrant in a much more realistic development environment that we can test things out in. And then we're going to use that new environment and make sure that everything works the way that we expect. For this video, you're going to need the same things that you would have needed in the last video. You're going to need to install Vagrant. You're going to need to have VirtualBox there. You're going to need to have an Ubuntu VirtualBox image, and you're going to need the GitHub repo for the course. If you've done this for the last video, you do not need to do this again. You only need to do this once. You just need to get into video 3. So if you've checked out the GitHub repo, you should see that you have a directory tree that looks like this. You have a top-level directory, and underneath that, you're going to have Salt, and you're going to have Vagrant directories. And the reason that these things are next to each other on the directory level is that we're actually going to reference the Salt directory from the Vagrant file. If you don't have these on the same directory level, then when we use the Unix notation to say go up one directory and go down into the next one, that won't work. If you're on Windows, you may have to adjust this in order to get this to work properly. So the first thing that you're going to want to do is you're going to want to change directories into the top level directory and then the Vagrant subdirectory underneath that where our Vagrant file is located, because we're going to want to be working with our Vagrant file. So make sure you have that ready. Okay, great. So if you have that ready, then you should have something that looks like this. You should have a Vagrant file and you should have a Salt directory. Now the Vagrant file we'll look at in a second. The Salt directory actually has a few things in it. It's got a minion file and it's got a key directory. So if we look inside the key directory, we'll see that there's 4 keys in there. And those are the private keys and the public keys for the master and the minion that we're going to actually set up right here on our desktops with Vagrant. And the minion file is actually just a pretty generic minion file, which has like all the standard things that you would expect for Salt. Okay, now the Vagrant file, something that's pretty important to look at. So we go into our editor here and we can see the Vagrant file. And I use the Atom editor and it understands this to be having Ruby settings, so it will actually highlight the things correctly. So let's look at what this Vagrant file does. And granted, this is a little bit more complex than the last Vagrant file we had. So we're going to have our VirtualBox that's an Ubuntu Trusty64 image, also known as 1404. We're going to tell it that we don't need it to update the guest editions. However, if you have trouble mapping directories, you might want to update your guest editions. For me, this worked fine without having to do any updates. Now we're saying for VirtualBox, we want, again, to show the GUI because we're just getting started with Vagrant and with VirtualBox, and it's comforting to be able to see the feedback. And we're going to bump up a little bit the amount of memory over what we used the last time, just to make sure that when our masters and our minions and all those different daemons are running, we don't run out of memory. Now, here's where we start to get a little bit tricky and interesting. Here we're going to run a shell provisioner that says that we're going to make a minion.d directory. And that minion.d directory is actually going to be configuration for the minion. And what are we going to tell it to do? We're going to tell it that we want to set the master to 192.168.50.10. And we're going to put that into a master.conf file, which the minion will actually read. And we're also going to set this hash type because otherwise Salt will complain about using MD5. Then we go down and we say for Salt, we do not want to run masterless. We set that to false. We say that the minion config is going to be in salt minion. That's the file that we just looked at. We don't want it to run a high state because we want to run the high states. And then we're going to have the SSHPTY set to false, which helps the minion run. Now, we're actually going to configure two different machines. On the top here, you can see it says config VM define master, and on the bottom, it says config VM define minion. We're actually going to run two different virtual machines and have them talk to each other and have the master control the minion. So the thing I was talking about before with map directories, master VM synced folder salt is going to be mapped to srv salt on our host. So that's the ... notation that I was mentioning, and you may have to adjust this on a Windows machine so that it actually points at the correct directory. But we know that salt likes to look for configuration in srv salt, so here we're actually going to say, no problem, you're going to use the one off of my file system. Then we're going to set a private network IP to 192.168.50.10. If you have 192.168.50 as your home network, then you might want to adjust these a bit so that you actually have an IP address that doesn't conflict. And then we're going to tell the shell provisioner to run that says that the ID for this host is going to be master because we want to call it a master. And then we're going to install the keys that we would have ordinarily installed otherwise. And you've probably seen in one of the other videos, we accepted the keys. Well, in this case, we're going to pre-populate the keys on the master, so we don't have to worry about that step. That will actually be done automatically for us. And then there's a bit of ordering problem with Vagrant, so we're going to work around that, and we're going to copy in some of the minion key things that are necessary and restart the salt minion. And then here's the configuration for the minion, which is actually a little bit simpler. We're going to set its IP to 192.168.50.20. We're going to say that we want the ID for this to be minion because we had one called master. We're going to actually provision the keys that we need on here for the minion. You'll notice we only have 2 and not 4 because we don't need to populate the stuff for the master. And then we're going to do a little bit of that fixing that we had from before for the minion. So that's kind of cool. And let's see if any of this works. So let's go back to our terminal, and we're where our Vagrant should be, right? We have our Vagrant file, and we're going to say Vagrant status, because that's going to tell us what machines we have available. And as you can see, we have a master and a minion, but neither of them is created. So let's get those started. We'll do a Vagrant up master, and this is Unix, Vagrant up minion. And that just means once you've brought up the master successfully, then bring up the minion. And the reason that we're doing it like this, instead of bringing them up at the same time, is we want to make sure that when the minion comes up, it has a master that it can talk to. So get that started. And this is going to take a while because it's going to provision 2 virtual machines, and it's also going to install salt and copy all the things into the right place and stuff like that. So for me, obviously, I'm going to edit this out in the video, but don't be discouraged if when you do this, it actually takes a little while. And the fact that it takes a while is okay because we're going to do development on here afterwards. And when we do, we're not going to be tearing down and building up the machine quite as much. So this will be done in no time at all. Okay, great. We can see that our process of bootstrapping everything has completed, and that might have taken a little while depending on the speed of your machine, the speed of the internet connection, things like that. So if we do, okay, so that completed. That may have taken a while depending on the speed of your internet connection, the speed of your machine, things like that. So let's see what we've got here. Let's do a Vagrant status, and we should actually see that we have a Vagrant master and a Vagrant minion both running, and we do, which is cool. All right, so let's get on the master, and we should be able to control all of our machines from here, just like we've done in the past. So if you remember, there's actually a bug in the salt master. So let's check for that. And actually, it looks like everything's okay here. So let's do a sudo salt star test.ping. And we can see that both our minion and our master are answering. And it might be a little bit hard to see, so you can see that those things are set to true. Now, if we want, we can control our minion, or we can control our master, but probably more interesting to control the minion. So if we do a sudo salt minion, and we tell it to run a high state, then the minion should go off and run what is configured to run in the top.sls that we had in our salt configuration. And so we can go here and we can look at our salt configuration, and here's our top.sls, and it says it's going to run graphite and it's going to run tuning. Remember, from graphite it's actually going to install some packages and enable the carbon cache. And for tuning, it's going to set the number of file descriptors to 65536. So let's check back, and it's still running. So let's give it a little bit of time because we could have a slow, well, I guess it's done. So we have our stuff set here, and it's set to 65536. Now, we talked about mapping. So if we look here in SRV salt, we've got graphite, top, and tuning. Well, this is really interesting because now I have two machines and they're both talking to one another. The minion's talking to the master's talking to the minion, but I want to do some development on my salt states. So if I want to do that, I can go back to my editor, which is editing files locally on my file system, and I can tell it that I want to change the number of file descriptors to 120,000. So I'm going to save that. And then I'm going to go back to my terminal, and I'm going to actually run the high state one more time. And when we do that, we should see that we now have 120,000 as our value. This is awesome. We can actually edit things on our desktop using our regular development environment, the editor that we love to use, and have all those changes reflected inside our development environment, which is running inside virtual machines that we can do whatever we want to and tear up and bring down and do whatever we want to do with them. So that's pretty awesome. So in this video, we looked at infrastructure as code as part of a continuous delivery lifecycle and looked at setting up an advanced Vagrant environment that we could use our regular development tools to work on our infrastructure as code. In the next video, we're going to continue examining infrastructure as code when we treat it like regular code and do testing with server spec. See you there. Hi, welcome back. In this video, we're going to look at testing with server spec. We're going to take a look at implementing a continuous delivery pipeline. What tools and software can you use to actually build the pipeline? Then we're going to look at server spec, which is an example of a tool for testing that's written in Ruby that will allow us to test infrastructure. We're actually going to test the salt states that we've been working on in the past few videos to make sure that salt is actually doing what we expect it to do, and then we'll give you the opportunity to experiment with server spec. To build a continuous delivery pipeline, you actually need two components. You need the thing that kicks off the tests, and you actually need the thing that runs the tests themselves. So, to kick off the tests, we can use something like Jenkins or Go, which are both open source tools, and you can find them at the websites listed on the screen. You can also use commercial offerings. There's commercial software, there are commercial websites that offer this as a service, and you can use any of those things, and they will actually kick off the tools that do the testing. And then you need the tools that do the testing. With these tools, like server spec, test infra, test kitchen, Rouster, which are infrastructure as code testing tools, you declare what the machine should look like and what the conditions are to test for, and then these tools will actually run those tests. In our case, we're going to use server spec. If we were doing application software testing, there are lots of other tools that are available to do the testing, and a lot of those are even built into the language that you're actually going to use. Because we've been doing infrastructure as code, we're going to use server spec to inspect the salt code that we've written. So, to get started with server spec, we're going to need to have two things. We're going to need to go to serverspec.org and look at how to install it, and we're also going to need the Mastering DevOps GitHub repository, which has the necessary files for this video in order to be able to do testing. So, if we're going to go to our web browser, we're going to notice here I have Cherubi. And the reason I have that there is just to say that you're actually going to need Ruby installed on your machine. So if you have an operating system that doesn't come with Ruby standard, as well as Ruby gems, then you're going to need to go and install Ruby and Ruby gems to make sure that you can actually install server spec. In my case, I use Cherubi because I like to have a local installation of Ruby. So if you look at my command line and I do a which Ruby, you'll see that I actually have a local install of Ruby. I'm not using the user bin Ruby, the system Ruby. So back to server spec. So once we know we have Ruby installed, we can go to server spec and we can see that for installation, we can do a gem install server spec. So let's actually do that. Going back to our terminal, and we'll say gem install server spec. And it should go out to Ruby gems, and it should download it, and it should install it, and now that's ready to go. Now, what's the next thing that it says? It says that we're going to run a server spec init. So I'm going to go back and run server spec init. And it's going to ask me a couple of questions. In my case, I'm going to choose Unix. And I want to use SSH. And am I going to use Vagrant? Well, yes, I am. And it knows that there's a Vagrant file there, so it's going to ask me if I want to auto-configure from the Vagrant file. And I do. And the Vagrant file that we're going to use is the exact same Vagrant file that we used in the last video. So if you want a more in-depth view of what's happening in that Vagrant file, you can go back to the last video and check that out. I'm going to say I want it to install the master. And so it's actually put a couple things in my directory now. I have this rake file, I have in the spec directory, I have a spec helper, and I have inside the master directory a sample spec.rb. Now, if you've got the checkout of the GitHub repo, you'll see that there's a graphite spec.rb. So we can actually go into the spec directory, and we can see in the sample spec that it's got a bunch of things about Apache 2. And let's just get rid of that because we're not actually going to do those tests. However, I've got this graphite spec.rb, and so let's check that out. All right, that will be a lot easier to see inside of a text editor. So here, graphite RB, I'm going to use spec helper, which we saw was one of the files that got installed. I'm going to describe that inside my virtual machine, I want to have graphite web and graphite carbon installed. So that seems pretty simple because we know we had that inside of our graphite configuration for salt. So let's see if that would work. Go back to our terminal. We're in the master directory. So we're going to go up and then we're going to look, and here we are. We have our rake file, vagrant file, salt, and our spec directory. So rake files are like make files. I don't really want to get into it too much because it's just a bunch of Ruby. That's probably not that important to you. But we also have our vagrant file. Our vagrant file, like we said, is the same one with our master and our minion configuration. So we're actually going to type rake spec. And this will take a while because it's going to actually spin up a virtual machine. And you'll notice that your virtual box will spin up and things like that. But we'll let it go, and then we'll edit this out, and we'll come back, and we'll see what's happened. Okay, so our test finished running. That took a while because we had to start up a virtual machine, install salt, do all kinds of fun things. But there's a problem. Graphite web should be installed, and graphite carbon should be installed. Uh-oh. Well, the good thing is, in our Vagrant file, we said specifically that we didn't want our high state to run. So let's go check that out. If we do a Vagrant status, we'll see that we actually have a master running. And there it is. So let's Vagrant SSH to our master. And once we're on there, we can make sure that the salt master is running. And it's only running a single thing started by PID1, so that's great. So let's do a sudo salt call state.highstate. And this should actually install the pieces of software that we were expecting to be installed. So let's let salt do its thing. Okay, it looks like it installed some software. So let's go back and run our rake spec again. And this time it doesn't have to fire up a virtual machine because that virtual machine is actually already running. So it shouldn't take anywhere near as long. And look, we actually have Graphite Web should be installed and Graphite Carbon should be installed. Great, we have 2 tests and they're passing. We were able to test whether or not salt actually did what we said it was going to do. And it did. That's pretty cool. And normally we wouldn't actually get on the host and run these kinds of high states ourselves. We would have either Puppet or Chef or Salt or whatever configuration management tool we have actually run these things by itself automatically, kicked off by Jenkins or Go or something like that. But in this case, we wanted to demonstrate that we could actually prove that the thing was actually testing our virtual machine. So if we go back to our Graphite spec, we can see that we have Graphite Web and Graphite Carbon, but there's other things we could do. We could describe what port something should be listening on. Does the Carbon cache actually listen on port 80? No. Well, what port does the Carbon cache listen on? We can actually go look that up on the internet and change this to be able to test whether or not that's listening as well. Or what about the Carbon cache process? Maybe you want to go to the server spec website and see if you can figure out how to test for the presence of a process that should be listening. You can experiment with testing, and once you're done, we'll move on. So, we actually have automated code testing happening. It's happening for our infrastructure code. We still need monitoring, but before we do that, we're going to do one last stop in our continuous delivery pipeline and ask, am I ready for production? And in the next video, we're going to talk about different deployment strategies that you can use to get your code to production. See you there. Hi, welcome back. In this video, we're going to ask, am I ready for production? We've already developed our continuous delivery pipeline. We've written code, we've tested the code, but how does that code actually get to production? Well, in this video, we're going to look at deployment concepts. We're going to talk about canaries and rolling restarts, which are 2 specific deployment concepts. And then we're going to look at Netflix's blue and green deployments, which is how they deploy their software on the Amazon cloud. You're going to see elements of both canaries and rolling restarts throughout the different things that we're about to talk about. The idea of a canary comes from a canary in a coal mine. In the old days, when miners wanted to know whether the air in a coal mine was safe, they would actually put a canary into the coal mine. If the canary came out alive, then the air was safe to breathe, and if the canary didn't come out, or the canary was dead, then that wouldn't be a good place for the miners to go. Well, we can do the same thing with our code. We can expose our code to production, and if we don't have any problems, then that code is probably safe to keep in production, and if things go badly, then we want to actually not have that code exposed to our customers. And we can do our canary launches a number of ways. They can be tested via feature flags, we can roll canary software onto a host, or a number of hosts, or we can even do a rolling deployment, which goes something like this. I have a number of servers, and they're behind a load balancer, and I want to get my code out. So I want to test a new feature, or I want to see if bugs are fixed, or if I want to see if new bugs are introduced. So what I do is I put my code onto one of the servers, and I take it out of the load balancer. So that machine is not getting any traffic anymore. Now that the new code is on there, I put that machine back into the load balancer, and I go to our next machine. I take that out of the load balancer, I put the new code on, I put it back, and I keep going until all of my servers are done and rolling my new code. Now, while I'm rolling things out, if I see something wrong, then I can actually go back and roll my servers back to the previous version of the software. If everything is fine, then I can just keep the software that I've deployed out on the servers. Basically, I can test what's going on with my software and decide what I should do based on the results. Now, Netflix has taken this to a new level on the Amazon cloud, relying on the features of elasticity that are available on EC2 or the Elastic Compute Cloud. The way that Netflix does it is they have a set of servers that they call the blue servers. And the blue servers are the code that is running in production already. And this is taking traffic from the customers, and everything's great. When they want to put out a new release, they deploy a set of servers called the green servers. And obviously these servers aren't colored, this is just their designation. And the sizes of these tiers can be in the single digits, it can be dozens, it can be hundreds of machines that are spun up. So pretend it's hundreds of machines. Now we have hundreds of blue machines and hundreds of green machines that are all ready. And the blue traffic is actually already live. That is the active servers. And when I'm ready, I'm going to tell my load balancer to actually shift some of the traffic onto the green servers. So now I'm running a mix of blue and green, and I'm migrating the traffic from the blue side to the green side. And they have systems that watch this migration happen and look at the performance of both the blue servers and the green servers. And the systems try to decide whether or not the changes that have happened in performance or any other measure they want are significant enough from what happened on the blue servers to when they actually went to the green servers. If the system decides that everything's okay and the green servers seem to be performing okay, then all the traffic winds up on the green servers, and the green servers now act as the brand new production servers that are serving traffic. That means their memory, their CPU, all kinds of things are okay according to the specifications that Netflix has laid out. However, if this automated system determines that whatever was happening with the green servers was not okay, they can actually roll this traffic back to where it was. In order to do this, you actually have to have really good metrics and monitoring to be able to make that decision. Luckily, that's exactly what we're going to talk about in the next section. In this section, we asked, what is continuous delivery? And we set up our very first test environment with Vagrant. Then we configured and launched a multi-server test environment with Vagrant, and we were able to control a minion from a master. Then we did server spec, where we actually tested our infrastructure using code to make sure that our infrastructure's code was okay. And in this video, we asked, am I ready for production? In the next section, we're going to look at one of my personal favorites, metrics and monitoring. See you there. Hi, welcome back. In this section, we're going to talk about the M in the CAMS model, measurement. We'll take a look at measurement concepts, so we'll have a framework for understanding the rest of the things that we're going to do in this section. We'll take a tour of Graphite, one of the most popular open source metrics and monitoring tools available today. We'll talk about getting our data into Graphite and see how to do that, and then expand upon that as we talk about monitoring agent examples, which will now allow us to send lots more data into Graphite. And finally, we'll take a look at actionable data. In this video, we're going to discuss measurement concepts. We'll talk about the different types of metrics that you can send into your metric system, in my opinion. We'll talk about the push versus pull debate, which has been raging in the monitoring community for years and years and years. And finally, we'll talk about dashboard pros and cons. So there are a number of different kinds of metrics that you can send into your metric system. One of the most important, but certainly not the most important, are system metrics. The example on your screen shows CPU metrics, and it can be other things like that. It can be memory, it can be disk, it can be network, it could be your load balancer, how many requests is it serving a second, what are its response times. But system metrics tell us about the behavior of the underlying system. If I release a new piece of software and my CPU utilization goes way up, is that okay? How about response time? It really depends on what we define as acceptable for our system. But our system metrics give us an understanding of some of the underlying behavior of our entire system. Another kind of metric we can collect are application metrics. In the example on your screen, it's number of items in Memcached, but it can be things like number of items in a queue or a cache. It can be timing metrics, like how long does it take for a call to a REST service to come back. And in order to get application metrics, we either collect them from the application that we're using, or we need to instrument the application code. And these application metrics tell us about the nature of the application itself. What is the application doing internally? It's also really useful if you want to find things like bottlenecks or bugs in our application, because this gives us a lot of visibility into the internal workings of the application. And the third kind of metric are KPIs, or key performance indicators. The example here is the number of calls into our customer service center. If we do a release and the number of calls goes up, we want to know about that. One of the great things about KPIs or business metrics like this is it gives us a holistic view of the system. Like we talked about before in the first way, we have to have a systems thinking approach to what we're doing. And in this case, these business metrics give us a systems thinking approach. We're looking at how are things affecting our customers. If we looked at one small part of our system, say our system metrics, and we didn't notice that we're having a negative effect on our customers, then we're not having a systems view of what's happening. So the business metrics are very important, and we can track them. So that's great, but how do we get things into our system? Well, there's two schools of thought. One is the push model. In the push model, the agents or the applications or whatever we're monitoring push their metrics into the metric system. And this plays really well into dynamic infrastructure, service-oriented architectures, things that would use, say, service discovery, where something would register in Zookeeper, and we would use that to find like Memcache or our metric server or things like that, because we don't actually have to go out and find these things, because these things will automatically go and push their metrics into the central metric server. And this is great for short-lived infrastructure. Right now we have new things on the horizon in DevOps, like serverless and AWS Lambda and Docker, and all of those things can push their metrics into a metric system. One of the other advantages is that our application, or the agent that speaks to our application, only needs to understand the metrics protocol. We don't actually have to have our metric system understanding how to speak SNMP and SMTP and any other kind of protocol that would be out there that we want to collect metrics from. Instead, everything speaks this one protocol of the metric system, and they push their metrics into there, which means that we can distribute our work to the edges. We don't have to have a massive metric server which goes out and does polling in addition to having metrics on storage, on disk, and rendering them and things like that. Another advantage is that if I've collected all the metrics that I want to push into my system, my metric system, and I want to have redundancy or resiliency, once I've collected those metrics, sending one packet to one place and another packet to another place is not a big deal, because I've already done all the hard work. So it allows me to push to multiple locations at once. The other side of the coin is a little different. With a pull model, our metric system goes out and collects metrics from all the different things that it wants to monitor. So the classic example of this would be SNMP, which is on our routers, our switches, mostly of our network gear. Even our host can actually speak SNMP. There's some hybrids. There's things like JMX Trans, which does JMX bean collection. It has a poller, which goes and polls JMX, but it even has a graphite output, which will allow it to push metrics in. There's a new piece of software on the metric scene called Prometheus that's decided to go with an all-pull model. If you remember Nagios from many years, where lots of people have been using it, it is mostly a pull model with some push allowed, and Nagios calls those passive alerts. And one of the great things about Nagios was that it also does alerting. And alerting is really important, and we're going to talk about that a little bit later. I think that the pull model is probably best for longer-lived infrastructure. Like if I have a data center where things aren't going to move around a lot. Because when I have something like Lambda or Docker, where my application can live for milliseconds or maybe even a few seconds, how am I going to pull that? Pulling information out of those short-lived pieces of infrastructure is a pretty difficult problem. If you want to know more about some of the pieces of software we just mentioned, you can find out about them here with the resources on the screen. And we're going to talk about dashboards. Dashboards are great. They can tell us all kinds of things. Like you can see here on your screen, they can tell us about disk, they can tell us about CPU, they can tell us about memory. And there's some great things about dashboards, and there's some not so great things about dashboards. One of the great things about them is we get our information at a glance. Just by looking at that last screen, you can see all kinds of things about the system just with a single look. When we're troubleshooting an application, I can pull up a dashboard that's built specifically for that application. Maybe it's my web server, or maybe it's my application server, and I can see a number of different metrics about that application. I can see response times, I can see number of requests, I can see all kinds of things, and that really allows me to understand the nature of my application. When we're doing things like that, you should always remember to mark your deploys. So if you see that line on the graph and something changes, you'll know, or at least have an inkling, as to why that thing changed. And dashboards are great for troubleshooting, but they're also good for exploratory testing. If I'm developing a new application and I'm watching the dashboard as I develop, then I'm actually going to get to know what's normal for that application. And having that idea of acclimation to normal is really important, because if I don't know what my baseline is, how am I going to know what's an anomaly? We used to have an information radiator at a place I worked, and it would just sit in the ops area. And people would come into the ops area to talk about this thing or that thing that they wanted to get done. And sometimes they would walk over to the dashboard and they would say, "Hey, what's that?" And we'd look at it and we'd say, "Yeah, what is that?" And sometimes it would be something that we should investigate. Maybe it was a problem. But by having that dashboard up at all times, we were able to acclimate to what normal is for that application. And getting used to normal is really important. And another great thing about dashboards is it allows us to highlight really important metrics, things that we want other people to know what's normal. This is the part of sharing that we'll talk about in the S in the CAMS model. If you go to Etsy in New York, one of the online marketplaces, they're famous for having dashboards when you first walk in, and they show lots of metrics that are really important to the company. And when you walk into Etsy, you'll get an idea right away of what are things that the company considers to be important. But there are some cons to dashboards. For one, who wants to stare at a dashboard all day and night? If I want to know about my CPU utilization, I don't want to sit there and look at a dashboard all day. Can I never go to sleep? Can I never take a vacation? That's a problem. And also, it doesn't scale. If I want to monitor 10 metrics, that's one thing. But what if I want to monitor hundreds of metrics? At Librato, we monitor hundreds of thousands of metrics. I can't have dashboards all over the place that have every single metric that I would ever want to look at, and I would never be able to look at them if I did. So what's the solution? We need to monitor our metrics. We want to have a system that can actually look at those and make decisions. Before we do that, though, we're going to need a metric system that can ingest our data and store it. And we're going to talk about that in the next video. In the next video, we're going to take a tour of Graphite, one of the most popular metric systems available. See you there. Hey, welcome back. In this video, we're going to take a tour of Graphite. We're going to take a look at Synthesize, which is a GitHub repo created by Jason Dixon, who's the current maintainer of Graphite, that makes it really easy to get a full working Graphite installation going in a virtual machine on your desktop. We're going to look at the Graphite listeners, what ports it listens on, which we have some idea about already from previous videos. We're going to take a look at the data storage for Graphite, where it stores its files, some things about the nature of that storage, And then we're going to look at some things that you can use for troubleshooting, like log files and things, in case you actually ever need to do that with your Graphite installation. And finally, we're going to start to look at the user interface for Graphite and examine it. In order to get started, you're going to need the synthesize repo checked out onto your machine. And there's instructions on Jason's synthesize GitHub page for how to install it. So let's go check that out. So first we have our synthesize URL that we need to copy. So I'm going to copy it, and then we're going to go over to a terminal, and we're going to git clone that synthesize. And it'll clone out, and everything will be fine. Now, Jason actually has instructions for how to run it. And for us, we're going to use the Vagrant installation because we already know that we have Vagrant installed and ready to go. So Jason says that you should go into the synthesize directory. We're there after we've cloned it, and we're going to install this plugin. So go back to our terminal, and we go to synthesize, and we will do a plugin install, and that's cool. And then our next step, according to Jason, is that we're going to do a Vagrant up. So not a problem. This is something we're very used to already, so we should be pretty ready to go. Okay, now we're going to do Vagrant up, and as we know, this will take a while to install. You'll notice that we didn't do a Vagrant box add this time because the purpose of that was to make sure that we actually had Vagrant set up properly. And now we know that Vagrant is set up properly, we're going to actually download and install whatever boxes we need in order to make this work. And through the magic of video editing, it should take no time at all. Okay, so our Vagrant box is launched. And we know this drill, so we're going to Vagrant SSH into our Vagrant box. And here we are, right inside of our synthesized box, which is just another box that's Vagrant. So, if we want to start exploring around, let's see what ports are listening for our Vagrant. So we'll do a sudo lsof -i -p, and we'll see what's listening. So we can see that there's a number of things listening on this box. In addition to our RPC binds and things like that, we actually have our Carbon cache listening on 3 ports, 2003, 2004, and 7002. And that will become important in the next video when we submit our metrics in. We can also see that memcached is running. We have Apache running that's listening on multiple hosts, multiple ports. And we have StatSite, which is a version of statsd that's written in C, so it's really, really fast. So if you want to explore, let's go to where our Graphite is installed. So if we go to op Graphite, we can see that there's a number of directories here. And the storage directory is really interesting because it lists a number of different things. One of the things that's interesting is RD. So Graphite did and still does store metrics in RD tool if you actually want. But the newest versions of Graphite all use Whisper, which is a slightly better database than RD tool. So what could be in our Whisper directory here? Well, there's collectd and a Carbon directory. So let's look at our collectd directory, which is a common agent for collecting metrics. And we can see that there's a directory called Graphite, and there's a lot of different metrics that are available. So if I went into like my CPU directory, and I did an ls-l, I can see that there's all kinds of different CPU metrics that I could grab. And you'll also notice that the file sizes are all the same because with Whisper databases, they're pre-created, and as the data gets older, it gets rolled up, and so the database size never changes. So that's something that we should keep in mind. And if I'm ever wondering whether or not my metrics made it into Graphite, I can always go into the Whisper directory and look around and see whether or not the Whisper file has been created for that metric. So what other things can we look at? Well, we can go to opt graphite conf and we can look at some configurations. For example, we can look at our storage schemas. Our storage schemas show us that the roll-ups for our metrics when they come in for collect D are 10 seconds get rolled up into 1 week and 60 seconds get rolled up into 1 year. And we can actually go in and change different patterns to have different roll-ups. That's kind of cool. But what if I have my metrics coming in, but there's something weird going on with them? Well, if I go up here to storage and log, I have my log files. And so carbon cache is something we're familiar with. There's only one carbon cache running on this machine, and we can see there's a number of different logs that are available. The first one we might want to look at is the creates log. So if we cat the creates log, we can see that there's a number of metrics that were created, and you can actually see that Whisper has created the Whisper files, or the Whisper databases, I guess, for those metrics that have come in. So this is a good place to look when I'm creating brand new metrics. We've also got the console, which is the Python console, and we also have the listener. And so whenever something makes a connection into Graphite to the carbon cache, we can actually see this listener running. And we can see that there's things that are connecting to it. So what else can we look at? Well, we saw in the documentation, if you were paying attention, that we have vagrant listening on different ports. So one port that is mapped is 443 gets mapped to 8443 on my host, and another is 2003 gets mapped to 22003. And this is our submission port, and this is the port for our UI. So let's take a look at the UI. So if I go here, I can see that I tried to connect to 8443, but nothing was available at the time. Now I can see that there is a connection available, and it's complaining about the certificate because there's no certificate called localhost that's been signed by any kind of certificate authority. But we know that this is okay, so we're going to proceed to localhost. And here we are. We actually have the Graphite web interface up and running. So we knew that we had some CPU metrics that were collected before, so let's go look for those. They were under collect D in Graphite, and they were under CPU 0. So let's grab some. Let's put the wait times on there. Let's put some user times. Let's put some system times on there. And that's pretty cool, except that I can't really see what's going on here. Oh, we're looking at the last 24 hours. Well, we haven't collected 24 hours worth of data, so let's change that to maybe the last 10 minutes. Oh, okay. That's much better. Now I can actually see what's going on here. So if I want to, I can go back to my web browser, and here I am with all my metrics coming in. So what can we do with these things? Well, we can modify them if we want. We have graph data, and here we can see we have CPU, wait, user, and system, just like we talked about. But we can apply functions to them. We can combine them. We can take sums. We can take averages. We can scale them like we have here. We can take the absolute values. We can calculate things like moving averages. We can filter the data. Maybe we want something where the minimum is above some number. Or we can do other kinds of special functions, like changing things to dashed lines. We can change legend names. We can do all kinds of stuff like that. But the interesting thing about these different functions is that they're all part of an API. And to prove that, let's look at this actual graph. So if I right click and we say copy image address, I can actually take that image address and I can put it into a new tab, and I'm going to put that in. Oh my gosh, I actually have the graph that I was looking at in the composer right here on my screen, because the URL is an API, and when I make this call in the web browser, I'm making a call to the Graphite engine and having it render given the parameters that I have in the API. So let's see what kinds of things are in here. So we go to our composer and we're going to paste the exact same thing that we had before. And we can see that we have this render engine, and we have the width, and we have the height, and we've got some collectee graphite CPU weights. We have user, we have system, and it says from minus 10 minutes, which is the last 10 minutes. And that's exactly what we're asking for. The ability to modify this URL is incredibly powerful. If we go to the Graphite Render API, we can see that there's all kinds of different transforms that we can do. We can change the targets that are there, which are the metrics we're going to graph. We can change from and until times. We can render things out as PNGs, as CSVs, as JSON. We can change the parameters about the graphs. We can change fonts. We can change all kinds of things. And the fact that these things are available in the API, and all we have to do is construct the proper URL in order to get the graphs that we want, means that we could generate these graphs using code, as long as we understand the API. That means we can generate dashboards wherever we want, in whatever way that we want, because it just turns into a matter of programming. So now that we know that we can collect our data and put it into Graphite and render it, how do we actually collect the data and put it into Graphite? Well, that's going to be the subject of our next video. See you there. Hi, welcome back. In this video, we're going to talk about getting your data into Graphite. We're going to take a look at some bash examples for how to get your data into Graphite. They're going to be really simple, and they're going to prove that if you can talk to the Graphite server, if you can make a socket connection, you can get your data into Graphite. Then we're going to look at a little bit more complicated example when we talk about Python. And the Python example will actually show how to do some timing and submit that into Graphite. And then we'll talk about where we're going to go from here. In order to participate in this video, you should have the following resources available. You should have the GitHub repo checked out for this course, Mastering DevOps, because that's where the scripts are that we're going to use as our examples. You should have Synthesize running. If you got that running in the last video, you can use the exact same Synthesize installation that you used then. You don't have to tear it down or make any changes to it. You can just go with it as it is. And lastly, you might want to have the Render API documentation available. In this video, we're going to change the URL of the Graphite render, which we know is also an API, and you're probably going to want to follow along and try that yourself. In addition, we know from looking at it in the last video, there are a lot of different options that you can use to change things inside the API. So you might want to use this opportunity to experiment with the API and change a bunch of different things. So the first thing we're going to have to do to get started is get onto our Synthesize instance. So I'm going to do just that. And if I go to my terminal, you'll see that I have myself placed into the storage whisper directory. And if I ls, I'll see that I have two things that are in there, carbon and collectee. And those are metrics hierarchies that are collected by default for Synthesize. So that's pretty cool, but let's do something a little bit more interesting. So I've got a couple of different scripts here, and they're checked out locally, and they are 1, 2, and 3. So pretty easy to follow along. So let's look at them, and probably a little bit easier to look at them inside of an code editor. So I'm going to bring up Atom, and we can see here for one POC, it's very simple. It echoes Mastering DevOps section 6. It submits a value of 3, and it submits a date. And the date is represented as the number of seconds since January 1st, 1970, also known as Unix epoch time. And that's all we need to be able to submit a metric into Graphite. We need a metric name, we need a value, and we need a timestamp. And you can see after that, we actually make a socket connection using netcat to localhost 22003 to submit our metric. You may remember that 22003 is mapped to the Carbon cache, which you will have seen on the Synthesize page on the GitHub repo. And so here we go. We're going to copy this.
And we're going to take it over to our terminal. And let's do it. Okay, well, that's interesting. So now if we go back to our Whisper storage and we do an ls, we actually see we have mastering in there. Well, that's kind of cool. Let's check it out. Mastering DevOps section 6. And we have our Whisper file, our Whisper database. It's all created for us automatically by Graphite. We didn't have to tell Graphite that we were going to be doing this. It just happened automatically. So that's kind of fun. Well, what does it look like inside of our web browser? Well, let's check that out too. So let's change back to our web browser. And if we open this up, we're going to see mastering. And we look in there and we see DevOps section 6. That's pretty cool. Now we'll make this a little bit easier to see by making it bigger. You can see that our y-axis is at 3, so we know that's correct, but we're looking at 24 hours. So let's look at the last 5 minutes. And we should be able to see there's a blue line down here that represents the minute that we're looking at, and it has a value of 3. Now, I don't like my y-axis to have a value of 3, so let's change that to have a minimum of 0, and now my 3 is here at the top. So that's pretty cool. I can make a socket connection, I can send in data, and things show up. Now let's do something a little bit more interesting. So we're going to go back to Atom, and we're going to look at our bash example right here. And so what does this say? It says while 1, which is while true, so just continually always do this. Generate a random number and have that number be less than 500, and we're going to create a hierarchy called call center volume num calls. Now you may remember a few videos back, I actually had this graph up on the screen, and it had a bunch of values in it, and the time when I ran it then, I actually had a sleep of 60. So in this case, we're going to have a sleep of 5. And we're going to submit our random number, we're going to submit our timestamp, and we're going to make a socket connection to localhost 22,003. So the only other interesting thing about this is you'll see on the bottom here that we have our pattern for call center is a little bit different than what we currently have. And the reason is by default, Graphite expects things at a 60-second interval. And we actually want this to be a little bit more interesting. So we're going to tell it that we want things to come in at a 5-second interval because that's what we're going to do. So let's go modify Graphite for this. So under here, we still have our regular databases. And we're going to go up a couple levels, and we're going to go into the config, and we're going to edit the storage schemas.conf. And let's just drop this right in between collectd and default. So we'll format this so it looks like the rest of it. And let's put some space. And you can see down here, it said 60 seconds is what it would normally have expected. And we're going to submit on a 5-second tick. So let's actually bounce the carbon cache because that's what's required to pick up this new configuration. So sudo service carbon cache stop. And let's actually double check and make sure that it's not there. Okay, it's not there. And then we're going to start it. And we'll double check and it's there. All right, pretty cool. So if we go back to storage whisper, we'll see what we have, and let's run our 2 bash example. And hopefully every few seconds that thing is actually submitting metrics in, and we'll be able to see them. So let's go back here, and we'll do an ls, and we see we have call center. And call center volume number of calls. So that's pretty sweet. Let's go look at that in our web browser. So we head back over here, and we're going to have to refresh because we're created a new hierarchy here. And under metrics, we have call center. So volume, number of calls. And we have to remember also that we've only been looking at these things for the past few minutes. So let's change this from 24 hours to 5 minutes. Hey, that looks pretty cool. And this thing actually has 0 as the bottom value, which is pretty sweet. So I don't actually have to change that. Now, we remembered that the URL is an API. So let's try that out. So if I go over here and I do copy image address, I can take that to a new tab and I can paste that in. And lo and behold, I've got the exact graph that I was looking at before inside the composer in Graphite. Now, we remember that the render URL API documentation says that we can do a from and until. So let's change the from. Right now, our from is 5 minutes. Let's change that to something else. It looks like we can use S as an abbreviation for seconds. So let's go up here and say, instead of 5 minutes, let's do 120S. And there we go. That's pretty sweet. We actually have the ability to change it from 5 minutes to 120 seconds. So we can do other interesting things. If we go back to our Graphite browser, maybe we want to modify this. Maybe we want to apply a function. Maybe we want to take the derivative. And now we've got some pretty cool things that we've been able to do to our data. So for our last example, let's look at Python. And in our Python example, we've got a few things that we're going to do. So we're going to have a couple of different libraries that we can use, socket time, things like that. That's are going to be important for what we're going to run. And the example here is what you would do if you wanted to time how long something took. So an API call or some piece of code, an algorithm, things like that. So what we do is we mark our start time with our timestamp, and then some things happen. Now, obviously, we're going to just use some random sleep time, but certainly you could use this to wrap anything you wanted. And then we're going to mark our time complete when it's done. And then we're going to calculate what is the difference between the time start and the time complete. And the time complete's obviously going to be a higher number. And then we're going to format our message to send into Graphite. So we'll have our call center, DevOps, Python elapsed. And then we'll have two values, the elapsed time, which is our value, and the time complete, which is our timestamp. And then we'll open up a connection and we'll send it in. So let's try that. So we'll go back to our terminal here. We'll go over to our examples. We don't really need to submit any more of those other call center metrics. And we'll say the Python example. And obviously the amount of time this is going to run is going to be variable because we have a sleep in there. So sometimes it'll be quick, sometimes it'll be slow. Doesn't really matter as long as we're submitting stuff in. And you should also remember that the submission, because we're underneath this call center hierarchy, the submission time that Graphite expects is supposed to be on this 5-second submission interval. So if we submit these things in, but it's not coming in at the submission interval that Graphite expects, then Graphite's going to have to deal with that. And so we can go over and see exactly what Graphite's going to do with this. So let's go back to our web browser, and we're going to look over at call center. And we don't have Python in here, so let's reload. And we look at there, and we have DevOps, and we have Python, and we have elapsed. So if I want to, I can actually put both elapsed on there, and I can put numcalls on there. And I can actually say we want to look at, say, the last 5 minutes. And you can see that these call center numcalls is actually a lot of data on here. And the Python elapse is these little blue lines on there. So a little bit hard to see. So we can make this bigger, but instead, let's just get rid of the number of calls because we don't really need that. And now, one of the weird things is we've got this sparse data because Graphite expects to get things every 5 seconds, and we were submitting it sometimes sooner, sometimes later. So what can we do about that? Well, Graphite's got a pretty sweet function that we can apply. So let's choose that, We'll say apply function, and we want a special, and we'll say keep last value. And I don't actually need to put anything in there. What keep last value says is if you don't get something on the correct tick, then just use the last value that you had, substitute that in as the thing that's missing, and keep going. And now you can see we have a graph that looks way nicer. Cool. So, in the next video, we're going to talk about monitoring agent examples. We're going to take what we've done here and shown how we can submit metrics into Graphite, but we're actually going to use agents to actually do this for us, which will be a lot more interesting. See you there. Hi, welcome back. In this video, we're going to talk about monitoring agent examples. We're going to look at collectD, which is an agent that comes installed on our synthesize instance already. And then we're going to ask the question, well, what if we wanted to install an agent on a large scale across lots and lots of servers? And we'll look at how to do that with Diamond, which is an agent that can talk to Graphite. To be ready for this video, you probably want to have your synthesize instance up and running. It's the same synthesize instance we've been using for the last few videos. You don't have to make any changes to it. You don't have to tear it down or do anything like that. You can just use it as we've been using it already. You'll also probably want to have the Diamond webpage open, because we're going to use that to look at how to install it. And you're going to want to have the Mastering DevOps GitHub repo, because the Puppet manifest and the Diamond config file that we're going to want to look at are both located under this video in that repository. So the first thing that we're going to want to do is get onto our synthesize instance. And you can see here I'm in etc collectD, and I have a number of different files. And one of the most important ones is going to be the collectd.conf. Now, when we have our Graphite installation and we go under metrics, we know that we have collectD. And collectD has all kinds of things under it. It's got things for Apache, it's got disk things, it's got memcached, and there's lots of metrics for that. But how does collectD actually get that into Graphite? Well, we can go and look at the code. So if we look at the collectD configuration file, we can see that Jason's actually changed the name for the collectD thing to Graphite. And we can see that if we want to find out the way that he submits it, we can look here and see that he loads a plugin called Write Graphite. And here's the configuration for that. And what this configuration says is that if you're going to talk to Graphite, you're going to talk to a Carbon instance. And you're going to be talking to localhost, 127.0.0.1. We have the port 2003 commented out because that's the normal place for Carbon. And you can also see that he set it up so that any metric that's coming in from collectD is prefixed with collectD. That's pretty nice. That makes things really easy. What else do we have inside this file? Well, if we go look for memcached, we can see that it loads a plugin called memcached, and you can see that it makes a connection to, again, localhost 127.0.0.1 and port 112.1.1, which is the standard port that memcached runs on. If you're familiar with memcached, you could probably guess that it's probably running the stats command when it connects there to pull down metrics. So that's kind of cool now how collectD is able to get my metrics into Graphite. And if you want to, you can certainly explore in here for a lot more configuration for different things that you can find inside the Graphite Composer window. But what if I want to install on lots of hosts? Well, we can do that too. So we're going to change to our home directory, and we're going to get our configuration from our GitHub repo. So if we go here to Mastering DevOps, we can see that we have this URL available, and we're going to go back onto our synthesize box, and we're going to do a git clone of that repository. And it comes down super fast, and everything's ready to go. And we go into Mastering DevOps, and this will be section 6, and then video 4. And you should see that we have a diamond.conf and a diamond.pp. So let's take a look at that. And I'm going to go into my Atom editor. And if you're not familiar with Puppet, then this will look a little bit weird to you, but it should be pretty easy to follow. And it's got some things that we want to do, and it says package Diamond. We want to install that, and we want to use the provider pip. And I've already installed Diamond before, so I know that it's going to want to have a var log Diamond directory, and it's going to want to have a log file for it to write to. So let's just double check. If we go to Python Diamond, then we should see that in order to install Diamond, you should install it via pip, and then you should have a diamond.conf. So that sounds pretty good. Let's check it out. So we go back here, and we have our diamond.pp, and because Jason has set some things up in here with Puppet, we actually have Puppet already installed on the box. In the past, we've used Salt, but like we've said, the tools don't matter. It's what we're trying to accomplish that matters. You need to use the right tool for the job. And rather than install Salt on here, which would be kind of ridiculous for such a small manifest, we'll just use Puppet. So we'll actually go and do a sudo puppet apply. And then we'll do diamond.pp. And we'll see that Puppet's going to go out and it's going to grab whatever it needs to do, and it's going to install stuff for us. And there we go. Diamond package was created, these directories were created, and everything's ready to go. So the only other thing we need to know here is what are we supposed to do. So we do a sudo diamond -h, and we'll see that we can actually pass a config file in for starting Diamond. Now, what does the config file look like? We go back to Atom, and we have this diamond.conf, and this is the same thing that you have. And we've changed a couple of paths in here and things like that. But kind of one of the most important things is that we can look for prefix. And we can see that I've changed the path prefix so that any metrics that are going to come in under Diamond are going to have Diamond as a prefix, just like Jason did for collectD. So let's start it up. So I can go back to my terminal, and I can say sudo diamond -c, because that's what it says right here, and we're going to use our diamond.conf. And if I do a PS and I grep for Diamond, I can see that I have a bunch of Diamond processes running. So if I cd to opt graphite storage whisper, I do an ls, you can see now we have a Diamond directory in there. So that's pretty sweet. Let's go back to our web browser and check this out. And we know that we just created a new directory hierarchy, so let's reload. And under metrics, under Diamond, Vagrant, we have all kinds of different metrics that are coming in. So we were able to take a configuration management manifest, we were able to install Diamond, and we were able to make it work. That's pretty cool. Now, there's lots of different things we can do with configuration management, and if you'd like, you can take what we've already started with for Puppet, and you can take the configuration file, and you know that there's probably a way to start the Diamond service, and you can modify that Puppet manifest to make it install the config and start the service for you. So that was a quick example of how we can use configuration management to install another agent. Now that the data is in there, we can do whatever we want with it. We know it doesn't scale to have people looking at graphs all day, so in the next video, we're going to talk about actionable data, how to set alerts on data in Graphite. See you there. Hi, welcome back. In this video, we're going to talk about actionable data. This is also the last video of this section. We're going to take a look at what is actionable data. What do we mean when we say that? And then we're going to install Siren, which is a application that can use Graphite as its data store, and it will look for thresholds in Graphite, and if we've crossed that threshold, it will actually do alerting for us. Then we'll look at how to set an alert on a metric, and we'll trigger a notification for the alert that we're working on. So what is actionable data? Well, most monitoring systems are a collection of things that talk to things that talk to things. We've got an agent that runs on a host, and that agent's going to talk to a metric server. That metric server is going to collect whatever metrics are being submitted to it, and then there'll be some monitoring system that reads that data and figures out whether or not we've crossed the threshold. If we have, it will talk to an alerting service like PagerDuty or VictorOps or SMS or something like that, which will eventually talk to my phone and wake me up at 3 o'clock in the morning. Actionable data means that the data can actually trigger actions. We can actually derive value from that data instead of sitting around watching that data ourselves for hours on end, especially at 3 o'clock in the morning. In order to make this demo work, we're going to have to make a couple of changes to our venerable Vagrant file that we've used with Synthesize this entire time. So you're going to need to have your Synthesize box up and running, just like you've had to for the past few videos, and you're going to need to have a checkout of the GitHub repository for this course. In there, we're going to have the changes that are required and a couple other scripts that will help us out. The reason we actually have to make these changes to the Vagrant file is that we've added a port for Siren, which will be 8080, and we've converted our Apache from SSL to plain old boring HTTP. And the reason we have to do that is because there's a fake cert on the host anyways, and configuring Siren to talk to a fake SSL certificate is way more trouble than it's worth just to be able to do a short demo. So once you have those things available, you'll be ready to go and open these in your browser. So you'll get the GitHub repository for Siren, which is the tool that we're going to use to trigger our alerts. And you'll need to get MongoDB because Siren requires MongoDB for it to work. That's where it does its metric storage. So once you've got that, we can go over to our terminal and we can get started. So one thing you'll note is I'm here on my Vagrant box on the Synthesize installation, and I've got a couple of things checked out. And I've got some scripts in there, some configurations, and I've got a new Vagrant file. And the new Vagrant file has the modifications that I was talking about. So if we look at the Vagrant file, you can see there's stuff there for 8000 instead of 8080, and there's another 8080 thing further on down. So one of the cool things that you can do is, here's my Synthesize checkout that's on my regular Mac. However, on the Vagrant box, if I ls/vagrant, that looks exactly like what I had on my Mac, except the colors. But it's the same files, and we have our Vagrant file there. So to make this super easy, I'm going to copy the Vagrant file that I have here into /vagrant on top of the Vagrant file, and I'll be explicit. And now I need to actually reload my Vagrant box in order to pick up this new configuration. So I'm going to do a Vagrant reload, and this won't take as long as our initial install did, but it'll take a little while because it has to tear down the Vagrant machine and start it back up again. So we'll do some video editing, and this will take no time at all. Okay, great. So that's up and running, and I'll do a Vagrant SSH, and I can get right back onto my Synthesize machine. And here I am, and I've got my Mastering DevOps checkout already, so I'll go to section 6, 5, and I'm right back to where I was. Now, I've got a few files in here, and in order to make it easy to configure Apache, I've actually done an Apache little script, which will copy the graphite.conf, which will move it off of SSL, and then it'll restart Apache. And I noticed that I don't have execute permissions on here, so I'm going to create that, and then I can just run Apache. And so that will have copied it in, and that will have restarted it. And let's go check that out. So if I go to my web browser, and I'm on port 8000, there was nothing there before, but it says it can't do it. and I try to go there, and it says it can't do it because I'm trying to go to HTTPS. So if I change this, now all of a sudden I can get to my regular Graphite server. And that's what we would expect. And so we have our collect D metrics in here, right? And we've got things like Graphite and CPU 0, and we've got CPU idle. So that's right there. Okay, so now that we have that set up, we're going to go work on Siren. So Siren has two requirements. It needs to have an instance of Graphite, and it needs to have MongoDB. So we already have an instance of Graphite. That's our synthesized instance. So we're going to go get MongoDB, and we're going to get MongoDB 3.0 because that's what's needed for this version of Siren. Maybe by the time that you're using Siren, there may be updated to use a newer version of Mongo. But if we go to Mongo and we look at how to install it, it says that we need to get the key. So let's do that. And now that we've got the key on there, we're going to go back to our instructions. And it says that we should create a list file for Mongo. And our Siren or synthesized instance is actually Ubuntu 14.04. So I'm going to copy this. And this is going to actually create a list file for me in the Debian directories that are required for it to be able to find that. And now, what does it say? It says I should do a sudo apt-get update. And I'm going to do that. Sudo apt-get update. And this may take longer or shorter depending on the speed of your internet connection. And we'll edit out anything that takes too long. Okay, so the things that it didn't like have to do with Puppet, and that's okay because we're not going to be doing anything with Puppet at this point. So, the next thing we need to do is install MongoDB. So we go back here and it says that we want to install mongodb.org. So we'll copy that and we'll put this in here and we're going to install it. And so MongoDB is now going to get installed. Okay, so it says setting up MongoDB, and if we grep for Mongo, we should see we have Mongo running. Now, if we go back to the Siren config, which is over here, it says that it's going to have a Mongo URL, which is located at 27017. So let's make sure that that's actually the case here. Telnet localhost 27017. Oh, it answers. Great. So we have MongoDB installed. So that's cool. Now, in order to install Siren, we're going to need to go and get a jar. So here it says wget this jar. So let's go and do that. We copy this, we bring it back over, and we're going to just do that. And down comes the jar. Okay, now our siren.jar is downloaded, and if we go back, it says that we should export this Graphite URL and then run Java and things like that. But to save us a little bit of headache, I've actually made a little script that will actually do some of this. So it's going to export the Siren log path to be local, and when we run the jar, we're actually going to send the output to siren.out instead of just having stuff, fly all over our screen. So let's actually start it up. Now, if we tail siren.out, we can see that the servlet is starting, and we're going to wait until it's started up and listening on port 8080. Okay, great. There it is. It's started up and listening on port 8080. So let's check it out on our web browser. And here it said it wasn't able to be reached. And let's try that again. And now we can see that Siren is up and started. That's pretty cool. And we know that this is working because we mapped port 8080 to port 8080 and everything works fine. So let's create a check. So we go to checks and we're going to create a check. And let's just call it something like CPU, and you can see that I've done this before. And we're going to do collect the graphite CPU 0, CPU idle, and we'll set the warning level to be 90 and the error level to be 95. And you can see while I'm doing this, there's actually a graph down here that shows what we're talking about, what we're setting, what the values are. These blue lines over here should look pretty similar for people who were watching that when we looked at that earlier in our graphite graph. So I'm going to say allow no data to be okay, and I'm going to create my check. All right, and there it is. Our check's right there. So we'll click on CPU, and we can see that right now it says that everything's okay. And that's cool. We're going to leave this machine alone for a little bit. And one of the things that we can do is we can actually create a subscription. So in order to do that, we need to have a place for it to go. So let's go back to our command line. We don't need to watch this anymore. And we're going to create a listener on port 9999. And this way, if anything talks to port 9999, we can actually see that because Netcat is listening there. And we'll go back to Google Chrome and we'll add a subscription. And this subscription is going to say that we want to have a target. And we'll say the target will be, I don't know, HTTP 127.0.0.1 port 9999 because we want to do a web post. And it's going to be HTTP, right? So this makes sense. And we're ready to go, and we say everything is good, and then we add it. And you'll also notice that during the time when we were setting that up, we went to an error state because our value for the alert was over 98, which was over an error level of 95. So let's test this and see if it actually works. So we hit our test here. And now we go back over to our web browser, or to our terminal, and we can see that something was listening on port 9999, and that was our actual webhook, for lack of a better word, since we're just faking that out. And we were able to do an HTTP post, and we can see that we have all this JSON on the command line, which means that our siren can post to a webhook. And once we can post to a webhook, we can do whatever we want. I mean, we can do things already with things like PagerDuty and stuff like that that are built into Siren. But now, if I can post to a custom webhook that's wherever I want it to be, I can put a Python script, or I can do something that'll go into ChatOps, or I can do all kinds of things. And these are the things that make our data actionable. So in this section, we talked about measurement concepts at first. We talked about things like push versus pull and things like that. Then we took a tour of Graphite and we learned all the cool things that Graphite can do. Then we examined getting our data into Graphite using things like Bash or Python, and we looked at the way that those things could be useful. Then we looked at monitoring agent examples and how we could use configuration management to set up a monitoring agent that will feed data into Graphite. And finally, we looked at actionable data, a way of using the data that's already in Graphite to be able to make things actionable, to be able to tell us when things are wrong so that we can go and respond to those things. In the next section, we're going to talk about the final part of the CAMS model, the S, sharing. See you there. Hi, welcome back. In this section, we're going to look at the final component of the CAMS model, the S, sharing. We're going to take a look at Agile and how we can use Agile software development as a new way of delivering software. We're going to talk about learning reviews and how they're important for us to always get better. We're going to develop a little chatbot so that other people can see exactly what we're doing in our daily work. And we're going to talk about other sharing tools that you can bring back to your organization to help perform even higher than you already are. In this video, we're going to talk about Agile. We'll take a look at What is agile? What do we mean when we say that? We'll talk about waterfall, the way that we used to develop software. We'll talk about two agile methodologies, Scrum and Kanban, and then we'll look at an agile board as an example of the kinds of things that you would do if you were organizing your Scrum or your Kanban teams. And finally, we'll talk about retrospectives. So what is agile? Well, agile comes from a manifesto that was developed by a group of software developers who looked at the way that they had been developing software and said, it's possible that we could do this better. And the real heart of the Agile Manifesto we have right here in the middle of the screen, and we've highlighted it. So there's a couple of components here that we should talk about. One is individuals and interactions over processes and tools. This is collaboration, right? It's much more important that we work with the people that we develop our software with. We understand the things that are important to them. We understand the needs that they have when they're developing software. And we rely on those things in order to be able to develop our software. We don't rely on lots of process and all kinds of tools because we already talked about that tools are not that important. Working software over comprehensive documentation. We need to have working software because we want to be able to get feedback, the second way of DevOps, right? Having comprehensive documentation about something that doesn't even exist yet, what's the point of that? If we don't have working software, we don't have anything. So working software is more important. Customer collaboration over contract negotiation. The whole purpose of why we develop software, the whole purpose of why we come to work every day is to help our customers and to help our customers be successful, to make our customers successful. If we have a contract that says something and that thing is not as important to the customer as what we could be delivering, then we're doing the wrong thing. So working with our customers closely to make them successful is really important. And then responding to change over following a plan. It makes no sense to blindly follow a plan down the wrong path. This is why we call it agile, right? The ability to respond to change. We know that things are going to change over time. There's going to be failures along the way. There's going to be different kinds of software tools that come out. There's going to be all kinds of different things that can happen. And we need to be able to respond to those. We don't want to work with a plan that we developed 2 years ago when that plan is no longer relevant. The business is going to have needs that change. The customers are going to have needs that change. And we need to be able to respond to that change. So how do we used to do software development? Well, we used to do a project plan, and it was called waterfall. And with this project plan, we would say that the first thing that would happen is we would have product develop a spec. And then we would hand it off to development, who would do development on it, who would hand it off to quality engineers, who would hand it off to systems engineers, who would, you get what I'm saying. Handoffs, handoffs, handoffs. We've already talked about how those things are killer. Well, the problem with all these handoffs is that in the very beginning of the project, we estimate how long we think things are going to take. Now, if I estimate that development is going to take 3 months and development takes 4 months or 5 months, then what happens to the plan? Everything gets pushed back. So we were supposed to develop this piece of software and have it ready for our customers in a year, and now it's a year and a quarter or a year and a half. Why? What is the point of that? What are the benefits that we're getting out of doing that? And this is the problem with waterfall. Number one, humans are already bad at estimating, but when we already never hit our deadlines, not without a death march of people just working nights and weekends and all kinds of things like that, that's not really helpful to us. We actually don't want to burn our people out. What we want is to be able to respond to the environment that we're in. When things change, we want to be able to be agile and adjust to that. So how can we be more agile? Well, one way is to do Scrum. And Scrum is one of many agile methodologies. When we talk about Scrum, we talk about it being more prescriptive. There are more rules about how things go. We're not going to get deep into the roles here about what's a Scrum Master or a product owner or who are pigs or who are chickens. You can look up all those kinds of things when you look up things about Scrum. So the first meeting that we have in Scrum is called sprint planning. And in sprint planning, we time box our work. we say that we are going to work on a piece of work or a group of pieces of work for X amount of time. So maybe it's 1 week, maybe it's 2 weeks. We certainly don't want to start going much past 2 weeks or 3 weeks because, as we said, humans are bad at estimating. And what we do is we estimate how much work we think we can get done during the sprint. And we do something that's called story pointing. So if I'm going to stand up a virtual machine, I might give that 1 point. If I'm going to develop a new algorithm, I might give that 7 points. And after a while, we're going to start to get to understand how many points a team can do during a sprint. Another thing that we do is the daily stand-up. Every day we actually stand up. We don't want to sit down for these meetings. We want to stand up because we're going to talk about what we did yesterday, what we're going to do today, and if we have any blockers. And if we raise blockers, then the team should help to clear those blockers. And the reason that we're standing up is because we don't want these meetings to drag on or take a long time. These are not times for in-depth discussions. We can have those at other times. This is something that starts at the beginning of the day, and everybody learns about what everybody else is doing. They're sharing with their team, and everybody gets together to help. Because the goal is for the team to accomplish their goals, not an individual. At the end of our sprints, we do a sprint review. We talk about the work we got done. We do demos of working software, just like we talked about in the Agile Manifesto, and we talk about any problems that we had. The goal here is to review what we did in this previous sprint review. And finally, the sprint retrospective. This is an opportunity for the team to get better. At the sprint retrospective, we talk about the things that we could have done better, things that could help the team go faster, things that could help the team get more velocity. That's what we're measuring in Scrum. So if we're talking about Toyota earlier in the course and how they were never afraid to have people study them because by the time they copied them, Toyota would be very far ahead. This is what we're trying to get accomplished in the retrospective. At the end of a year working together, our team should be so much better as a team than they were at the beginning of the year. They should have much faster velocity because that's the aim of Scrum, trying to accurately as possible measure and deliver a certain amount of work for each sprint. And we're going to have a good idea because when the team is working together long enough, they'll start to get an understanding of exactly how much work they can deliver. Another methodology is called Kanban. Kanban is less prescriptive. The idea with Kanban is it's a 100% pull-based system. We have a backlog of the work that needs to get done, and as we finish work, we pull more work into the system. We're continually moving work through the system. That's the goal. And this comes from places like Lean and Toyota, where they do these kinds of things in manufacturing, where they're pulling work into the system. The best way to give an example of a Kanban system is this. I have a garden, and for people to go into the garden, they have to have a token, and I say I have 5 tokens. And every time somebody goes into the garden, they take a token until there are no more tokens left. And when there are no more tokens left, no one else can go into the garden. And when someone leaves the garden, they return a token, and the next person can pick up that token and go in. Because we can only have a certain amount of people in the garden at a time, in Kanban, we can only have a certain amount of work in progress at a time. And we have work in progress limits on how much work can actually be done. And the team, depending on how big they are and all kinds of different things, can decide what their work in progress limits are actually going to be. And the aim of Kanban is to measure cycle time. It's how long does it take from when work gets into the backlog before it gets into the done column on our Kanban board. And we're going to look at an example of a board in a second. This is a big difference from waterfall, where things have this cascading effect on downstream work. In Kanban, we don't pull work into the system until we're ready to work on it. It's not that we're not doing any planning, it's just that we're less confident about things as they go further out. So we can be pretty confident about shorter time frames, and we're much less confident about things that are further out. And by understanding exactly what our cycle times are in Kanban, or our velocity is in Scrum, we can start to get an idea of how long do we think things will take to deliver. Scrum and Kanban are much more about what is happening in more the immediate present. So we talked about Kanban, we talked about Scrum. They have walls and boards and things like that. So we're going to look at an example of that. So there's this tool called Trello, and Trello is not an agile board. It is something that is very close and very similar, and we're not going to get into the details of what a Scrum wall or a Kanban board would look like. But this is an example of what it would look like. And so we have our backlog on the left, we have our work in progress in the middle, and we have our done things on the right. And the idea is to move work through the system. So I can go down and I can say, okay, section 7, video 1. Okay, if that's complete, I'm going to move this over here to the right. And I can go over here and I can drag maybe section 8, video 1 into the work that needs to get done. And I'll put that here on the bottom. The idea being the things that are near the top are higher priority, the things that are near the bottom are lower priority. But the whole goal here is to have work moving through the system. The nice thing about having a board like this is that anyone can see it. Anyone can come and see what the things that still need to be done are. Anything can see what the work in progress is, and anyone can see what work has been completed. Whether it's my boss, whether it's my boss's boss, whether it's somebody on another team who has a dependency on some of the things that we're working on my team, everybody is able to see it. We're sharing this information across the organization. Everybody gets to see it. This is super powerful, and it's a big part of the S, the sharing, in the CAMS model. The last thing we're going to talk about is the retrospective. And like we've said in the third way of DevOps, the goal of any experiment is improvement. Every iteration that we do, whether it's in Scrum or Kanban or any other kind of agile methodology, is an invitation to get better. Every iteration is an opportunity for improvement. We can try new things. If we don't want to have a stand-up every day, maybe we want to try having that twice a week. Does that work better for the team? My team, one of my teams at work, actually this week said, we don't want to do Google Hangouts for stand-ups anymore. We want to do it in Slack. And I said, okay, try it. See what happens. See if you like it. Eventually, if you want to, you can go back to daily stand-ups, or you can go back to doing Google Hangouts or whatever. But the only way to get better are to run these experiments and get feedback. Over the course of the year, we should always be getting better. We should have lower cycle times or higher velocity or things like that based on the fact that we look back at the things that we've done. In the next video, we're going to talk about learning reviews, which are another kind of retrospective. And we can have learning reviews for all kinds of things, and we're about to find out what that means. See you there. Hi, welcome back. In this video, we're going to talk about learning reviews. We're going to talk about blameless postmortems. Wait, I thought we just called them learning reviews. We're going to talk about the root cause fallacy. We're going to discuss accountability in our learning reviews. Then we're going to talk about things called counterfactuals and biases, which can affect our learning reviews in negative ways. And we'll have a reference at the end for more information. So, blameless postmortems, and now we're calling them learning reviews? Why would we do that? Well, the reason is we don't want to have a review just when things go badly. What if we try to deliver a piece of software and it goes really, really well? Maybe we should talk about that. Why did it go well? What are the things that we did to make it go well? How do we do those things again? So blameless postmortems has this idea that something bad happened and now we have to figure out what was wrong. With learning reviews, we can talk about learning reviews for things that went well or things that went poorly. So there's a couple of things to think about when we're doing learning reviews. Number one, there's this idea of the root cause. And the root cause is a fallacy. There's no such thing as the root cause. When there's an outage, when things go wrong, everybody says, let's figure out what the root cause is. Well, is there really a single root cause? If we eliminate this root cause, does that mean that we'll never ever have a failure again? Maybe not that one, but we're certainly going to have other failures. Plus, there's never just one root cause that will eliminate any failures. There's all kinds of different ways that we can look at a failure. And failure is normal. Failure is a normal part of the way that we operate our systems. Nobody ever runs their systems without having failures. Google doesn't do it. Facebook doesn't do it. The fanciest DevOps unicorns still have failures. It's a normal part of the way that we work. Another problem with the root cause fallacy is that the root cause is relative. The systems engineers can blame it on the network engineers because that's what they see. But the network engineers could say, well, I'm going to blame it on my boss because my boss didn't get me the resources that I need. And then the boss is going to say, well, you guys don't understand because I didn't get you the resources you need because I don't have the budget. Everybody's idea of what the root cause is different. That's three different groups, syseng, neteng, and the neteng boss, who all have a reason why they know what the root cause is of the problem. So the idea that there's a single root cause which explains everything, or that we can just ask enough questions and we'll get to one single answer that makes sense for why something happened, it's not real. It's a fallacy. Another problem is, what does having the root cause resolve? Like, what if we find this single root cause? Does that mean all of our problems are going to go away now? Is it really that important that we find whatever this singular root cause is? Does that get us the thing that we want? Because what we want is to get rid of the errors. We want to find out how to prevent the errors from happening again. We want to characterize the problem, and we want to prevent that entire class of problem. And there's no way that finding a single root cause is going to eliminate an entire class of problem. So we need to understand what happened, and we need to be able to discuss that as a team so that we can get a better understanding of exactly what it would take to eliminate that kind of error. When we are having these learning reviews, it's important that we keep in mind this concept of accountability being different than responsibility. Accountability is exactly what it sounds like, being able to hold people to account, for people to give an accurate account of what happened. And in order for that to happen, people need to be free to talk. They need to be free to not worry that if they talk about what really happened, that they're going to be held responsible and be fired or be disciplined or something like that. We want people to be able to give an account of what happened. We want them to say, when the outage happened, I did this. This is what I was thinking. This is the information that I had. This is why I came to this conclusion. These are the things that I thought that other people would do. All these kinds of things are really important to be able to recreate in the meeting what happened during the incident. Or, in the case of something good, a success. We also, like we said, need to make it safe. Our goal is to get the facts, to prevent it from happening again, or to cause it to happen again if it's something that was good. But the goal here is not to assign blame. We want people to feel free to talk about what happened without obscuring any details, so it has to be safe. And these ideas of accountability and making it safe are part of something that's happening in our industry right now called just culture. And just culture is a culture that is just. We don't hold people responsible for things that went wrong because people make mistakes. That's normal. And people also operate with incomplete information and things like that. So it might not even be their fault that something happened. We need to look at the entire system. Everybody's operating in a system, just like we've talked about in the first way of DevOps. If somebody made a bad choice, let's look at the system. Let's figure out what it was in the system that led them to make that bad choice. And let's change that so the next time someone's put into that exact situation, they make a different decision. Because we can affect these things by applying systems thinking to it. How do we set up the system to prevent those problems from recurring? Maybe it was a bad hire. Maybe the person isn't a good fit for this kind of a job. Maybe we just didn't train them well enough. There's all kinds of different inputs into a system that can affect the outputs. It's ridiculous to think that if we fire somebody who was put into a certain part of a system, and then we put somebody else into the exact same bad part of the system, that we're going to get a different result. And most of us who study learning reviews and things like that don't believe that that's actually possible. Another thing we want in our learning reviews is to have empathy. because the people that are going to be giving their account of what happened, they made a mistake possibly. They might feel embarrassed. And we need to understand that. We need to understand that everybody comes from a different background. Everyone's going to bring a different perspective to the learning review, and they're going to bring a different perspective to their daily work. And some people may respond differently. Some people may respond the same, depending on their background, their experiences, things like that. It all depends on the person. But we need to have empathy for the people that are in the group that we're talking with, because that's the best way to ensure that everyone's going to be a full participant in the learning review. Another thing about learning reviews, aside from the things we need to keep in mind from the section that we just covered about accountability, are these things that can actually affect our learning reviews in a negative way. And there's counterfactuals and there's biases. Counterfactuals are recreating the past in a way that didn't happen. So if we use language in our learning reviews like, we could have done this, we should have done that, if only we had done this, we're using counterfactuals. And we need to train ourselves to recognize when we're talking about these counterfactuals. We're trying to create a past that didn't actually happen. If only we knew that making this change to the router would knock the entire company off the internet, we wouldn't have done it. Of course you wouldn't have done it if you knew it would knock the entire company off the internet. That goes without saying. No one goes in to make a change with the intention of knocking the company off the internet. That's not how we go into work. When we go to work, we have good intentions. We try to do the best job that we actually can. So when we say things like we should have or we could have, we're pretending that we would have had this knowledge in the past. But that's not true. That's not actually what happened. So we need to watch for these things in our learning reviews and catch ourselves if we see ourselves doing them. The other thing to watch out for are biases. And these are a normal part of being human, these cognitive biases. And these are only some examples of many, many, many biases. One bias would be recency bias. We tend to ascribe more value to things that occurred recently. We think that if something occurred recently, it's more likely to occur again. Whether that's true or not, that's just something that our brain does as a way of trying to make sense of the world. So that's a recency bias. There's also things like hindsight bias. This is just like we talked about with counterfactuals. Being able to look back, given the benefit of hindsight, and make a judgment. Well, that's great, but we didn't have that hindsight when the actual event occurred. We only have that hindsight when we know the result of what happened. So having this hindsight bias is not helpful to the learning review. And the last one we're going to talk about is the fundamental attribution error. That's the idea that when somebody else does something, it's because it's in their nature. Oh, the network engineers are careless. The systems engineers don't care about DNS. There's always lots of reasons why someone else is careless or they seem like they don't care. Lots of people go through lots of things in their lives. Maybe they had a fight with their significant other. Maybe they were up late working on something. There's all kinds of reasons why people would have a problem. But when we have the fundamental attribution error, we don't think about those things. We think that's just the way that they are. But when it comes to ourselves, then we have an excuse. Oh, I didn't have my coffee this morning. I didn't get enough sleep. So we have to keep these things in mind. Otherwise, they're going to creep in and they're going to affect the way that our learning review happens. We need to figure out how to affect the systems that we're working in order to prevent problems from happening again, or figure out how to affect the systems to make sure that the things that we accomplish that we're doing well do happen again. We want to have more success. We always want to get better. If you're really interested in this topic, I highly recommend this book, Beyond Blame, by Dave Zwieback. In full disclosure, I was a reviewer for this book. I have no financial interest in this book, but I think Dave did a really great job of covering this topic of learning reviews. In the next video, we're going to have some fun. We're going to talk about chatbots, and we're going to build our very own. See you there. Hi, welcome back. In this video, we're going to talk about chatbots. we're going to take a look at ChatOps. What is it? What's so great about ChatOps? Why are chatbots a part of ChatOps? We're going to create our very first chatbot, and then we're going to improve that bot a little bit to make it do some interesting stuff. So ChatOps. ChatOps means that whenever we're going to perform an operation, whenever we're going to do something like a deploy or anything like changing infrastructure by spinning up new instances, we're going to do that in a chat room. And you can use lots of different platforms for this. You can use IRC, Slack, HipChat, things that you can run yourself, things that you can buy. It's not really important what platform you do it on. It's important what you do with ChatOps. And in ChatOps, the bots themselves are the things that perform the actions. The bots are the ones who deploy the code. The bots are the ones who adjust the auto-scaling group to allow 3 more instances. It's commands that we give to the bots that allow them to go and do those things and know what they're supposed to be doing. The bots are there to help us all the time. The great thing about doing stuff in a chat room with a bot is it's visible to everybody. Everybody can see what happened. If I do a deploy and things go badly, people can look at the chat room and say, oh, Dave did a deploy. That's why our numbers are going down right now. When did he do it? Oh, there's a timestamp on that deploy because it's in the chat room. Well, what did he deploy? Oh, he deployed this revision number? Okay, what other things were people deploying at that time? There's an entire history there of what happened that everybody can see. And they can actually go back in time. Like if I wanted to know what happened last Tuesday, I can go back to last Tuesday and see exactly who did a deploy at 3 o'clock in the afternoon to this application and what revision did they put out. All that stuff is available when you're using ChatOps. It's very, very powerful for sharing and for learning. If I'm a new member of a team and I want to know how do I deploy app foo to production, I can actually look for app foo inside chat and see how did people do this in the past. Or I could tag along with someone by just watching what they're doing. They don't even know that I'm tagging along with them. This is so much different than in the past when someone would sit down for their first few days on the job and read documentation and learn how they're going to do things on their day-to-day jobs. Because with ChatOps, everything is continually being documented. It's always there for everybody to see. We're going to make our first chatbot, and to do that, you might need a few things. We're going to make a Slack bot today, so if you don't have a Slack organization, you can go to slack.com and sign up for a free one, and that'll allow you to follow along with what we're doing. We're going to use a bot called Limbo. So there's this GitHub repository here with Limbo, which we're going to use in about a minute. And you should also have the GitHub repo for this course because I've got a plugin for the Limbo bot that we're going to use. So you might want to have that available. So let's get started. We're going to go over to our chat bot here, and we're going to see that it's called Limbo. And in order to get started, we're going to need to clone or download. So let's clone it. And we're going to go to a terminal. And in the terminal, I'm going to say, of course, git clone. And I'll pull that down. Now, while that's coming down, let's go look at the documentation here. So the documentation says, in order to run it, I'm going to create a bot user if I don't have one yet and copy the API token. Well, I already have a bot user ready, so let's go find out what its API token is, shall we? I'm going to open this in a new tab, and we should have Slack come up and show us that we have a bot available. Okay, and I'm going to choose bots, and I already have a bot here called W.E. Deming. And W.E. Deming is for W. Edward Deming. He was the man who brought lean manufacturing to Toyota and is a huge influence on the DevOps movement. So let's copy the token we have here at the top. And for those of you who are security minded, don't worry, I will regenerate the token as soon as we're done with this recording. But we're going to take that back, and it says that we need to export capital Slack_token. So let's go do that. Okay, export Slack underscore token. And we're going to put our token in here. And then we're going to go into the limbo directory because this is where the software is. And we go back and it says all we have to do is say make run. All right, that seems pretty easy. Make run. And it's going to see I've got all my requirements and it starts up. So let's go and check it out. I've got my Slack room open here. And there we are. We have W.E. Deming. He's a bot that's in our room. So if I say help, then the bot should answer me back and say, hey, here are all the things I know how to do. Oh, well, that's kind of cool. So if I wanted to say commit, I can probably get a funny commit message. Insert your commit message here. Oh, okay, thanks. It's not that useful. Maybe you say something else. Oh, I'll explain this when I'm sober or revert it. So, that's kind of cool, but we don't only have to do funny things or silly things with our bot. We actually, like we said, we want to use our bot to get actual work done. So let's go back and see how to do that. Right here, I've got a couple things, but the important part is under Limbo, there's a plugins directory. And if I put things in this plugins directory, I can execute my own plugins. So I've got something ready to go here. I'm going to copy the deploy.sh or deploy.py rather into there. And that's not where it is. So deploy.py to work, limbo, plugins. So I've got this thing ready here, and I'm going to copy my plugin into work, limbo, plugins. And now if I go back to here and I do the same command that I did, you should see I have a deploy.py available. So let's start our bot again. We go back, we do a make run. And now when I go back to my room where Deming just showed up again, and I do a help, I should see that I can actually do deploys. So let's deploy an app to production. If I say deploy, and let's call it foo, then it says deploying app foo with hash to production, IP 192.168.50.123. Well, that's kind of cool. What actually happened inside these deploy plugin? Well, it's actually pretty simple, and we kind of faked a couple of things out. So this is just a little bit of Python. It says when we get this message that has deploy, then we want to take the app that we want to deploy and we want to send that into this deploy function. And we match the first thing that matched here inside of our regex, and we're going to deploy this app. We're going to take the app, we're going to encode it, we're going to take an MD5 of it, we're going to open up a list of hosts that we have running on the cloud, maybe on AWS, so that we would know where we're going to deploy this thing to. And we're going to say we're deploying app, the app name with a hash, which we just calculated, to production IP, the IP address that we have in that host file. Now, obviously, we can do other cool things in here. We could send a packet to Graphite that says we're doing a deploy. We could copy things to AWS and restart daemons. It's really up to us. Once we have the ability to do things inside this Python script, we can do whatever we want to do, whatever our capabilities are, because it's just software at that point. So that was really great. And like we said, one of the best things about having a chatbot and doing things with ChatOps is that other people on our team can see exactly what we're doing. Someone could look and say, oh, that's exactly how Dave deployed this foo app. And they're learning, and they can copy that, and they can repeat what I did, and they can show other people. And I actually had documentation right there in line. If I said, bang help, it showed all the different capabilities that are available. So people can actually explore and learn and add new things and give it more capabilities. In the next video, we're going to talk about other sharing tools that you can bring back to your organization to help with the S in the CAMS model, sharing. See you there. Hi, welcome back. In this video, we're going to talk about other sharing tools. This is also the last video of this section. We're going to talk about documentation. What should we do with it? Where should it live? We're going to talk about the idea of a monorepo, which is something that's practiced by like Google and Facebook. We'll discuss retrospective artifacts, which is a hack that I developed with some people at salesforce.com, which they've taken on to other places with much success. And we'll talk about the idea of conferences, brown bags, things like that. And it's important to remember that these are only some examples of things that you can do for sharing. So, documentation. Well, documentation is a really important part of what we do when we develop software. If people don't understand how to use our software, they don't know how to consume an API, then they're not really going to use it, and they're going to have a really hard time. Not everybody wants to go and read all the source code to understand the things that we've developed. So we need to make documentation an important part of the development process, not an afterthought that comes later. If we make the development of documentation a separate thing than the development of the software itself, then it's very easy for them to get out of sync. If we practice things like continuous deployment or continuous delivery, this is an even bigger problem because we're developing and releasing software so quickly that often we forget to go back or we don't make enough time to go back and write the documentation. So one way to make sure that the documentation is kept up to date with the software is have it live with the code, mostly. So if it's a getting started guide or something very general, then okay, that could live somewhere else. Perhaps that could be with some published documentation for the customers. But otherwise, the documentation itself should live in the exact same code repository as the code. We want to make sure that when we're developing code, we're developing the documentation. So much so that the best documentation we can do lives in the code. So if you've ever done something like PyDoc or PuppetDoc or something like that, you can actually write the documentation in the code itself. As you change the code, you change the documentation. You say, I'm going to add something to this method, and then you can actually go into the documentation and say, this method takes an additional argument of type integer or whatever you have to do. But this way, at any point in time, you can always generate the latest code. And you can always generate the latest documentation simultaneously. And this is really important for keeping the documentation and the code in sync. Another thing that people do as part of sharing is monorepos. In a monorepository, all the code for all the projects lives in a single repository. All the code is visible to everybody. So we don't have a lot of different repos for different services. If you check out the code for a service, you're checking out the code for everything. And you can see anything that you actually want, which is really important. Because it means that you can inspect anything, including the documentation that we just talked about in the last section. And this is especially important with now that people are doing things like microservices. Because if I have a contract with a microservice that you're going to return me this or that, and I have some kind of SLA, then if I need to understand the code of what you're providing to me, I can easily do that if I have access to all the code that's necessary. I don't have to go searching for where is this or where is that. This is one way to ensure that we have the best communication possible. And it allows us to also use our standard tools. For example, if I'm used to working in an IDE, then I can use that IDE to search through anything that I need to in any repository that's part of this monorepo, and it'll allow me to actually do things that I'm very comfortable with. So I don't have to go and import 50 different repositories to keep track of things. I just do whatever I need. Another advantage of having a monorepo is that we can use our standard tools. So for instance, if I'm used to working with an IDE, I don't have to go out and check out 50 different projects or anything like that. I can go and search through the repository with the tools that I'm accustomed to using. And if I can do that, then it makes it really easy for me to understand what other code is doing. I can share everything in a monorepo that's required to operate the website. One hack that I developed with Greg Oman when I was at Salesforce with him was at the end of every sprint, we developed retrospective artifacts. So we did a retrospective. We demonstrated our working code, and we gave a demo, a short, less than 5-minute demo that we recorded as a screencast. We took that screencast and we published it internally on a salesforce.com website, like a wiki that was internal to Salesforce. And it doesn't matter where you publish it. You can publish it on GitHub or Confluence or whatever you have that's good for you. The nice thing about publishing your retrospective artifacts at the end of every sprint is anybody can see what your team is working on. If it's a vice president, if it's a project manager, if it's another team that has a dependency on what you're doing, anybody can go anytime they want. It doesn't matter what time zone they're in. It doesn't matter if it's 3 days later, and they can see exactly what you've been developing. And this is a lot like we've talked about in the second way of DevOps. We're getting feedback early and we're getting feedback fast. We don't want to wait to get feedback. If another team is relying on my team to develop some API functionality that they're going to consume, and they look at our retrospective artifact where we've gotten our minimum viable product working, the most basic thing that actually allows us to learn something, and they look at that and they say, oh no, that's absolutely not what we were asking for, I'd much rather find out about that after the first week than after the first month or 2 months, or when we finally walk up to them and say, hey, we're done, this is great, and they say, no, that's totally not what we need, you built the wrong thing. So having these retrospective artifacts and making that signal of what we've developed clear and easy for everyone else to consume early in the process is a great way to share. And the last thing we're going to talk about, and certainly by no means is this the last possible way that you can do sharing with DevOps, are conferences or brown bags or things like that. Things that are designed explicitly for sharing. And these conferences or whatever you're going to do can be big, they can be small, they can be formal, they can be casual. The important thing is that you have them organized in a way that allows people to not only share what they're thinking, but also open up for discussion. And at Salesforce, we used to do something that we called the Internal DevOps Mini Conference. And we got this idea from Damon Edwards, one of the originators of the CAMS model. He gave a talk at DevOps Days Rome where he said, hold an internal mini conference. And we did. And people would get together and they would talk about pains that they were having. They would talk about projects that they were working on. They would talk about successes that they had. All kinds of things that allowed people to communicate and share with other people. And the parts of the conferences that we had that were actually driven by the conference attendees instead of speakers who stood up were the most popular parts of the conference because people got to share what they were thinking and they got to share their ideas with others. If we're going to do these conferences or brown bags, we have to remember to make it safe. Just like with retrospectives. What we're trying to do is we're trying to increase flow, right? We're trying to get better. We're trying to have these ideas of Kaizen. We're trying to grow. And people need to feel like they can share their frustrations. They need to feel like they can be honest with the other people that they're working with. And that's one way to have a successful conference. The other thing you should always try to ensure is diversity. Diversity is strength. Different kinds of people on your team make them stronger or better. You want to have people from different backgrounds. You want to have people from different experiences. You don't want to have all men on your team. You don't want to have all white people on your team because different kinds of opinions or different kinds of backgrounds lead to different kinds of discussions with more ideas, better ideas. They actually make you stronger. You want to hear from all the different elements. You want to hear from different disciplines. I want to hear from network engineering and systems engineering. I want to hear from the women engineers. I want to hear from anybody that has something to contribute that isn't just all the same ideas that everybody else has contributed already. Diversity is a huge part of DevOps. It's a huge part of sharing, and it's a huge part of making your company successful. Ignore diversity at your company's peril. In this section, we started off talking about agile and the different methodologies in agile and some examples of agile boards. Then we went on to learning reviews and how to have a successful learning review so that we continually hold this concept of Kaizen, of getting better all the time, as a core part of how we operate our company. Then we went on to talk about chatbots and how people can see what's happening with a chatbot, and we actually built our own chatbot, which is really fun. And lastly, in this video, we talked about other sharing tools. In the next section, we're going to talk about where do I go from here. You already have a strong foundation in DevOps at this point. In the next section, we're going to discuss more advanced topics that we can now finally understand because we have that strong foundation. See you there. Hi, welcome back. In this section, we're going to talk about where do I go from here. We're going to talk about security and quality engineering and how they fit into DevOps. Talk about the role that compliance plays in an organization that practices DevOps. We'll talk about sales, marketing, and beyond, parts of the organization that we traditionally haven't talked about in DevOps. And last, we'll talk about how to become a learning organization and get some resources that you can use to expand your DevOps knowledge even further. In this video, we're going to talk about security and quality engineering. In this video, we're going to take a look at, is DevOps more than just dev and ops? We're going to talk about the role that quality engineering and security can play in the development of our software, and then we're going to look at some examples of what they can do. W. Edwards Deming. We named a chatbot after him. The chatbot wasn't really so focused on quality, but W. Edwards Deming was. He was famous for bringing quality as a mindset to Toyota manufacturing. And he had a quote that we really like. Cease dependence on inspection to achieve quality. Eliminate the need for inspection on a mass basis by building quality into the product in the first place. What Edwards Deming was saying is that we can't inspect quality in afterwards. We need to make that a part of the way that we develop our software. We talked about in the second way how we feed back things about the way that our software runs into development. This is an opportunity to feed quality back into the way that we develop our software. We want to deliver a quality product to our customer. We can't be like the old days where they'd say, we develop our software and it's ops problem now. In the same way, we can't say, well, we developed our software, it's quality engineering's problem now, and they're supposed to make a quality product out of what we delivered to them. That can't happen. You can't put that in at the end. We need to have quality engineering involved from the very beginning. They can do things like design reviews. When we're designing the software, when we're designing the system, how do we handle failures? What inputs are we supposed to expect? What inputs would break things? How are we going to test those kinds of things? If the user does this or the user does that, how do we expect the software to respond? We need to incorporate quality in from the very beginning in the design of what we're actually going to build. And then we're going to put that quality engineering mindset into our continuous delivery pipeline. The quality engineers are the experts in testing. When we're doing continuous delivery or continuous deployment, we're just maximizing the automation of our testing as much as possible, and the quality engineers are experts in that. Does that mean they can't do exploratory testing as well? No, but we want to have them involved as early as possible, and the beginning of our continuous delivery pipeline is about as early as we can get, except for maybe the design review. So we want the quality engineering teams to be involved in helping us to build the CD pipeline. They're the experts on how to maximize the return that we're going to get out of the investment that we make into continuous delivery. They can also help with things like test design. How do people write their tests? When people write their tests, we want to make sure that we're testing the right things. The quality engineering teams can help us with design. They can give advice. They can be real partners in software development. If I have operations people who are trying to write unit tests or integrations tests, or if I have developers who are trying to write unit tests or integrations tests, and they're not sure about what the right way to test something is, there are experts who know how to do that. So get quality engineering involved early in the process. And the last thing that they can be involved in, among other things, is destructive testing. So places I've worked, we did destructive testing with quality engineering before any service went live. And they had a checklist. And the checklist would say things like, this is what it looks like when it's operating normally. This is the failure that we're going to induce. This is the expected behavior for that failure. And this is the observed behavior for the failure. Nothing goes to production without destructive testing. We know it's ready because we tried breaking it first. And if it responds correctly, then that's great. And if it doesn't, then we go back and we try to fix it so that all of our failures are expected failures, at least for the things that we thought about. We don't want to find out that some piece of software is broken or it's misbehaving once it's in production. We already know it's way cheaper to find things during development and as early in development as possible. And destructive testing is also an opportunity to get operations involved, so they know what the remediation steps are if there's things that need to be fixed by people in operations. They can practice things, they can see it, they can understand the documentation. So destructive testing can be an important part of having quality engineering involved in the process. But what about security? Well, Tahir El-Gamel, the father of SSL, said, security is just an aspect of quality. Just like quality engineering, we need security to be involved throughout the development. We don't have a quality piece of software if it's vulnerable to exploits, or it can crash based on user input, or it reveals passwords, or it leaks things from the database. That's not quality software. We don't want downtime for our customers. So security needs to be built into the product just like quality engineering builds things into the product, because security is just an aspect of quality. So again, security can be involved in design reviews. They can say, we are not allowing any passwords in plain text to be on the disk. You can't pass passwords on the command line because if you're on a Unix system and somebody does a PS, they could see your passwords. They can mandate, this is how we're going to build our firewalls. This is where we're going to need strong authentication or strong authorization. All those things can be important parts of the design review. We want a high quality system that's resilient to attacks from the very beginning, which means we also can have security involved in the continuous delivery pipeline. Security should have a voice there. They should be running automated security tests, just like we talked about when we talked about continuous delivery, as part of the continuous delivery pipeline. One of the things they could run there are static analysis tools. They'll do an analysis of the code, and they'll find out whether or not that code is vulnerable to a well-defined set of tests. And this is important because you can actually feed back the results of that analysis to your developers and say, this is a class of problem that we noticed that's in your code. Here's how you resolve that class of problem. And then all of the quality of the code that's going through this continuous delivery pipeline is going to be better, of higher quality, more secure, more resilient. Another part that security can be involved with is artifact integrity. Is the software that I'm testing the same software that's being deployed to production? We can do things like signing our artifacts. We can do checksums. We can do all kinds of things. If I have a Docker container, is it the Docker container that I use in dev and test the same Docker container that I use in production? This integrity of these artifacts is super important because we want to know that we have the quality software that we tested as the quality software that's running in production. We don't want some kind of, oh, well, we made a bunch of changes after it came out of development and we're going to do this different piece of software in production because we don't know how that software is going to behave, and that's not necessarily quality software. So we had DevOps, and now we're going to have quality engineering involved, and we're going to have security involved. So does that mean that we need a new name? Are we going to have DevSecQualOps or something weird like that? No, we don't need anything like that. DevOps is DevOps. It's more than just development and operations. DevOps is an entire organization trying to deliver high-quality software to production. there are lots of opportunities for different parts of the organization to be involved. And we're going to talk about some of the other parts of the organization that can be involved in the next video when we discuss compliance. I'll see you there. Hi, welcome back. In this video, we're going to talk about compliance. We're going to take a look at auditors and what the role of auditors are when they come in to audit our organization. We're going to talk about configuration management and how configuration management can help us when we're getting involved with an audit. And then we're going to talk about an aspect of compliance called separation of duties. PCI, DSS, SAS 70, FSMA, there's all kinds of compliance standards that people have to comply with in their companies. These are only the American standards. There's standards for the EU, there's standards for Australia, there's standards for all kinds of different government regulations all over the world that people have to comply with. When an auditor comes into our organization, they have a few questions that they really need to ask when they're trying to assess the org. The first question they ask is, does it meet the standard? Are the practices that we're doing, are the things that we're doing, are they meeting the standards of the compliance? Are we doing things the right way? Do we have things turned on when they should or turned off when they shouldn't? If not, what's the remediation steps? What are the things that we're going to do to ensure that our infrastructure or whatever process they're measuring will become into compliance, right? We don't want to fail our audit. That's a really terrible thing for the business. And lastly, if we are failing and we say that we have a remediation step, can we prove it? Or if we're not failing and we say that we're doing something, can we prove it? And this is a tough problem to solve, right? If we have a big organization, we could have thousands of machines. How are you going to do that? Normally what would happen is the auditors would come in, they would ask a few questions. You would say, yes, we are in standard for this, we're out of standard for that. And then you would show them a couple of machines that are supposed to represent the larger infrastructure that you're running. And they would inspect them and they would say whether or not these machines that you looked at match what you said. But you don't really do things the old way anymore, right? Now we're practicing DevOps. Well, what's different about that when it comes to auditing? Well, it could be something like this. Do you remember this? This was our configuration management code that we had a number of videos back, and this set the number of open file descriptors on our host. Well, standards are very much like this. Standards are often about, what is this set to? Is this service running? Do we have this securely locked down? All kinds of things like that. Those kinds of things are what configuration management is actually good at, right? Configuration management is a compliance engine. When our configuration management code is evaluated by the configuration management software, it goes through and says, what am I supposed to be? Am I this? Yes or no? If I'm not, correct it. If I am, move on to the next thing. Configuration management is a way of ensuring compliance. It's a way of ensuring that something complies with the definition. So, if our auditors come in and they say, can you prove it? I say yes. And I've got the automated tests that run every single time I check in code that can prove it. This is something that isn't an afterthought for our organization. This ensuring that we are in compliance with the standard is a part of how we run our business. We do it every single day, all day long. You want reports? I can generate you reports. I can show you that our configuration management code is proving that we are in compliance with the standard. I can give you reports from my production systems that shows exactly how many problems that existed on the production systems were remediated by the configuration management software. And I don't have to do this across a small representative sample of machines. I can do this across hundreds of machines, thousands of machines, tens of thousands of machines, and prove to the auditors that yes, I am definitively in compliance. I can go one better than that. I can show you that I have cryptographically signed continuous delivery pipeline is signed cryptographically. That proves mathematically that this software that I said meets these standards is actually the exact same thing that I have out there in production. And this is one of the great things about understanding DevOps. We can now apply the principles that we've learned in this course to problems that we encounter every day. So let's look at another example of applying DevOps thinking. There's this standard in the United States called PCI DSS, which is about personal information that's associated with a credit card. And one of the things that's inside this standard is something that they call separation of duties. And most people think that when we're going to implement separation of duties, that means that we need to have multiple people who are executing things so that one person is this duty and another person has that duty, and there's separation of duties. But separation of duties is not what people think. If we look at the guidance for separation of duties that comes from the PCI standard, it says, in environments where one individual performs multiple roles, duties should be assigned so that no one individual has end-to-end control of a process without an independent checkpoint. It doesn't say anything in there about we have to have multiple people or that each person has to have different roles. It says that no one person can have end-to-end control of a process without an independent checkpoint. That means that that independent checkpoint has to be satisfied in some way. Can the independent checkpoint be another person that performs that role? Sure, but this doesn't say that it has to be that. We know in DevOps that we're trying to optimize flow. As part of that optimizing flow, we have our continuous delivery pipeline. So, if I want to have an independent checkpoint, maybe I can build that into the flow of my work. Maybe I can make that a part of the way that we develop software. So, cryptographically signed code reviews. Maybe I develop my software, and as I'm developing my software, I get to a point where I'm ready for a code review. Okay, I check my code in, and I take my token or whatever way I want to do it, I put it in a machine, and I cryptographically sign that code that I'm submitting and say that I am the one who developed this software. I'm verifying mathematically that I'm the one who developed the software. When someone goes to code review it for me, they review the code, they look through it, they make sure I'm not capturing credit cards and sending stuff to my personal bank account or any of the other things that are required. And then they get out their cryptographically signed key and they apply that to the actual code review. And they're assessing that I am the person that is the one who reviewed this and nobody else did this and no one else has tampered with this. And when they do that, now I have a mathematical proof that an independent checkpoint is happening. We're going to do a code review anyways. So with DevOps, we can look at other ways to solve our problems that satisfy these compliance requirements. What about continuous deployment with automated tests? Can I have an independent checkpoint there? Well, if I only have a single developer that wrote all the tests, then yeah, maybe there's not an independent checkpoint. But if, like we do in DevOps, I collaborate with performance engineering and the quality engineers and security and people like that, and everybody contributes tests that are going to be running as part of our continuous delivery pipeline, then I do have independent checkpoints. I don't have a single person who is exerting end-to-end control over the entire process. That collaboration with other people can give us independent checkpoints. These are things that we can actually plan for. If I'm running static analysis on my code, that is a checkpoint that I did not control. That is not something that I put into the software delivery pipeline. And this is another way to satisfy compliance. It's just like that old expression about Perl. There is more than one way to do it. With compliance and DevOps, there's lots of different ways that we can do stuff. And with DevOps in general, when we're trying to accomplish things, there's lots of different ways we can do stuff. That's why we say, don't get too attached to your tools. The tools are not what's important. It's the thing that we're trying to accomplish that's important. When we look at the principles that we've learned with DevOps and the 3 ways and the CAMS model, and we apply those to the way that we're developing our software, we can still optimize the delivery of high quality software into production, no matter how many different compliance standards we're actually required to meet. We've talked about security, we've talked about quality engineering, we've talked about audits and compliance. In the next video, we're going to expand upon that even more when we talk about sales, marketing, and beyond. I'll see you there. Hi, welcome back. In this video, we're going to talk about sales, marketing, and beyond. This is the video where everything comes together, where we're going to rely on everything that we've learned and how to apply DevOps throughout our organization. We're going to start by taking a look at the first way and make some adjustments to the way that it was described. We're going to talk about the system of a company, and then we're going to talk about a new vision of DevOps. So you remember the first way. It emphasized the performance of the entire system. And in this representation, Gene has the system going from dev to operations, where development represents the business and operations represents the customer. Well, I think that Gene got it just a little bit wrong. I think a better representation would be going from the customer through the business to the customers. If the goal of why we're here, if the goal of why we go to work every day is to give the customers the things that they need, to give the customers the things that they want, then the real input to our development or the real input to the business is what the customer wants or what the customer needs. And usually when we're talking about DevOps, we have the usual suspects: Dev, Ops, QE, security, but I think we're leaving some people out. I think we're leaving out sales, and we're leaving out product and product marketing. I think those people are really important to the success of our company, especially with DevOps. I think the real start of the system, the head of the system, is sales. It's the people who are talking to our customers. It's the people who are determining what the customer wants and what the customer needs. Those are the people who understand what we need to deliver. Sometimes the customers don't even know what they need, but the sales and the marketing people, the product people, those are the ones who have to understand that. And they feed that into the system. I have a friend who's in sales, and he's so good at his job that when he calls up a customer on a Monday morning, he can tell within the first few minutes whether or not he should try to sell something to that customer based on how that customer decides to describe their child's baseball game from the previous weekend. If the baseball game did not go well, he'll say, "I'm sorry," whatever, and he'll get back to them another day. That means that these people really understand their customers. That's their job, to truly understand their customers. So, if our salespeople are talking to their customers, they can find out what their customer wants. They can take that to product and feed that into the product organization, who will go and negotiate with a development organization and with operations and say, how much time would it take for you to deliver this feature that our customer really wants? Our engineering team lead can go and look at her sprints and her team and say, we can deliver that feature in 6 weeks. And as they go through those 6 weeks, they'll post their sprint review artifacts on their wiki. And during that time, they'll get feedback from development and marketing and operations and sales. And they'll make adjustments as they go, because they know that these sprints are times to run experiments, just like we talked about in the culture of experimentation. And because all the testing is automated, this goes very, very quickly. And they can even get to a point where they can feature flag the customer on to try the feature and get feedback early in the process, right? This is the second way. And in the end, they can deliver exactly what the customer wanted. This makes for happy customers. This makes for a business that's high performing and exceeds their competitors in market capitalization, just like we learned in the beginning of the course from the DevOps survey. In the end, DevOps is not just dev and ops. It's the entire organization being optimized. So, the next time somebody writes to you and says, "I'm sorry to bother you. could you please point me in the direction of the person in charge of DevOps? You can write back and say, hey Jerry, we're all in charge of DevOps. In the next video, we're going to talk about some resources you can use to become a learning organization. Hi, welcome back. In this video, we're going to talk about becoming a learning organization. This is the last video in this section, and it's also the last video in the course. We're going to take a look at what is a learning organization, where does that term even come from, and then we'll discuss some further resources that you can use to continue in your DevOps journey. We start with a quote from Andrew Clay Schaefer. He says, "You are either building a learning organization or you will be losing to someone who is." That sounds compelling. We know that part of the reason that we're practicing DevOps is to beat the competition. Another part of DevOps is ensuring that people are happy at their jobs, and we talked about how that's a virtuous cycle that feeds into itself. So what is this learning organization that Andrew's talking about? Well, the term comes from a book called The Fifth Discipline by Peter Senge, and he says that an organization that's a learning organization has multiple components, and the combination of all these components makes a learning organization. The first component he discusses is systems thinking, which is something that we already have a pretty good background in. We're trying to optimize flow through the entire system, right? We're trying to look at the system as a whole. In the learning organization with systems thinking, we look at and we measure the different components of the system. We don't want to have local optimizations, right? We want to have global optimization. And looking at the system as a whole is an important part. The next component is personal mastery. This is the idea of individuals learning and getting better all the time. They're leveling up. This can be training from the company, or it can be things that people learned on the job. But we've talked about this, right? The idea of self-improvement. If we have lots of individuals who are doing that, then they can go out and beat the competition. The third component is mental models. Inside of our organizations, we have shared knowledge. We have ideas about how things should be done, and we have ideas about how things are done. And as part of having these mental models, we need to continually challenge the existing ways of thinking about our work. But we have to make it safe. We don't want these challenges to be confrontational. We want the ability to do things like run experiments, the third way of DevOps, and see what works. The fourth component of a learning organization is to have a shared vision, to have common goals throughout the organization for people to strive for. We can't have different parts of the organization having distinct goals because those goals could be in conflict with one another. If we're going to beat other organizations, that could be a shared vision. There could be more lofty goals for the organization, like a happiness quotient or things like that. But this idea of a shared vision is part of being a learning organization. And the last component is team learning. The idea is the entire organization gets better as a product of the personal mastery, the individual learnings that people have. And we now have lots of tools that we can use to thrive in a learning organization by applying DevOps principles. If we want to get better, if we want to have better personal mastery, which leads to better team learning, here are some recommendations I have for you for materials that were used to make this course. If there's one book that you can recommend to people, it's the IT version of The Goal by Eliyahu Goldratt. The IT version is The Phoenix Project, and you'll notice that the lead author is our old friend Gene Kim. The Phoenix Project is written as a novel, and it's a great way to introduce other people to the concepts of DevOps. Whether they're executives or people who are skeptical, they can use this book because it's very, very accessible, and it leads you through the concepts of the three ways. No discussion of DevOps could be complete without the Continuous Delivery book by Humble and Farley. This is the Bible of continuous delivery. It gives you lots of tools to think more deeply about DevOps and continuous delivery, much more than we've discussed in this course. Yes, this book is long, but it's very, very worth it. When talking about systems thinking, of course, there's the fifth discipline by Peter Senge, but there's also Thinking in Systems and Toyota Kata, and both of those books are excellent resources to give you more academic ways to think about the problems that we're trying to solve. For things that are available online, you can definitely subscribe to the DevOps Weekly newsletter published by Gareth Rushgrove. He does an amazing job every week of collecting resources about DevOps, either new tools that people are using, new articles about ways people are thinking about DevOps. All kinds of different content is in there, and it'll show up in your inbox every Sunday. It's fantastic. And we referred earlier to the DevOps Cafe podcast, which is one podcast among a number of podcasts that are put on in the DevOps community. The DevOps Cafe has excellent guests. Some of the most important things that I've ever learned about DevOps, I've learned from the guests on the DevOps Cafe podcast. And that's done by John Willis and Damon Edwards, the people who brought you the CAMS model. And lastly, get involved. There are DevOps Days events that happen all over the world. They happen on almost every continent, probably not Antarctica. But the idea of having DevOps Days locally instead of one big conference, that's by design. That's the way Patrick Dubois, the godfather of DevOps, wanted the community. He wanted everyone to be able to be involved on a local level. And now that you've taken the time to do the course, now that you've taken the time to learn, you are now part of the global community of DevOps practitioners. So I encourage you to get involved, participate, organize, attend, learn, discuss. Be an active member of the global DevOps community. In this section, we talked about security and quality engineering and how they fit into DevOps. We talked about compliance and how we can work with our auditors and show them the things that they want to find out by applying our DevOps principles. We talked about sales and marketing and how other parts of the organization can be an important part of the delivery of quality product to our customers. And lastly, we talked about becoming a learning organization. In this course, we talked about the 3 ways of DevOps from Gene Kim. We talked about the CAMS model with culture, automation, measurement, and sharing. And finally, we talked about next steps that you can take to advance yourself on your DevOps journey. In this course, we talked about the 3 ways of DevOps from Gene Kim. We talked about culture, automation, measurement, and sharing. And finally, we talked about the next steps that you can take to advance your knowledge of DevOps. But it doesn't have to end there. You can keep the conversation going. Here is my Twitter handle, @DaveMango. I would love to get feedback, the second way of DevOps, from you about the course. What are things that I could have done better? What are things that went well? What are things you thought about? I would love to hear from you and have an online retrospective about the course. Feel free to @mention me on Twitter, and I'd love to be able to engage in conversation with you about the video course. And finally, I just want to say thanks. Thanks to my editor, Nitish Shetty, to the reviewers who reviewed the course, and most of all to my family who stuck with it throughout the entire development and recording of the course. I really enjoyed working on the course, and hopefully you enjoyed going through it with me as much as I enjoyed making it. Thanks for participating, and I wish you much luck and success on your DevOps journey. Bye.